That's what you said.
Well,
So this is
the
how
way
we see
that you're
stars.
trying to explain them as corpuscular rays, no, we don't see the stars as corpuscular rays.
We weren't even talking about that. I showed a picture that shows how we see the stars. You said that's not how we see them, so I went and showed actual star trails. So anyway, and of course, look how wide this angle is right here.
Okay.
You see two different motions. So if anyone understands basic things, you obviously can't see two different rotations if you're looking in one direction, and it's because the spin of the Earth. You would have to turn towards a different direction.
What has that got to do with them existing? Explain how there's two of them existing.
Wait,
we're gonna get to that, buddy. So anyway, so
what do you mean by one direction? That doesn't make any sense.
So we all agree this is actually how we see the stars, and that girl is wrong.
Sure.
Arma, say she was wrong.
If you look west, you can see.
This is how I know.
And also, don't tell me what to say, all right? Because I'm tired of this whole like, oh, do this or whatever, right? Like I'm my own guy, all right?
Honest, you guys are. So she blatantly was wrong. She said that that's not how we see the stars, and we clearly do. Everyone knows that you can take star trails, you can see the straight lines, and then you can see the two different rotations side to side.
No, the context
of that is just laughable.
No, the context was you showed a Mercator map, and that's when she said we don't see like that, whatever. It was supposed to be the Mercator map getting up.
That's the map I was comparing.
This is how I know you're dishonest, right? Because you're now becoming a
She literally said it on the Mercator map. All right, I'm keeping track of this.
You didn't see anything about a Mercator map?
No, you had the Mercator map
on screen.
You had it. Yeah, you had the picture.
We see the stars.
Yeah,
That's not how we see the stars at all.
She's doing it again. She's doing it again.
Okay, so strictly with this Mercator map, okay, that's okay. First off, we would have to assume the fucking Mercator map as the Earth, right? No, that doesn't work on that. And even then, that's not how it would work. Even if we were to like somehow map that onto a ball, because it's not even like easing out. It's not even like easing into like that middle point. I don't even know what the hell's going on. You got like just full circles and then like a straight bar in the middle. I don't even agree with that either on the ball. If you were to map that, it just doesn't work.
This is how we see the stars.
You with it.
Barely.
So,
fuck you.
Yes, it is. It's how we see the stars. Now, look, here is the phenomena of anticorpuscular rays.
Sunlight rays. Sunlight rays. Get them off.
With your same stupid thing. You're just saying the same thing over and over. I could make an AI say your argument at this point. It's not impressive. You mean to go script an AI so I can debate with it and then make it interrupt me every 5 seconds and just keep the same thing? Sun rays aren't the same as star rays. Sun rays aren't the same as star rays, even though my religion said the sun is a star and they are the same, but they're not the same.
But I think you're trying to equate the two in a weird fashion. Like you're trying to say, well, because at least from the looks of it, I could be wrong, right? But it seems that you're hinting at that, where you're going to bring in the sun rays and then be like, okay, the stars are doing a very similar thing.
Sources, right? They're both points.
That's what you don't get.
They're doing anything they can to make sure the point doesn't even get made.
Okay, go ahead.
Right.
I mean, I'm not.
They're both point sources, bro. Why are you treating them different?
What's a point source?
A star and the sun.
I don't know. I don't know if the sun is definitionally a point source. I'm pretty sure point source has to be like
I don't know about that last claim.
This will end up taking forever.
You would have to define. I'm pretty sure. I don't know about that last claim, but I mean, the stars and the sun are like.
They're both the same thing. They're stars, yeah.
With light, right?
Wait.
We get light. What the fuck is wrong with you? We get light. We perceive light. That's how we know stars and the sun exist. There's nothing else. That's all it is.
So we're gonna take it step by
even in your paradigm, in the globe paradigm, stars are essentially the sun. There is no difference.
Is the light from the stars parallel? Yes or no?
Wait, say that.
Use the
light that comes from the stars parallel? Yes or no?
Compare a star ray to a sun ray.
Is the light that comes from the stars parallel? Yes or no?
I mean, I don't really know how that would work for stars.
So you guys need to go back to 3rd grade and learn the globe before you come taunt flat earthers, maybe.
No, stop comparing apples to oranges and claiming you have a win.
Is the light that comes from the stars in your paradigm parallel? Yes or no?
Well, I don't really know what that.
Sun rays and stars.
Well, I don't really know what that means for the stars. I mean, for the sun, that kind of makes sense because you actually have like a size to it. For the stars, I mean, it's just like a.
It means nothing for the stars. Absolutely.
I don't really know
nothing.
if that really makes any sense.
Sure, if you're like 5, it means nothing. So, does the light travel to the Earth from the star parallel? Yes or no?
I mean, I guess technically. I mean, like.
There's no I guess technically.
Like, okay, fair. Okay, if I was going to like, I guess take like a photon or whatever the fuck from the star and then to the Earth, and then another one from the star from a different position and then to the Earth. I guess those would be. I guess, effectively parallel at that point because the angle.
Yeah.
So I mean, I guess that is a point. I guess.
Okay, cool.
Yeah.
So even in your own paradigm, the sun is a star, and in your own paradigm, the light comes from the stars parallel. So when we examine the actual phenomena we see on the Earth, we have crepuscular and anti-crepuscular rays, right?
Okay, but that
Yep.
only works on the ball Earth though, where you have parallel lines. How do you get the
You're
parallel
so
shit on?
lost that you have to keep
Works
insisting.
in reality, dude.
Okay, so now the sun is setting over here in the west, right? And we
Okay.
see what looks like rays diverging out from the position of the sun, even when we can't see the sun, even when the sun's down seemingly below the horizon, quote unquote.
Okay.
Right? So now when we turn around 180 degrees, we'll see the same thing in the opposite direction from the east. Now the sun is setting in the west, but we'll see it all converge to a singular point even in the east, okay? So this is just a product of perspective. There is no actual point source where all the rays are diverging from in the east. The sun is in the west. So this is objectively a product of perspective. So if what's going to happen if we draw the point on the right and then we draw divergent rays out, then we draw the point on the left and draw divergent rays out, they're going to meet in a center point. Right?
Okay.
But the stars aren't perspective.
Hey, are they going to meet in the center point?
I guess with what you have here, I mean, I guess that goes without saying.
Well, no, that's not what we have here. It's what we have in reality.
Well, I mean,
Yes, that's what happens with sun rays. It doesn't happen with star rays, but yes.
Okay,
I mean,
now what?
she
Now
just
what?
claimed
Let's see
the
if you guys
stars
can
are
answer this next.
perspective, but
See if you guys can
Go
answer
ahead.
this question.
But what's
So
you
what would
have diverging
happen-
lines though. That
This
doesn't
is
really.
what we see in reality. So what would happen if I start to spin the rays?
I
They're
guess.
not gonna match the stars. That's what will happen.
Okay, see. So what would happen if these begin to spin? What would they look like looking west, and what would they look like looking east?
Yeah, I guess it would mirror it, whatever. But once again, that only works with parallel lines, though. You have to kind of show that this works with something else. Like this doesn't really make sense on the flat Earth.
there'd be a
And the
rotation and a
sun
Yeah,
counter
but to
rotation.
avoid the point, right? So first of all, you can
You're
have
telling me that
divergent
the
rays.
sun's stars are a
Hey, let me
reflection of-
enlighten you with something, Arma. You can have divergent rays without parallel rays. In fact, let me break this down for you. In your own paradigm, the rays from the sun aren't actually parallel. They're a light source coming from a sphere that go in all
Okay.
directions. They're divergent light rays in your own paradigm. You call them parallel because you claim that the radius of light from the sun is so big that just a tiny little fraction hits the earth. So for all intents and purposes, we can consider them parallel, even though they are divergent.
Okay.
You understand? Okay, cool. So you obviously don't need parallel rays to see divergent rays. That's ignorant, huh?
No, okay. The rays that we see, the crepuscular rays, right? That isn't caused by the divergent rays, whatever. Like they have to be parallel for this effect to work. If they're diverging, whatever, then you're gonna get a totally different visual.
Not true.
That's incorrect because in
That's
your
not true.
own
Wait,
paradigm, they're
wait,
actually
wait.
divergent.
No, in our paradigm, if you
Let
actually
me
take a
take
picture of those rays or whatever from above, whatever, I think you've seen those pictures, but those rays are, or those shadows are essentially parallel.
They're actually
They're
not parallel. They're not parallel.
You've seen
I've
them
taken those pictures
diverge.
and shown that they're objectively not parallel.
Yeah, it shows them
I don't know,
parallel from
I've seen
above. Then when you get underneath, all of a sudden it starts showing perspective. So she just
Oh.
claimed that
But
the
then-
stars aren't perspective.
No,
But,
it
but
doesn't
y'all
even
do
show them
control
as
yourself.
parallel
Hold
from
on.
above. Why are you saying that? No.
I've
no.
seen pictures where they're parallel.
Me too. The shadows on the clouds from above. If you
Yeah.
actually draw the lines, they're not parallel.
I mean, I don't know. The ones I've seen, they are parallel, but
No, they're not. I've seen the same ones you have. There's only 2 of them that anyone ever shows.
okay.
Okay. So anyway, if we have this optical effect here, even in your own paradigm, it looks like these rays are diverging to the point of the observer from both directions. So if they started spinning, just answer the question without your follow-up of how you think it's impossible on a flat Earth because you don't understand it. Okay. Do you agree that if this started spinning, then if I look to the west, I'd see one type of rotation, and if I turned around and looked to the east, I'd see the opposite rotation?
I mean, I guess it
So
goes
why
without
aren't they
saying
reflecting?
if you have the structure extend out from the sun, whatever, whether it be a light ray or even like a pole or something, right? Then that goes without saying. You're looking literally like a 180 of that same structure rotating, right? This doesn't apply to the stars because the stars literally are their own thing, right? Unless you're gonna like have them be the same structure or something, and even then, there's still a lot of issues with that. But
You're still lost. Okay, so is there an actual central structure in the center over here in the east?
No, but the thing is, those rays, which would be their own kind of structures, if you want to call them that, right? They would be essentially, what do you call it? Perspective would be essentially having them appear to converge, whatever, right? So what I'm trying to say is those rays that we're seeing converge are still like the same rays from when we do 180 and look at the sun. You can't really do that with stars, though.
They are where they are. We're talking about the rotation of them.
Yeah.
Those rays are identical
understand the
on
argument,
both
dude.
sides. Those rays are identical on both sides. The stars are not identical on both sides of the sky.
It's irrelevant. You don't understand
It's
it.
not irrelevant.
It's pretty relevant.
They can't be.
They represent
That they aren't a reflection of the other side of the sky, like this example that you're showing me.
Reflections, Trouble. They can't be reflections. That's not what we're
Well,
saying.
you're showing me a reflection here that's working on both sides.
No, it's not a
And then you're
reflection.
claiming that's
You don't
what's
even know
happening
what the
on
word
the Earth.
reflection
It's
means.
Only the stars
perspective,
aren't a
dear.
reflection.
Okay, fair enough.
Hey, you guys, hold on a second. As a point of moderation, it's really hard. For everyone listening, it's very hard to listen when everyone's talking over each other. Could we try just giving each other their time to speak and go one at a time so we can hear?
Fair enough.
All right, thank you.
This isn't reflection, it's perspective. Those are fundamentally different.
Okay, maybe I'll grant you this for now, but there are paradoxes once again that I have brought up, and maybe like towards the end of this I can bring those up and maybe we can discuss that, because even with this argument now, if you look actually into it, it doesn't really work at the end of the day. But go on.
That's what you think. So now we see that what you're going to see is that they're going to meet in the middle optically, and they're going to look like they're converging to a singular point in each direction. So if I began to spin this, it would look like all these rays are spinning around a singular point in the east. But of course, there's no source of light in the east, and they're going to look like they're all converging around a singular point, when in reality, they're just spinning. Okay, so just
to every observer, real quick, Austin. To every observer is going to see a rotation and a counter rotation. There's no getting around it.
Correct. This is just objectively how perspective works, and we know this by like actual observation. So here we go. Now we're just going to compare the two ideas. Okay. So right here, we're looking north. We see the stars moving. Now, when we look south, we're going to see them moving the opposite way. When we look in the middle, we're going to see where they're meeting.
But it doesn't really look like that. I mean, it's close, but it doesn't. That's not really close to what
it makes it. It works. It works no matter if you make it exactly like it. Good luck trying to program it out to make it look exactly right on an over-the-top projection. That doesn't matter. That's completely irrelevant. So, we would see it have straight lines in the middle.
I'll give you one. I've got one. I'll put it in the back chat for you.
We would see it have straight lines.
Picture it in motion. Sorry, picture it in motion. Trouble. Picture what that's on screen. Picture it all in motion. So in other words, you see at the equator. If you could put that back up, Austin. If you just picture that the middle rotate, moving across the screen basically, and then picture it halfway toward one of the poles moving across the screen, then that's a smaller rotation. And then picture it toward the point. It's just the rotation gets tighter and tighter. Do you at least see what we're trying to explain?
I get what you're trying to explain, but it's not accurate. But yes.
Well, we see with the sun. So you guys have to say that the sun is anomalous, just like Antarctica is anomalous and all that stuff. Okay, so if we look at a depiction of this, first of all, this would be our personal grid of view. If you put it over concentric circles, you see an optical convergence point that's not actually there, right? That's not actually there. Those are just concentric circles, but it'll look like a convergence point through the curved view.
Isn't that a lens?
So you can't deny that. It's just objective. You can say it's not happening on the Earth if you want to, but here you go. You can have concentric circles, and whenever you look in both directions over top of a azimuthal grid of vision or a dome, you're going to get what looks like two different convergence points in both directions.
But that's a lens, though, right?
Do the poles all around in a circle.
Lens, dude, you didn't know?
We got both sides of the poles, and you're only showing one side as if they just meet on a point.
No, I just showed both.
No, you showed the middle.
Wait, hold on. Wait, what was that about? We said what did you just say?
Around the globe.
We'll get
all right, so you're proving the globe. All right.
No, what's it? Okay. What's it? I said that's a lens, and you said what?
For one, our eyes are lenses, and two, we look through the atmosphere that acts as an additional lens.
That's the only spot on the Earth you can see both rotations. Just so you know, we're going to see one rotation. One pole.
Well, I'm under the celestial equator, so above my head I see the equator, and to the right is the northern one, and to the left is the southern one. I can see most of the southern one, and I can barely see the top of the.
Right, but everywhere else we don't see that. We see like a portion of the rotation. You know, like if you're a little bit further south, you won't see Polaris. You'll see a portion of the northern rotation. It's just when you move that thing around, it pretty much mimics. It's just each individual's perspective.
Well, hold on. Wait a second. You say our eyes have lenses in them, whatever, right? Okay, I'll somehow grant you that, right? But the whole lens thing, though. Wait, hold on. Okay, whatever. So in that picture, right, where you have these two little circles, whatever, right? Here's the thing, though, right? I don't know if you've ever seen that GIF where the guy is like putting that lens over the, the stars circle, the circle of stars thing, right? But there's no two centers of rotation, though. It just kind of looks like there's center of rotation. But if you actually follow the stars, they just kind of disappear, and then new stars come in. All right, there's always like, and that makes sense too, because if you have a lens over, I don't know, a giant like, circle of stars, whatever, right, and you're moving across that surface, right, there'll be stars outside of that lens's, whatever. It can't really get
irrelevant. You don't understand it.
Well, the point I'm trying to get at is when we look in the South, right, everyone in the South essentially sees the same stars around the center point or whatever, right? How does that really work with this whole thing? You're sort of bringing this.
Can I say something real quick? So, what we see in reality is two apparent centers of rotation, and basically, what's been demonstrated is that you can create two apparent centers of rotation with a lens.
Exactly, that's the whole point.
Not really. I've seen the videos. They don't really do.
You just
they
always
don't really rotate.
You're not saying
No, I've seen the video. They don't really rotate. You can show me, but you can look at it yourself. They don't really rotate around it, and new stuff comes into the thing.
Well, so here is how you would see it inside of an azimuthal grid of vision, which is a dome. That's how we actually record the sky. Flatter globe. We went out when we take angles to the sky. We always get a dome every single time. Every time.
But you don't get a circle around the pole stars. You get this oval.
You're not understanding.
You've never gotten a perfect circle around the celestial poles. Why do you get this oval dome shape?
On a globe, unless we're looking that way, we would never get that rotation unless we're looking right at the pole. And you could demonstrate this in reality. You could demonstrate this by setting it up. A guy did it. I'll try and find the video. But unless you're looking right at the pole, you won't get that rotation. You get a bigger rotation. It has to be perspective.
Hold on, Brian.
No,
Brian, it depends on field of view.
Around things, and I'm not looking directly at Sigma Octantis. I can be looking way above it, and I'll still get.
Oh, you've never looked at Sigma.
You'll never get a perfect round circle of the poles.
But Brian,
rotate a camera. Here's the point: if you rotate a camera, unless it's pointing right at one of them poles, you won't get that tight central point. The guy demonstrated it a long time ago.
That's not right.
But in reality, we do see it. So that shows you it's not the camera rotating.
Do you guys understand this illustration?
I mean, as best as I can for this weird, model of yours.
Okay, well, here we go. Now we just put it into a program, okay, and we're going to be on the plane through the middle of that. This is objectively how you would view with curved visual space. It's objective.
But see how much you've spread the poles out? Now the poles are like this long thing instead of this nice round tight thing. You'll never get the celestial poles to work over your flat Earth.
Dude, they're sitting here doing it. So here we put it in a program.
Okay.
Holy shit.
Here it is in an actual program.
Oh my God, Whitsit, that's great.
Now watch what we see as they move.
All right.
Oh, don't take away the last branch. Don't take away the last branch. Don't take away.
Wait, how is that game over? How does this prove anything? I'm so confused. How is this game over?
How do you understand?
And do you know the stars don't? The spaces between the stars don't get bigger and smaller like it is happening in your version.
No, it's not.
Don't take away the sky. Don't
the
do it.
distance is between stars, no matter where they're rotating.
I need my space. I need my sky. It is so confused.
I don't see how this proves anything. It's literally just a fucking rotating sky at 180 degrees field of view.
I mean, what it does is it takes away your guys' only bit of proof. Is you always appeal to. We know. We know this is the shape because of the sky, and we're demonstrating that we can have the exact same sky with a different shape. That's what's important about it.
Yeah, exactly. Let's be honest. And what they're arguing against is they've come up with some arguments against the idea that there's a giant dome over top of the Earth, right? And so they just keep on arguing from that. They're not even actually responding to the true argument, which is that it's a personalized dome. Like this is provable because we can go take measurements on the Earth and prove it. We can also go look at anti-corpuscular rays and prove it. And even suncalc.org, using the globe model, has to map the sun in a 360-degree field of view.
Okay.
You understand?
So I think your presentation is absolutely. I just say something. Fine.
Yeah, go ahead.
I think your presentation was absolutely brilliant yesterday. It's a shame about the sound, but I think if you were able to do it again, but have the sound going, I think it's it's really worthwhile to produce that again. And
Yeah,
hone it
no,
in
I think what I'm gonna do, bro, is I'm
up.
gonna do the presentation with sound and make it a short video that's like 10 minutes so that people can just share it that way.
But let's be honest, guys. Did the globers ever had any proof regarding the sky? I mean, any sane person looking at star trails being completely straight, and they would correlate this for being on a sphere that is tilted and wobbling and flying from an ever-expanding void of darkness at 67,000 miles per hour while speeding and accelerating and slowing down simultaneously. Like who would consider? I'm talking about the stars. Who would consider that lights would behave this way and give you such a clean and stationary side? It's absolutely ridiculous what you guys think reality might be.
Well, hold on. This is
completely fooled, and you don't even realize it. Like, because you're not even considering how stupid the idea is that you're on a moving, spinning ball that shows you perfect star trails, as if that's a thing, you know?
Wait.
Magic light.
Okay, but this is the point here. Even in their own paradigm, with suncalc.org mapping out the crepuscular and anticrepuscular rays, you have a 360-degree field of view all the way around you. If you bust a 360, and then to map out the visibility of the sun and the anticrepuscular and crepuscular rays, you literally use this circle field of view all the way around you.
Okay.
Even on the globe.
That's what showed suncalc and the divergence and convergence. It's all they have to call perspective for that phenomenon.
There is no divergence and convergence. Even Whitsitt will tell you that.
Go to suncalc. That's what we see, though, right?
Can
I don't
Whitsitt, you want to teach your own flat earthers your model because they don't understand it. They've all got different ideas of what's going on in the sky.
We're saying that what we see in the sky,
suncalc and stellarium. She doesn't care about any of the globe programs. She just will just
Simon 8, Stellarium, and Suncalc. Okay, so if you guys deny the construct, you deny your own model, right? This is how we have to use this to map it out even on the globe. And again, this is suncalc.org mapping out the crepuscular and anticrepuscular rays, showing this very same thing that I'm explaining, which is that there's a 360-degree field of view all the way around you, and that's the limit to how far you can see the sun, and that you have this optical effect fitting within the sun.
Yeah, but then you claim that the southern stars are not real, that they're a reflection of the northern stars, which they're not even close to a reflection of.
That's not what he's saying. Of the northern
they can't be reflections.
Wait,
in this program, they can't be.
Wait, hold on. Can I just?
Wait, this whole idea is not saying that the southern stars don't exist and they're just reflections. Trouble. That's not.
Wait, hold on.
Not saying that. It's talking about perspective. And wait. Also, what Brian was just saying about the convergence and divergence, Whitsitt doesn't disagree with it. It's an apparent divergence and convergence. The way that we see makes it apparently a convergence and divergence. So they do agree.
Yeah, they're not actually separating and conjoining like this other guy keeps insisting that they're doing.
No, he's not saying that they're doing it in reality. He's saying they're apparently doing that from the same exact perspective.
No, that's what Whitsitt says. The other guy doesn't say that.
Talking about it being apparently that way. Whitsitt included in his presentation last night, they apparently converge and diverge from our personal azimuthal grid perspective.
They have to be doing that.
And the next person seeing the same thing sees them converging and diverging at different places.
They have to be doing that because when we see the anticrepuscular rays behind us, but the sun's in front of us, we know the sun's not actually behind us. So no matter what you think the Earth is, it has to just be perspective causing that effect.
Right, and that's my whole point. When I made all them videos and I showed the convergence and divergence and suncalc and stellarium and on Google, hold on, real quick. Let me finish. When I showed all that stuff. That was globe killer. In other words, you have to either claim it's perspective or it's really happening. That's what we see, right? I was almost done. Either you claim perspective, which kills the globe, or that it's really happening, which kills the globe.
Can I just jump in real fast? Whitsitt, is this the end of your little presentation? Like, if so, I
want you to acknowledge what I just said.
What was that?
Don't know what I just said?
Well, everyone else was talking. Can you repeat yourself?
Even in your own paradigm, using suncalc.org to map out the phenomena of crepuscular and anti-crepuscular rays, you're using a 360-degree field of view all the way around you, drawing a circle, and then explaining perspective relative to that circular view.
That's how 3D worlds work. You rotate. You could rotate. I mean, that goes without saying. Literally, the objects are around you. That's how 3D worlds.
Saying we have a limit of you can rotate a sphere. Wait, are you saying it goes without saying we have a limit of perspective in a circle around us?
Not a limited. Not a limited.
Why is it a circular limit of perspective here?
Wait, what limit are you? Wait, hold on. What is this limit thing coming from?
You don't understand the picture?
All I'm saying. Go ahead.
Do you not see that the sun is clearly within the circle? The visible light is within the circle.
Okay.
Okay.
So it's the same on a globe. Yeah, you've got a personal atmospheric dome on a globe as well.
Correct.
I feel like we sort of jump. Okay, hold on. So what was the argument again? Because all I'm saying is that in a 3D world, right, which we live in, right, it goes without saying that you can rotate around, right, and have 360 rotation. So yes, naturally things will be around you, and therefore naturally things you could map them out, using 360, was it horizontally and vertically, whatever. That goes without saying. But I think you're sort of like jumping, not the gun, but you're sort of like throwing in this extra part with like, what was it, limiting or something? Can you explain that part?
Yeah, this is from that observer's position. This is the limit of your perspective. They're saying, well, just because this is as far as you can see, it makes the anti-crepuscular rays appear to be converging to a point because you can't see further than that.
No, I don't think anyone claims that. I mean, they always converge. Even if you had like infinite resolution, they would still converge. But just maybe they may not meet per se, but they would get really close. They would still converge.
If I zoom in, what will happen to the optical convergence?
I mean, they're still converging.
Will they change?
What would change? The way how much they converge, or whatever? Or like, what are you talking?
Yeah.
No, they'd be converging at the same amount. You zoom in, they'd still be converging.
Wow, that's crazy. So if I zoom in on a railroad track, what happens?
They're still converging.
At the same rate.
Yeah.
So you don't even understand it. So like if I'm standing on a railroad track and it looks like they're converging, if I pull out a high zoom camera and zoom in, you're going to start to see that railroad track spread back apart.
No, I mean they're still converging, but like I get what you're getting at. Yeah, sure. If you like zoom in, there's like more, but they're still converging though. I mean,
it's a non sequitur.
I'm not really sure what you're like arguing about.
Yeah, I get it. So this is based on what we see as an observer. From an observer's position, we can only see so far in each direction. That gives us a 360-degree field of view if we're bussing around, right?
Wait, hold on. They're still converging. Even if you zoom in, they're still converging. They still have an angular size. The angular size between those railroad tracks, whatever, it's still the same size even if you zoom in. All right, I get your argument, but they still have that same angular size, so they still were converging. Like you're
my guy. They will start to optically spread out as you zoom in. Do you understand?
Okay, but the angular size is still the same though.
Yeah, you're changing your perspective ratio essentially if you start zooming in like that.
I know. Well, that's not what
converge because the freaking camera also can't see forever.
Oh, I get that argument. When I say converge, I mean like they're still angled the way that they're angled is what I was trying to go at. Because I mean like there's
non sequitur.
Okay,
he's not saying he's not saying they're not converging still. He's just saying that your perspective makes them widen again when you zoom in, meaning that when you're at a different point at if your perspective changes, then it's going to widen out and it's going to keep widening out as you zoom in and go along the railroad tracks. It's just going to be all about your personal limit of perspective.
Yeah, and we have telescopes have a limit as well, right? Like when we take actual angles to the stars, we have a limit to how far we can see. You guys seem to think that light travels infinitely and that we can see 46 billion light years away, but that's actually insane, right? Like that's not.
Armin, do you think on a flat Earth there'd be a direction we'd look and not see any stars or something? I'm just curious. Like to me, it seems like he's thinking in the South there'd be a direction we look and there'd be no stars or something. Like is that what you're thinking?
You would still have stars, but you wouldn't have a center point of rotation. And I'll be glad to show you or not show you. I'd be I want to like share my little paradox, whatever that I had earlier, but I mean, I guess we're still talking about this.
A rotation, bro. You can't. It's not possible. And with a dome of view, you can't not have a counter rotation.
This is what's so funny. Think about this. So they're saying there's no limit to our perspective, right? So then, shouldn't I see half the sky?
You're talking about field of view. We're talking about in terms of like distance.
Oh, so there is a limit to my field of no, not field of view. Like
it is field of view. Field of view. If you would need a field of view of 180 degrees to see all of the sky. or at least left to right. Maybe not up and top, you know,
So
up and
are
down,
you
but
saying
left to
I
right.
can
Though.
see
Technically, you
half
see
the sky from one position on the Earth?
You see 6
Well,
constellations
okay.
at a time.
Well, hold on. Okay, so as a person, if you wanted to see from one end of the sky to the other end, right, you would need a field of view 180 degrees. But you're talking about something else, though. Hold on. What's it talking about something else, though? In terms of being on the Earth, and in terms of the amount of stars that you can see, you should be able to see about 50, if not even slightly more than 50. Yeah, 50% of the celestial sphere. You should be.
Yeah. So can we?
Yeah.
No, we can't. So that's what I'm saying. Most globers seem to think that you can actually go out in the world and see half the sky.
Well, what makes you say we don't?
You can only see a few miles around you, bro. What are you talking about?
Right, evidence that we do.
Okay, show us.
That's what I'm saying. Yeah, show me that you see half the sky.
Okay, I mean, I guess I'll just. I mean, first off, I'm pretty sure if you want to use Stellarium so much, I'm pretty sure Stellarium shows us half the sky. But you know,
no,
sure,
Stellarium specifically doesn't.
You sure about that?
Yeah. Oh, yeah. Stellarium shows within your azimuthal grid what you can see and what angles you see, and it's not half the sky.
Can you show me that?
Yeah, go to Stellarium.
Let me see this shit.
So, okay, look, here's the actual point here to drive this home. Even in your own paradigm, you need to use the same circular limit of vision. You guys can say no, but this is how we observe the world right here. We have an observer, we have 360 degrees around us, we can turn around. This is how we map everything. Right here, this is how we map the whole sky, because this is how we see. We have a limit to how far we can see. We map it all based on that.
Hey, Winston, I have one question, dude. You know how they say, like, somebody in the UK, like yesterday I was debating a Glober about I think it was Exiles or somebody posted it that you can see the moon in the northern hemisphere in one orientation, but the person in Australia see it upside down. So I shared a picture. Do you see it in the chat? It's not coming through on my end, but do you see it?
That's a different topic.
No, that's easy to explain.
No, it's not.
Dave Weiss has even explained that if you put a moon up above you on the ceiling and you walk from side to side, it's going to look different.
Wheel, bro.
I want to put this out to you guys real fast too. So these are of course we have like the perihelion, then we have like sun dogs and halos, moon halos as well. Okay, even observatories catch them. Now, first of all, this makes perfect sense understanding that we have an azimuthal grid of vision. This isn't the dome over the whole Earth. The dome would be way bigger than this, right? But this is based on our limit of perspective. We have curved visual space, right? So when we have something in the sky that can reflect the light, we'll see these limits being illuminated, the curved visual space. The globe doesn't actually have an explanation for the shape, for why it's not equidistant. Since the light's coming out from the source and they claim it's ice crystals all in the sky, there should be little circles everywhere going all the way out and continuing out. They don't have an explanation for why it starts to go the other way at the top. They also have to claim that the ice crystals are parallel to a flat surface below it. This is the globes, and they admit they can't fully explain it. Okay, but what this shows is that we have a personalized dome of view right here. This is what we're inside this. That's why we see this when we look at the sun. The globe can't explain. Again, they say that these ice crystals are perfectly parallel to a flat surface below, in theory. And look how far out you can get them to go. How far out is the Earth flat? Right? And again, they don't even explain this part right here. I don't know if you can see my cursor, but where it's going up, where it begins to change direction.
Okay, hold on.
It changes direction. Look, right here.
What's it? I'm on Stellarium right now, and I'm seeing more. I'm seeing about 50%. Why did you lie?
You put your azimuthal grid on, and you can see half the sky.
You're talking about stars infinite distance away. We're talking about the sky. Period. Like you can only see a portion of the sky.
The sky. I get that. Yeah, in terms of like the fucking clouds, of course you're gonna see less than that. I'm talking about the fucking celestial sphere.
Think about this,
specifically the celestial sphere.
Think about this. If you take a plane that's flying above the ground about 10 miles in front of you, you're going to see it for a little portion.
Yes, it disappears. Right? I know. I got that. I literally agree with you.
Hold on, man. Hold on. Let me put this picture for everybody, bro. Why are you interrupting me, bro? So then now,
my bad.
It's 10 miles away from us, and it's flying across the sky. We're going to see, okay, depending on where it's at, okay, it's north of us. And then we raise it up, let's say a mile, and fly across the sky. And then we raise it up another mile and fly across the sky. you're going to see a little dome, and every time it raises up a mile, it's going to make a bigger arc if it's north or south of us, man. That's just how we see, bro.
Yeah, but when I was talking to Witz earlier, I was saying specifically, I literally said celestial sphere. All right, in terms of celestial sphere, we should see 50% of it. And what I'm getting here in Solarium is 50%. All right, I literally have the azimuthal grid of vision up, right? And we have, what is that? We got 10 degrees, 20 degrees, 30 degrees. I literally have up to 90 right above me because I'm at the North Pole right now, and then all the way down to the what do you call it? The horizon, whatever. I got down to 0. Let me also pull up the. Actually, no, that's actually not azimuthal grid. That's actually equatorial grid. Okay, all right. Yeah, exactly.
You half the sky.
Half of the celestial sphere. I'm not the sky itself on the Earth. That's a different thing. But in terms of the celestial sphere,
oh well, shouldn't we see half the sky itself on the globe Earth?
You mean in terms of like clouds and shit up there? Then no.
Wow. You talking about clouds?
No,
well, that's part of the sky.
On a globe, you're on the side of a sphere, so you'd be looking out and seeing half the sky. You'd be looking out.
Okay, when you say sky, do you mean celestial sphere, or do you mean like the clouds and planes and all that shit up there? Like, what are you referring to?
Like the stars. The only thing that should be blocking how far we can see in the sky should be the Earth.
Yeah, so it's the celestial sphere. That's why. Yeah, so yes, we should see 50, and from Solarium, from the looks of it, yeah, we are getting 50.
So if I go out into reality, can I see that?
Sure. I don't see why not. I'm pretty sure.
For. And by the way, look,
you made the claim that we don't. Shouldn't you be the one showing us evidence that we don't?
We don't know how evidence works, right? So
you literally made the claim. You brought it up first. You literally said we don't see that. So I was telling you, show me, and you were like, oh no,
negative. I mean, technically, I could go out there and not see it, and you guys just make excuses. So how about you show me actually seeing half the sky from the Earth that you claim is a globe? And by the way, just so the room knows, ARMA's excuse for this, because again, they have crepuscular and anti-crepuscular rays, and they look like they're converging down on the horizon, right, 180 degrees away from each other. So when we look at them, we see a curve in the sky. Just like if you take a dome, you're going to see it curve over from point to point down onto the perceivable limit, right? You're going to see the curve. That's what we see in reality. We literally see a curve. ARMA said that this is because it's a wide-angle lens.
Yeah, let me say this, Arma. This is very important. If we're on one side of the globe, look at the equator.
What?
Hey, y'all, listen to this. It's very important. If we're on one side of the globe and we're at the equator looking at the north and south celestial points. Okay, now we're on the other side of the globe looking at the north-south celestial points. So, Arma, we see we see every star between the two of us. We see every star, right? So what's in between? So the rest of the Earth that's in between us, how the fuck does that work? Do we share it, or
yeah?
They see what you're saying is 50% of the sky. Then if I'm on the opposite side of the equator, then me and you can see the entire night sky, right? So what's in between us?
No, you're always.
Here's the deal. Here's the deal. You can check this on Solarium. It's sunset for me right now. 90 degrees away from me is noon. At 180 degrees from me is sunrise. That's just the way it is.
Dude, that's how we made the globe, Leftwing. The fact that you guys don't comprehend that we made the globe by looking at the sky blows my mind.
Well,
yeah,
let's not.
I'm looking at I can see half the sky for sure.
Well, hold on. What's it? Seriously, we need we need to go back to that little claim of you saying you're saying don't prove a negative, whatever. But you literally said we don't see. All right, 50%. All right, so you should be making the claim in general. You can't make a claim without some kind of evidence or proof, whatever. Right? I mean,
just imagine my point, bro. Howard just jumped in. Okay, so if I'm on one side of the equator and you're on the other, we're seeing the entire night sky.
Yes.
Okay, what if Howard is what if Howard is in between us? What the fuck is he seeing? A shared night sky? Like we're on the ends of the globe, but we're seeing the whole entire sky.
Yes.
So hold on. So we're in between us. What is that? Just the fucking Twilight Zone or what?
Okay, how about this? So let's divide the sky into 4 sections: red, yellow, green, and blue. All right. You see red, yellow. All right, and Howard sees green and blue. All right. The person in between would see green and yellow, and the other guy on the other side would see blue and red. All right. There you go. It's not hard.
Hey, this is what real fast though. Before this gets lost, I want to understand. You're saying that this is just because of a wide angle lens. So if we were using a normal lens, what would they look like?
I'm not sure. I would have to get another lens to see how that looks.
Okay, so if these are converging down onto the horizon, and you're claiming the light's going above our head, because of course, if the sun is just like 1 degree above the Earth on your model, it's like 1.3 million miles above the Earth or something crazy, right? So if you guys are claiming that the light rays are going over my head, but we see them converging down on each horizon, So how does it go from a point on the horizon over my head back down to a point on the other horizon without curving?
Once again, it has to do with like 3D space and whatnot. I'm pretty sure I could, like, literally this would work with anything. If you had power lines, whatever, I could probably model this in Blender, in fact. But Blender doesn't use like any curving thing. It literally just uses, trigonometry and, I guess the field of view or something. I guess maybe the field of view kind of throws in that sort of curving effect, whatever. And that maybe supports your argument. But that still doesn't explain southern star rotations, whatever.
Wait,
somehow equating the two, though.
You do this every time. Every time you have to concede, you just end your concession with, but it doesn't work, and you change the subject. No, you said that the only reason this looks like it's curved is because of a wide angle lens. I'm explaining to you that doesn't make any sense because we see them appear to converge on each horizon. So if I take the point on the horizon and I draw over my head back down to the convergence point on the other horizon, how can you do that without it curving?
I don't know if I'm 100% following. Remember, I think.
Hey, let me put it like this: you should be able to show us the sun doing a perfect circle from the North Pole. You should show the sun at 23 point whatever degrees doing a perfect circle and not going up or down. Let's see that.
What?
Why would it go down? If I'm at the North Pole, why would the sun appear to drop for any reason? I mean, if it's not perspective, then it's doing a perfect circle around me. If I'm the one spinning, and I'm at the exact North Pole, I'm at the exact point of rotation. So go to the South Pole, whatever point you think is the South Pole of rotation, and show me the sun 23 degrees above the sky doing a perfect circle around the sky, because that's what would have to happen if I'm rotating.
No, if it was 23,
circle. No
hold
circle.
On. If it was 23 degrees above what? Above the horizon is what you're saying? 23 degrees?
No, like on the solstice, on the southern hemisphere's summer solstice. If I'm at the exact center of rotation at the South Pole, you should be able to show me a sun do a perfect circle 23 degrees above the horizon. If I'm the one spinning,
23 degrees above the horizon?
No.
Once again, if
that doesn't make any sense.
Spinning, oh god, dude.
You said, hold on, 23 degrees above the horizon. So basically, am I getting that correct? Is that correct? You said 23 degrees above the horizon.
23.4 degrees above the horizon.
Yeah, no,
the sun starts at summer solstice in the south for the southern. Yeah. Okay, now
it shouldn't do that.
If I'm at the exact center of rotation, why would it go down?
Okay, so that doesn't. Maybe I should model this out in Blender, all right? Because this doesn't. What you're saying right now doesn't really make any sense. But I could.
This is wild, bro. Okay, let's just
read. Brain won't let you comprehend it, bro.
No.
For one, he had to concede,
Blender, right? Because I'm pretty sure.
Yeah, there was a point that Arma was trying to respond to Witsit, and then Brian came in and just brought up some whole new thing.
Well, yeah, I want you to concede, man. Like, okay, like we can recap if you want, because I feel like I'm almost picking on you at this point, right? But I'm
sure if you
yeah, you're all by yourself, right? You're kind of getting dogpiled. Don't take it the wrong way. So the point is that we see them look like they're converging on the horizon, okay, from both sides, 180 degrees. So if you're claiming it goes over our head, to draw from one point on the ground and then go over your head back down to another point on the ground, it has to curve. Secondly, the celestial sphere does not show literally 50% of the sky.
Well, hold on.
You can prove this by understanding you can't see the alleged southern pole rotation, the circumpolar rotation, from just below the equator. You have to go to a way lower latitude than that.
You sure about that?
See literally 50% of the sky.
Are you sure about that? You said at the equator you can't see the southern pole?
So you're saying that we can see the southern celestial pole from the equator?
Well, technically you shouldn't, because it would be exactly on the horizon, I guess. But no, that's not really true either, really. I mean, because technically speaking, right, because the Earth is curving, right, technically there is a 0.04 degree amount. Yeah, technically you should. I mean, it's probably not like super visible, but technically it should be like a smidge of it there, I would say.
This would debunk the globe, though, if you can't see it, right? I mean,
like I said, it would be like a smidge, a smidge amount. So you probably can't make it out. So
I believe that you might be incorrect with it. As far as I understand, Southern Cross can be seen from Texas.
Southern Cross isn't the
Florida.
southern celestial pole.
No.
Yeah. Hold on. So the pole.
You can see. You can
from Texas.
Apparently. Yeah. Apparently,
Nope.
Florida and Florida and Texas. Yeah. Just go look it up. apparently.
Yeah, wait, hold on.
The Acrux is the southernmost point of the Southern Cross, and it's at 27.5 degrees, I think. So yeah, we can see it. If I go just a little bit south, I can see a little portion of it where I'm at, but I can't see the southernmost star. But still, I was sorry for changing the subject. I was just trying to elaborate on what Austin's saying, because they think about the sun a lot better and practically, and so these shadows we see for the North Pole, like they try and show us 24-hour shadows. It's the same concept. Like the shadows pretty much should do a perfect circle from these 24-hour cams on the government cams, but that's not what we see. So we know there's horse shit afoot.
Yeah, I just wanted to say that I kind of liked it. When I first saw it, I thought, okay, this makes sense. And then I was sort of picturing in my head walking to the farthest, southern point and seeing that southern rotation, and that was fucking me up. I couldn't get my head around it. And also, I think you're supposed to be able to see Polaris from the equator also, which I couldn't, the two wouldn't marry up in my head. But this has made it much clearer, so I appreciate it, Austin.
Yeah. No problem.
Well, the thing is, though,
Hey, me too, man. Me too, by the way. Good presentation.
Does this place in a poll, because this also happens in my,
You're a robot, man. So what I was going to ask, Austin, the thing is, so like crepuscular and anticorpuscular rays can be viewed anywhere, on the Earth. You're going to see that kind of convergence, divergence, and if they were spinning, you would see the rotation and counter rotation. But to use that explanation as the southern stars, wouldn't that have happened if you were, let's say, like north of the equator? Wouldn't you see a southern rotation everywhere? You would, if it was just because of, Brian, you're interrupting. If it was just because of perspective, wouldn't you always see a southern rotation at every point?
You're going to see them start to look kind of funky because you're looking in that way. You're not going to see a full convergence point.
But isn't there something different about the sky in the south that makes it that convergence? Meaning, like if you were in North Dakota or something, you're going to see the northern rotation, but you're not going to see a southern rotation.
Yeah, but where you're at, if you're near the equator, you're going to see that point moving. Okay, if you're actually at the equator, then you're going to see the opposite of the sun. That's just a point. So everybody's going to see that point as the center of their rotation, and that's only if the rotation's getting smaller. So in other words, that rotation is. Go ahead. Sorry.
Well, I mean, but why don't we apply these same rules to the northern sky?
Because the northern rotation isn't a facet of human perspective. Right, it's physical.
Okay. Oh, okay.
Yeah. It is physical reality. The stars are rotating one way.
Well, how do you know that it's not the same in the south, that it is physical reality that they're rotating the other way? Because what I was saying is that if it was just a matter of perspective, like you can get crepuscular and anticorpuscular rays anywhere on Earth. You don't have to be in the north or south. So if it was just the stars or just perspective, it seems like you would always get a southern rotation anywhere you are on Earth. But instead, we only get it when you're in the south.
Only when you're far enough away from Polaris where you can't see Polaris anymore. So in other words, only in the south while looking south.
What if you're looking east, Gio? If I'm looking east, am I going to see a rotation? If I'm looking east and the sun is, and then the anti-spot is directly behind me, am I going to see some type of rotation? No, I'm going to see them just going and ending up in a point behind me, right? It's only if you're looking north or south, bro.
But what dictates what dictates the midpoint though? Like how you get like the equatorial rotation? Like why is it like specifically there? Like that doesn't really. And what happens if we extend the flat Earth even further and we go further out? Like
where the star lapses armor of the South Pole straight up? Can you show me some of those 90 degrees?
Wait for what?
Under the South Pole, time lapse. Right?
That's my point right there, dog. Shane, that's what I'm talking about. If they could show us this direct rotation overhead, look, they showed us star trail bullshit. I want to see it with the sun. It should be the same thing with the sun. If it's at 23 degrees, it should do a perfect circle at the South Pole. But when we look at them flags, we see the shadow going up and down, and working its way around. So they can't demonstrate this horse shit.
Well, hold on, real fast, Brian. I will give you that. I actually did the summer solstice thingy on my little model, whatever, and I have the camera at the South Pole, whatever, and yeah, the sun does seem to stay 23, which is correct. But those videos though, where they show like the sun, and the South Pole, whatever, right? Those aren't like claimed to be at the exact center, right?
Ah, okay. So all the spots they claim as the South Pole, they're really not the South Pole. But look,
They're not claiming them
show me
to be
the sun
the
do a
South Pole.
full circle. If you show me a sun do a full circle at 23.5 degrees and prove where you're at, flat Earth over. But they would have already done this, Arma. If they could have showed this, they fucking already would have, bro.
Yeah, but here's the thing though. Even if it's not doing like a full circle like above, like even if it dips a little bit, isn't that still like problematic though? The fact that you have that much like sun at once, like I don't even like how do you even like you basically you get to the point where the sun is dipping it's still in front of you. You know what I'm saying?
So you agree they haven't killed the flat Earth with the sun in Antarctica? They could kill it like that, and they haven't done it.
But I feel like sure. But sure, but I feel like the ones that are even out though, the ones that like the sun dips a little bit, I feel like that's still also for the most part destroys the flat Earth unless you have some kind of bending light. If you don't have bending light, then that should destroy it instantly. The fact that
here's
you
where
have that much sunlight.
Here's where it gets modeled. I see what you're saying, but they haven't even showed us that in the north either, bro. So like, do they really know exactly where the fuck everything is? You're giving them too much credit. Like we've got a model, it fucking works, but dude, they haven't showed this in the north or the fucking south, bro. I mean, they've showed the 24-hour sun, but it's dipping down and all that. Like, bro, it shouldn't be an act of God to go to these geographic positions, okay, and prove your fucking model, bro. It hadn't been done in no way, shape, or form.
Before we lose Geo's point, because this is something that I was asking about before too. Hey, Witsit, are you still there?
Yes.
When at the end of your presentation where you showed like what looked like a quadrupole, can you go to that part to show Geo? Because it's something that he shows similar to what he shows when he's talking about, where it shows, like the different, what I'm talking about, right?
No.
Only if you're perpendicular. To see rotation, the stars got to be perpendicular.
You're talking about P-Brain's, one of his, where it shows like 4 clusters kind of stars?
Well, no, it was, you know what I'm talking about? Towards the end of your presentation where, right there. Yeah, there you go.
Yeah, that's not a quadrupole, but yeah.
Well, no, but it's similar
to curiosity.
Geo's
I
talking
always
about.
said that one was confusing.
Don't change the subject. I want to get to this real quick.
Well,
do you see what I'm saying,
there's
Geo?
4
That kind of
celestial
looks like what
poles
you've
now.
shown before.
So now you're saying there's 5 celestial poles?
No,
or
no,
is
no.
there 8?
No, we're talking
like,
about
do you not know? Or are you guys just making up as many as you need?
No.
All right, hold on. I'm going to have to
It's not about saying in reality there's all these different celestial equators, but that your position determines what you see. And this looks similar, like, see what I'm saying, Geo? That kind of looks like your map that you've been showed before, where it looks
that is
like
one model. I did it with 3, but we got it. The stars that are perpendicular to
I'm not clear. Now Brian's going to sideswipe into something else. What are you saying?
Yeah,
if you were interrupted originally, can you repeat that? Try to.
Well, you see how what he's showing right now kind of looks like what you've shown before, as far as like the what's seeming to be a quadrupole.
Yeah.
Right. So explain this, Witsit, how this, like you did in your presentation.
Okay, so this is just each observation is obviously individual to the observer. Not all 4 of these people can actually see anything known as the South Celestial Pole at the same time, but it doesn't matter. There's just going to be an optical convergence around a singular point in the sky for each observer, and actually they'll technically not be directly ahead. It'll be slightly around, but it's just an optical effect relative to each observer. Like just like the anti-crepuscular rays looks like they converge into a singular point. When you're looking south and the stars are moving over top of you counterclockwise, you're going to perceive them the opposite direction going around a singular point, just like here at the bottom. And that's going to happen. That's going to happen for each person because you're
perpendicular to each person.
Yeah. Well, I have can I bring up my paradox real fast?
No, Arma, wait. We want to get to this because Geo, this is something that I was also asking about. So what I was saying before too is like we have a celestial equator starting at one point that we know of and ending at another point, right? What Geo's saying is if it's all about your personal dome, then wouldn't you have that same effect no matter where you are, where you're seeing this southern and northern?
No, bro,
rotation?
only perpendicular, bro.
I know. I'm not saying
perpendicular.
Wait, Brian, don't butt in. Let Witsit or even Shane or anybody else explain why that's not the case, because it's not about it. It's not saying that there aren't any southern stars, that it's not just this dome reflection of the northern stars, like troubled things that people are saying sometimes. It's about. Go ahead and explain it.
There's only one point perpendicular to each person, bro.
Right, I know, but
That
Brian,
doesn't make any sense.
let Witsit explain it, or Shane or something, because this is the part that makes it confusing. Because it's like,
So,
wait a minute, we seem to have a celestial equator at one exact point. Wouldn't that be the case no matter where you are on Earth then, if it's all about your personal dome? Go ahead and clarify.
You don't mind what's it?
Yeah, go ahead.
Right, so most of the known world, like 80 to 90%, sees the northern physical actual rotation. We live in the northern hemisphere, we see the actual center point. Only when you get far enough away from that center point does the counter convergence induced by perspective come into play. And again, only in the south, while looking south. Does that help at all, or is that just more?
Yeah, so each person's going to have a perpendicular. There's only one point for each person that's perpendicular to the north, and each person is going to have that around the flat Earth, a point that's perpendicular, and everything's going to rotate around it due to perspective. There's no getting
Brian,
around.
Brian,
What makes north in the center? Why can't south be in the center?
I think maybe
why can't south be in the center? How do you know north in the center? Like you could flip it.
Can you let Geo ask questions real quick, everybody? Because I think Geo is trying to get to this point, and I'm trying to clarify between the two.
Well, I was just trying to respond, but I haven't. Yeah, it's a lot of people wanting to get in. All right, so like let's say with corpuscular and anticorpuscular rays, like no matter where you are on Earth, you can get those. You can get the convergence, at one, like where the sun's setting and then 180 degrees, you're going to get that thing, you're going to get that effect. So if the stars, the southern star rotation was only caused by your personal atmospheric dome, then it seems like anywhere you would be on Earth, you would have a northern rotation and a southern rotation and an equatorial equator in your personal dome. The fact that it only occurs in certain positioning, like when you go further south or further north, to me shows that it is something in the actual sky that is occurring, not just the personal field of view.
Which is sound. That's sound logic.
It's a course, and it's the northern point from the course and the southern point from the course. This is why you have the appearance of oppositions, right?
What if the sun was Polaris?
Can someone actually respond to what I said that would be on topic?
Wait a minute, guys. Brian and
the course of the course of the rotation. Course of the rotation, right?
Right. Can you just Data? You just came in. Can you let these guys go back and forth and clarify this point before you
give me this one.
Same with you, Brian.
Give me this one. So if the
we
sun
almost
was
need to just
Polaris,
mute everyone so we can have a conversation, because everyone's going to jump in and pull in different points. I mean, you
Yeah.
brought up one thing. I responded to one small part of it. I don't know if it's possible with everyone in here right now.
Can we let Shane? Can we let Shane and Gio go back and forth on this, guys? Everyone else, just shut up, please.
All right.
For fuck's sake.
So you said you're asking about is there a physical? Is this the celestial equator question again?
Yes.
So like Witsit said yesterday, right? They deduced the globe from the sky. So the latitude literally equals the decline of Polaris as you get away from it, right? And it's the counter for the counter rotation. So as you go south of the equator, each latitude would mark, the southern rotation point, increasing an elevation on your south pole, right? It is a facet of perspective for each person. Have you guys seen there's a video of a guy taking star trails in Sydney on the southern pole, and at different times and different nights, it's at different elevations, which would make it weird as a physical point at the bottom of a ball converging for everyone, and exactly accurate if it's an optical convergence specific to each observer.
Right. So picture every star.
Wait, Shane, real quick, Shane,
Hey, Brian.
Shane,
please.
Shane, real quick, Shane.
Gio.
What that shit that you just said, Shane, about the guy taking the altitude or whatever, the measurement. Do you have that as a link?
Of course.
I would like to see that, because that's very interesting. I never heard of that before.
But like everybody else, so shut up.
That
Please,
means
everybody
all
else
the
shut up,
stars in
including
the
you,
sky
Sean.
would be moving. Because if that's happening in one place above Australian skies, then all the stars in the sky would be moving up and down. How come it's only seen here and it's not filmed all over the world?
How the
Yeah,
fuck
that's
did
the
I
point
say
that needs to be
something directly
clarified.
to Shane? How the fuck did I say something directly to Shane and
Sorry.
other people answered?
Sorry.
Right. Well, he's got a link for you, I'm sure, but let's get beyond that.
Well, hold on.
Let's
Gio
just
has a point though. Look at those gifs. Look at those gifs in the chat, right?
Yeah,
That lens.
let's clarify that point, because Trouble's making that same argument, and that's what needs to be clarified. Shane, continue with, or whoever wants to continue with, why it is that it seems like it's not happening everywhere, that we have a celestial equator no matter where we
I
go.
got the answer, bro.
But
I
it
got the
seems
answer.
to be, Brian, stop for a
You keep cutting me off, bro.
I'm not. Yeah, you're cutting me off. I'm not even finished with my point, bro. What I'm saying is that what seems to be the problem here is that there's a celestial equator that we know that we can identify being at a certain point in the sky and where you are on the land. But what seems to be the problem for people that see this personal dome as it is creating that effect, that you would have that effect no matter where you are, no matter how north you are, no matter how whatever position you are. So that's what needs to be clarified, and I know that it's hard to grasp that, and that's for me, for myself
Okay,
as well.
bro.
Which is why
There's only
I wanted
one
to hear
spot in the
Geo.
sky that's
Yeah,
not
I wanted
moving.
to hear Geo. I wanted to hear Geo and Shane clarify
Bro,
this.
you
so
should
we can-
think like Geo. I'm trying to respond directly to Geo, bro. Nobody has done it. Okay, so there's only one spot in the sky that doesn't move. So 180 degrees to that, no matter where you're at, is the only place you're going to see an opposite rotation. In other words, it's got to be perpendicular. So if you look to the east or west, so picture every star as having its own corpuscular rays coming right at each individual. That's how we're all going to see it. So it's only going to be 180 degrees from the actual point that's not moving. Everything else is going to be doing a certain size rotation perpendicular to that spot, brother.
Why
Okay,
can't I
Brian,
see the
can you stop?
corpuscular rays coming from the star? If you're claiming that every star has corpuscular rays, why don't I see the ray?
No, I was just trying to get him to imagine it.
Okay.
All right, Geo, did that help? And Shane, did you think that you could comment on what Brian was trying to add?
Well, it sounds like to hash through what you're bringing up, it would have to be me, you, Witsit, and Shane are the only ones speaking. And so we could do an event at some point, or we could do, something. Because
could we just do that right now? Everyone else just shut up because we're there already. We're already there. Just everyone else shut up, please, and then just let them go back and forth. Brian, what trouble? Just please give it like 10 minutes without anybody else talking.
I'll back off, bro. All right.
I'm going to drop out.
Thank you.
Yeah, because with an open panel, everybody wants.
Yeah, you don't have anything else to learn here. You've already decided, trouble, huh?
This is so.
Go ahead, back and forth. 10 minutes. Shane,
what?
Are you still there?
Yeah.
Can you just clarify the whole point? The whole point. Did you hear what Brian said?
Yeah, I didn't quite get it though. I didn't quite get what he was
so maybe just try to clarify again. The fact that we see, it's not that the personal dome creates this illusion of the southern stars, no matter where you are, in the same way that it would be
right.
Yeah. Okay.
Yeah. So it's like human perspective on a massive grand scale. It's the only thing we have comparisons for. The reason that we see anticorpuscular and corpuscular rays is because it's so far above us that our vision wraps it in a dome around us. And if you just tilt that dome 45 degrees and expect what would happen at night, and have the stars pass above you east to west in perfect circles, then you can imagine that it kind of warps it around you, as all the modeling shows, as the dome footage shows, as a bunch of stuff in which its presentation actually showed your perspective doing that, right? And again, you only see it when you're far enough away from the center of rotation. Otherwise, you see everything extending outward in concentric circles from the source. Only when you get to the equator and you see the equatorial view, where you kind of see the both poles on the on 90 degrees on each horizon, and that is what you would see. And the star trails do show that, right? You don't see you see the beginnings of one pole and the beginnings of the other just creeping over the horizon, and then from that point on, or south of the equator, you no longer see the northern rotation point. It's below your horizon. You do see the stars circling around it in that direction, but you can't see the actual focal point. And the further south you go, the higher the focal point in the south induced by your perspective gets. If that makes sense.
Yeah, but the perspective thing indicates that it's something within your personal field of view, your personal kind of region. Meaning, like, if you're getting corpuscular and anticorpuscular rays, those are converging at, in front of you and behind you because they're in that personal range. But with the stars, like if that was the explanation for the stars, and we would get that southern and northern rotation everywhere. You would get it if you're in North Dakota, Texas, the equator. You would get it everywhere, and you would also have like a celestial equator in the center, just like with anticorpuscular rays, where they kind of, there's like that center line at the point at the top. But the fact that we only get that effect when you go further enough south or further enough north, to me indicates that it's not just the personal field of view that's kind of warping the stars around you. There's something in the actual sky or in the actual environment that's creating that differentiation.
I'm kind of confused by this argument. You say that in like the middle of the country, we should see the north-south pole and the equatorial view at all times?
No, you know what it is? I think because you're okay. Here's what makes it confusing. What it seems to be indicating, if it's just your personal dome that's creating the idea that there's two poles, rather than there actually are two poles, right? And we're getting, because you're saying that the North Pole and South Pole as if it's definitive where the South Pole is, rather than just an illusion, which is the idea with this paperweight idea, that it makes this illusion that the South Pole is just a reflection of the North Pole, or it's just some kind of an optical effect, rather than it being an actual point of rotation, which would make it like two rotations, like I was talking about with E1's map and all that.
Yeah, I don't think that's what's happening at all, though.
Right. So then how do you explain it in a way that where you're talking about the South Pole as if it's an actual point that affects your what you're seeing in your personal dome?
It's not. It's an optically induced counter perspective, right, from every point south while looking south. I mean, it's a weird thing to grasp, man. But again, if you think about the limits of your vision during the day, like that's what creates anti-corpuscular rays and corpuscular rays, right? Just imagine like the sun is rising on the east horizon, and those corpuscular rays are emanating outward from it in perpetuity, right? Just on to infinity. And then you turn behind you, and you still would see the anti-corpuscular rays because you can't see the end of those light beams. You can't see where they end up. It's the limit of your perspective, and it converges them in a convergence point just because that's all it can do, because it's the limit of your curved visual space, right? And that's during the day. And I'm saying it's the same thing at night while looking south, because you have to be far enough away from the center, i.e., in the south, so past the equator. If you're anywhere like the rest of the 88% of the world that lives close enough to the center of the focal point of the rotation to actually see it, then it looks normal and you're seeing a physical rotation. If you look south in the north, you can see the sort of the remnants of what would be maybe, right? But you have to get south to the equator to see the equatorial view, where you kind of get the counter convergence. You get both poles on the horizon, and then your counter convergence will just put it up further elevation from your horizon in the south. While looking south, the further south you go.
Yeah, so it seems like the equator is important regardless of the fact that your personal dome is creating this effect. And like it makes me think of like flat earth philosophy's idea with he has like that kind of like that tunnel, where it goes around. And so maybe what's that?
I was gonna say, good point about that. I asked Flat Earth Philosophy to come in here and take a chat with us about the stars and see if we can get that right, and that's going down on Thursday.
So it seems like what his model, if anyone's not familiar with it, it's kind of got like around the equator is the highest point, and then we have like kind of like a tunneling that goes in like a snake around the equator, and then inside and outside might give us different effects. So it's almost like there is a firmament, if you will, that affects the whole thing as well. So not only does our perspective of our personal dome affect the converging and diverging and appearance, as well as being closer to the equator, making it seem as though we see more of the southern sky, but the effect off maybe the firmament or whatever it is, the magnification of being towards the outside of the actual dome, creates that effect more so within our personal dome. Does that make any sense?
Yeah, sorry, I stepped away.
Yeah. Okay, so we're trying to clarify the fact that when you get past the equator, right, you're seeing more of the southern sky, and you're able to see both what seems to be the converging and diverging of these southern stars as opposed to the northern stars. So what Gio was asking, as well as what I've tried to clarify and grasp myself, is that it seems like if that were the case, it's not just like when you're way up north, wouldn't you see like a similar effect of this personal dome creating the southern and the northern stars, no matter where you are? But it's not that way. It's more like where there are more northern stars, quote unquote northern stars, because you're in that area. But as you get closer to the outside of the actual dome, the bigger dome, your personal dome is also affected to see more of the converging and diverging of these southern, quote unquote, southern stars.
Because they're spaced out further on the outer rim?
Well, no.
Maybe.
My understanding, it's just like when you see crepuscular rays, right? And then you look behind you and you start to see the optical illusion of the anti-crepuscular rays. You don't actually see them all go to a point, right? You're at a certain distance closer to the actual sun. Right, so in theory, if you went far enough in the direction of the anti-crepuscular, then you would get closer and you would see more and more closely the actual convergence point. It's like the same thing with the sky because there's a giant clock over top of us moving in actual direction. So if you look south, you're not going to see like the full convergence point because you're not far enough away from the actual source, just like with the crepuscular rays. Does that make sense? Shane, what do you think? What is your take?
No, I like that. That was very good. I think it would help if we played with Bislin's model though, because again, looking at that's kind of how it made sense to me for the first time was looking at that
you kind of
and
have
moving it around and changing the latitude and going on the equator and going to the north and pushing it out south and saying, oh.
Geo, is this getting close? Does any of what was just said help at all, or should we go to the Bislin model? I think it would help more. But do you have any questions at this point? Does any of that clarify it? I'm trying to grasp it still all myself.
I'm trying to understand.
What I'm saying, right? If you look at the crepuscular rays and you turn 180, you see anti-crepuscular rays. You can actually see those anti-crepuscular rays actually like converge all the way into a singular point. You can tell that they're optically appearing to converge into a singular point, though, because you can just follow the divergence of the rays, right? So, like in theory, if you were to go in that direction, you would see more and more of that convergence to the point. The same thing with the sky. We're under an actual rotation, right? A counterclockwise rotation around Polaris. You have to get far enough away to where Polaris is dipping down in your sky to where you're going to get close enough to the optical counter convergence in the opposite direction. Same thing with the anti-crepuscular rays, just on a giant scale over the giant flat Earth.
So then what do you think the stars are doing then? Do you think that they're just going out like fan blades, like a dartboard basically in the sky, like going out for, spacing out like that?
They could be spacing. I mean, I do think the southern stars seem to be a bit more spaced. Yes, they are.
So you don't think there is an actual rotation in the south?
No, I think that it's one gigantic counterclockwise rotation, and I think it's probably flat. And so this just clicked with me the other day. I'll drop a picture, see if this clicks with you. I'm just glad that my objective is not to claim I fully understand the sky. It's to make flat earthers talk about it.
Right.
Okay, so if we... Let me drop a picture. So imagine a dome, right? Now, I think this goes for the Earth and for our personal vision. So just envision a dome, and here's a picture of it. Okay, so this is crude. I made this on Canva, but if you see this dome, right? Now, if you were to, just like on a sphere, say you want to draw lines on this.
Do you have a second screen that's not sharing?
Oh, no, yeah. Here, I can probably just drag it into my PowerPoint right now.
Yeah.
I dropped it in the chat, but I'll just drop it on the... I forgot I was sharing. Okay, let me come over here.
If you're pointing, if you're wanting to refer to that one, we can't see it.
Yeah. Let me grab it out of the thing again. So just imagine in your mind like a dome, and just like on a sphere, here it is. Okay.
All right.
Just like on a sphere, right? If you were to draw lines around the sphere, they would as you get to the poles, they would get smaller and smaller circles. Right? That if you drew lines around a sphere. We'll cut that sphere in half. Now we have a hemisphere because that's how we see. So if you were to draw circles around the inside of that dome, it's going to be bigger circles at the bottom, and then the circles are going to get smaller and smaller and smaller. They're going to be actual circles that are level and parallel to each other, going all the way up. So I think the stars is on one of those density layers. I think we actually have literal horizontal layers above us that are parallel, and they're all confined within this dome, and the stars are on one of them. I currently think the stars are on a flat plane above us. Does that make sense? Like if you were to look up, you would see these circles right here, and this small circle would be the highest up. You see what I'm saying?
Yeah, you said this years ago, Brian's Logic on Oakley's show. When I was first learning about the flat Earth, suddenly Brian's Logic comes. I love Brian, by the way. And he comes and he's suddenly the sky's flat. I was like, what the fuck?
Yeah,
sky's flat as well.
So yeah, it's like like layering like a dartboard within a dome, essentially.
Yeah, like say you have a sphere and you draw these lines on them, right? Like on the surface of the sphere, they're gonna get smaller as you go to the pole. If you cut that sphere in half and then step inside of it and you looked up, you would see circles above you that are getting smaller and smaller. Right? So I think this explains why when we look out from the side, we see the rainbow is a dome, but when we look at it from above, we see the circle. I think this is why whenever you can have like a halo right above you, it's a perfect circle. I think it's all optical, right? Like you look at it from the side, you're going to see the dome. When you look at it straight up, right here, see, you're going to see a circle. Does that make sense? I think you're looking at this, and this is personal to you, and of course, our whole existence is fractal. So actually, it's also over the whole Earth, and it would continue down. It would technically be a sphere. We just live on the plane through the middle, so we only see the top half of our hemisphere of view because we can't see through the Earth.
So then, based on that, like on that little dome one on the left there that has the lines, how are the southern stars in your viewpoint like rotating in that very tight circular fashion in the southern regions? In terms, if it's mapped like this, if it's like a flat layer of stars within a dome.
Yeah, say the stars are at one of the lower layers, so it's on like one of the big circles, right? And it's just a you could potentially have like tons of these circles, right? I mean, you could pick any. They don't even have to be evenly distributed or spaced or anything. But so as you go further out, I think that they'd be a slightly more spaced, but they're all going to be spinning counterclockwise, right? And then just like with the crepuscular rays, anti-crepuscular rays are here. Oh my god. Right here, you're like, okay, the source of the light's directly behind you. So you aren't close enough to that anti-convergence, if you want to call it that, to see the point. So if you have to get far enough out from Polaris where it's going to drop in your latitude, this is how we made the globe, right? We took angles to Polaris as we went out, and we literally made latitudes based on the angle to Polaris. And then we get so far because it's dropping down our field of view that Polaris reaches the horizon. So now you're sufficiently far enough away from the source, so much so you can't even see it. Now when you turn around this mark, you're going to be close enough to the edge of the rotation to see the counter convergence. Well, you're viewing it all through your personal view. But if you were to put a dome directly over concentric circles, in the middle, it's going to just look like circles. You're going to see the actual rotation in the middle. But as you get far enough out, you're going to actually see, and you look the opposite direction, you're going to see them move the other way optically. And then if you're far enough away from the center, you're going to see them converge in a point. That's why I think this video is really good. Yeah, I'll play this if you want to. Yeah, I think you guys should be able to hear it. It's just a couple minutes, but I think it's good.
Yeah, it's epic.
Okay. Let's change latitudes now and let's go to the North Pole. If you go to the North Pole, the North Star would be directly above your head at your zenith. So if this is the latitude of 45 degrees, because if the equator is here, this black line, that's 0 degrees. That's 45, which is right in the middle of 0 and 90 degrees. Okay? So the 45-degree parallel, the North Star is visible 45 degrees. The North Star would be here. Okay? So if you're at 90 degree north, the North Star is 90 degrees above your head. 40 degree, then it's 45 degrees above your head. Now if you're at the equator, the North Star would be directly 90 degrees. You wouldn't even be able to see the North Star if you go past the equator. See? Watch, I'm going to show you. But first, you're going to see how it looks. See, now it arches. It's going this way because the sun is at the equator, but you're not at the equator. So the sun doesn't go directly above your head. It does this arc. It does a curve instead of a straight line. So the sun would never do a straight line at the North Pole. It would always go around you, and the sun would never do a straight line going above your head. The sun would always be turning at the horizon at the North Pole. So the sun never sets in Sweden and Scandinavia during the summer. It keeps going around the horizon, and it's never above the head or below the horizon. It's at the horizon. Sometimes it's twilight, where the sun is below the horizon, but even though it's below the horizon, you still get light because it's not a ball. Well, peep this out, guys. This is very interesting here. Look what happens when we go past the equator and we go to the South Pole. Boom. The South Pole is near the horizon. It's never above your zenith unless you go to the South Wall, which we're not allowed to go there. So no one ever takes pictures of the South Pole directly above your head except for the Army. And that South Pole going the opposite direction is just a reflection. This dome is reflective, and as that turns this way, like that, this goes the other direction.
So yeah, I think he does a pretty good job explaining it. I would probably critique it some, but so I have another video I didn't get to put in here where a guy actually just demonstrates it. He puts a dome, he puts the stars rotating or like lights rotating over top of him, and he shows that you'll actually get the exact opposite rotation towards the outside. So it's just an optical effect. He used 2 cameras to do it. Let me see here. And in fact, I'll go as far as to say no model can accurately explain the sky without acknowledging this because of this. Right, like we have all of this phenomena that has to be explained. This has to be explained. And the globe cannot explain it. See, the globe uses the azimuthal grid of vision and then tosses it in a trash can and claims the Earth's a ball. This is why they can't explain this, not that one, but they can't explain this. Why is it curving up the opposite way? Why is it extending a different layer? If there's ice crystals all throughout the sky, and that's the only thing causing this, then there should be like little circles going all the way out from here. They shouldn't start to show the opposite direction going up, right?
Yeah,
and
that's actually... Sorry. No, that's actually kind of showing that. Yeah, if you were to imagine that center part of that sundog is the North Pole, and then like there's the southern rotation right up there. Like
That's
it's like an opposite. It's like a boomerang. It's like shaped the other way. So yeah, it kind of does show that.
Yeah, and like the globe can't explain this though, right? That's what's so obviously flat earthers have been showing this for a long time and saying it's a product of the actual physical dome of the Earth. But I mean, well, how big is the dome, right? I mean, I don't buy that. But look, it does it with the moon. So it's going up the opposite way, and it shows this all the time. Like, this is one of the prettiest ones I've ever seen. This was on top of a mountain, and if you look, it also shows it here in just a second. At the top, you'll see it start to go the oh my goodness. You start to see it going the opposite way right here. Boom.
Yeah, it's like flaring out.
Yeah. Yep. So this combined with anti-crepuscular rays.
That's got 4 of them too. That's like a quadrupole. It's got north, south, east, west. There's like 4 points on those.
Yeah, isn't it crazy, bro? Like, it's such a crazy... We see the world through curved visual space. There's like no way to explain where we live as to how we see the sky without acknowledging it. The globe, dude, they took this because they had to do this. They had to map out the Earth. Like, they had to take the dome of vision, right? This is the short GIF. Like, it literally shows how we mapped out the Earth. Like, you have your observer position, and you just, relative to your zenith, you literally establish an azimuth on the horizon, your direction. Then you take an altitude angle to the star. And we map this out 360, and we get a dome. The globe did this. That's why it's still on stellarium, time and date, and sun calc. You have to do this. It's the only way you can explain where we live at all is to map out the sky. That's the first data set. The globe took this, said there's no limit to perspective. You can see infinitely far forever. The only reason that things appear to create this dome is because the Earth itself is actually curving. They got that rate from what we see in the sky.
Isn't that the best part? That's crazy. Exactly how it feels.
Yeah, they put the celestial sphere model under your feet. What about so if it's a limit, Austin, to your view, this personal dome, limit implies that you can't see past that, right?
Well, okay.
Can you see past it?
Good question. So you can see stuff that's past it, but you can't see it until it reaches your limit. Does that make sense? So, like,
well, I'm just thinking if you can see Polaris from the equator, that doesn't make any sense to me. If it's a small local.
Check it. So you have your limit of view, right? Say this star can be way up here, okay? But you're not going to start to see it until it's right here. That's why we'll see difference in actual and apparent positions, because we don't begin to see it till it gets within our field of view. So it can be further than that, and you can still see it. Well, it's light. So yeah, you see the light, but you can't start to see it until it gets to your personal view.
Right.
It can be way further, but you can't see it till it gets to that view.
So then from that perspective, if you have like 5 people that are all looking at Polaris from different, someone's in China, someone's in Europe, someone's in North America, different areas, and they can all see Polaris in that viewpoint, they're not all actually looking at Polaris. They're all actually looking at Polaris kind of that has traveled to them and is within their limit of what they can see, basically. So it's kind of within like an apparent position of it for each of them.
Just in a different position.
And we know that because we know that it's a perspective issue and that the things drop because of perspective, just like the clouds right here. The clouds in the background are looking like they're going down, right? This is just perspective. The clouds. Ask the Globers: are the clouds touching the Earth and going down behind the curve of the Earth? Beside the sun that's going behind the curve of the Earth? No, things drop in our optical view once they reach our limit. They hit the curved area of our limit. Same thing with these clouds. They look like they're going down in the distance. That's just because we have a limit of view.
Right, so in that perspective, it's like it could almost be said as simply like they took our hemispherical limit of view and turned it into a spherical reification.
That's what they did.
Exactly.
And then we can see forever. And then they draw straight lines from our eyes and pretend to make them smart. Do like 7th grade geometry. It's wild.
And that's why the sky can be kind of converted into a globe model in that way.
Well, it's
that's how we made it. Yeah,
right?
that's how we made it. That's literally how if you look at the history, that's quite literally how we made it. We looked at the sky, made the globe. We looked at the horizon, took an average of how far we can see over water, and then made the globe with those 2 data sets combined.
Like Nathan Oakley said, right? They hijacked perspective and turned it against you, and that's how the war was started. That's exactly what they did. Every single argument we have comes down to overflip. It's literally a battle of perspective on every facet of this argument, right? Curvature, stars.
Great word.
It always comes back to that.
And then you could even convert that to like the worldview perspective, someone's perspective on the world, like in a different context, like what they think the Earth is. Yeah.
That's why I find this helped me. I think this should click with people. If you look at the dome here, right, you're going to see that's just what happens. Like if you see in a dome, it's what happened, right? And it can be demonstrated a million ways. And so when you throw this, you see this, that's what you're going to see. Now, of course, the stars do look different when we take time lapse looking south, even from the northern hemisphere. Right?
Yeah. But you wouldn't see the actual convergence point. It would be buried in your horizon because you're too close to the center.
That's right. You're too close to the source, just like with the crepuscular rays. And this right here, I think is just beautiful, dude. Right? So you have it right here. It's going to show you the stars moving within this azimuthal grid of vision.
Nice.
Yeah, this was cool. Was this stellarium just pulled all the way back?
I don't know. I just found the video.
I thought you recorded it.
No.
Oh, man.
No, because it's a flat surface, too. I don't know how they would get the 2 points on there.
But I was just I never thought to go all the way back and just show both poles.
Oh, maybe you could, just go all the way back. I'm sure that may be what it is. It does look like stellarium, huh? That is
if you could pack this into like it's a lot to pack into like 5 minutes, but maybe 10 minutes, 10 minutes, that'd be great.
Well, I mean, so I chopped up your stuff from yesterday into like a 40-minute digestible chunk that starts with your like quick review. I thought that was a pretty bite-sized, digestible, all-encompassing piece.
For normies, Shane, are you kidding?
For people who can't watch a 3-hour thing, because a lot of people won't.
Yeah, look, what Gleam has posted, I have in here too. So this is very fascinating. So this is the stars all moving in one direction over top of a flat Earth. They're all moving around Polaris. That's the actual rotation. We know there's a rotation, obviously, right? I mean, we can even pick it up with the gyro, it seems. There's just a coincidental perfect correlation with the sidereal rotation. but not with the orbit, which actually shows you that it's in fact the sky that moves. But
Yeah,
anyway, so
yeah,
this is basically what they're saying. This is what that girl was saying. It's what they're all saying. This is what they're saying that it should look like on a flat Earth. You should look all the way out south and just see the stars all moving above you in one direction.
Yes. That is the common misconception, right? It's like when P-Brain says you'd expect to see the sun rays emanating out in perpetuity, but in fact, that's not what you see. You see the counter-convergence anti-crepuscular. And when you add the Atmos, that's what you see in the sky too.
Exactly. When they added the atmosphere in the program, it began to perfectly match the star trails that we see. Now,
That's a different argument, though. You were just making an argument that it's
see how you
perspective.
jumped in and
Yeah,
you were
there's
just
no
absolutely
argument.
dunked on, dude. Like,
No, because
get out of the lane, Arma.
No, because you just said now you're saying it's atmosphere now. So is it atmosphere or is it perspective? I mean,
Did you remember when I told you you were going to get dunked on?
I never got dunked on, first off, but
Well, you're in the lane. You need to get out of the lane. So, okay, I was literally in the process of finishing my statement where I was saying, well, what it actually is doing is acting like a lens. So our eye is a lens. The atmosphere acts like a lens. So with the atmosphere being an additional lens, it exaggerates or exemplifies the effect of our personal viewing limit that's curved. So whenever you add the atmosphere, it's like putting on a magnifying glass or thicker glasses. It exaggerates the effect. And when you exaggerate the effect via the Atmos, then this is what you're going to get.
Provable.
Got it now, Arma?
That was an and one.
Yeah, the old and one. Nuts in the face dunk.
He said, is it a personal dome or is it perspective? It's actually a perspective-induced personal dome of atmosphere. How's that, Arma? Does that help you out?
This still doesn't. I mean, like you still have two pictures. You have the bottom one and the top one. The bottom one has none of that effect, and you have the top one.
There's a very good reason. Yeah, but that's exactly the point, Arma.
That's literally the point of the program, Arma.
All right, if you guys want to believe that.
What do you mean believe it? All we did was account for the atmosphere, and it made the star trails match reality.
No, it didn't. It barely did. You still have warping at the bottom.
These are observations.
Dude, have you never actually looked at the star trails in reality?
Me personally, I mean, would have to time lapse that for you to get star trails.
It's 2.5 hours.
Honestly, man, I didn't until I started doing flat Earth, and until I came across this argument like last September, right, when I had this idea that it made sense to me. And now every time I go out, I look at it, and I notice that when I bring my dog out twice at night within 2 hours, the big Orion's belt actually moves a good 20 degrees in its circle that I see perpetually. Right now,
Like
I notice
a wheel.
that. Yeah,
Like a
I never
wheel
actually
almost.
noticed that my whole life.
Yep.
This
It
is
moves
exactly
like a
what it looks
wheel
like in
across
reality.
the sky.
Yeah. I don't know what you're
The
considering.
wheel keeps on turning.
Yeah,
The
Journey knew
wheel
what's up.
in the sky keeps on turning.
Arma,
Right?
do you deny that this is exactly what the star trails look like in real life?
That right there,
Yeah.
on screen,
Yes.
they do not look as fucked up as that. Look at that. What's that
See,
bottom? What's that at the
have you
bottom
ever
right
looked
there?
at 'em?
I've seen plenty of videos. None of them have that bottom shit.
Okay.
Come on, man.
Come on, man.
Right there, equatorial. There it is.
Yeah, where's that warping bottom?
That's a compilation of equatorials. That's awesome.
Yeah.
You're not showing me that warping bottom. None of these show warping bottom. They literally are perfect circles for the most part. If obviously with like the lens distortion or whatever. But what I'm saying is like if you go back to that video that you were showing, right, the bottom of that circle was literally just like open almost. It was like it was all fucked up.
A particular picture that shows it perfectly.
You don't see them on the horizon. Majority of them. Some of
That's
them
correct,
do breach through.
Gleam.
Look at the latest one.
Gleam.
think
Where do
it
you
must
stand on
say-
it? Aren't you a Glober? Do you think we see the stars? Do you think we see the stars like we're explaining as a Glober, or are you?
We do see the stars. I do a perfect analogy where we could be shipwrecked. Me and you could be shipwrecked on an island, and literally say to each other, "Do you think the Earth's flat or globe?" And we could go away for a year, map the whole stars, both map out reality, and come back together. You would have a flat Earth map working on reality. I would have a globe Earth map working on reality. They both work because you're building it off reality.
Yep.
That's
Now,
funny.
what's causing us to see what we see?
Well, here's another thing though. There's another big issue with this though. If I'm correct, that little simulation that person did, I'm pretty sure they're only applying this effect to the sky itself and not to the rest of the person's vision. All right. If we want to be like, if this is gonna be genuine, we should be applying this to
It's a
everything.
widescreen camera. It's a widescreen camera, and he moves around the model. You can move it. It's a to scale model,
No,
and
the
it does.
simulation.
the simulation, you can actually see the 2 poles as well, even though it is just a one disc at the top, like a record player.
Yeah,
when you zoom out down into land view, he is actually about 1,000 foot off the Earth, I think. But if you zoom down into that view, you put yourself in a wide-angle camera, which you did, and then you add the atmosphere effect.
Yeah, atmosphere effect. That's what I'm on about. I'm saying I'm pretty sure he only adds this effect to the sky or whatever. Like he's not actually applying it to, the camera here in this little program. Like if you want to be,
we see the sky through.
It's volume.
Okay, that's fine, but like you're making this whole argument that it's perspective only or whatever. Like you don't understand that whenever Globers argue perspective, we're talking strictly like just
7th grade
perspective.
trigonometry. Yeah.
Yeah, what you're showing right now, that's not what I see. And if you put the sun in that, check it out.
We did put the sun in it. There it is.
Yeah, I see.
So what I'm saying is I don't fully agree with their assessment because they say just the atmosphere. And I'm saying, well, we have an azimuthal grid of vision that we view through the atmosphere. So again, I gave you the analogy, which is like it just exemplifies or amplifies the effect like a magnifying glass.
I mean, if you want to,
Dude, the Bisland's model really is the best to get the hang of this. Like, if you move it around, change the latitude, go up and down, watch what the observers see, and it makes a lot of sense.
But
I'd like to do side by sides of the Bisland model and like actual star trails. That usually sells
Before we do that, let's go ahead and play their rebuttal for them.
Dude, so great.
Before you say it, Armin, we'll just play the AI saying it.
And for that model to work, bendy light rays.
Bendy
My
light
daddy
rays.
MC Tune said light can't bend that way. Stupid flurf. Ben. D. Light. Rays. Ah.
Refraction and space-time exist where bendy light rays occur.
Yeah, but it's okay for them though.
Sure they do.
So we can get that out of the way.
But Walter can actually press delete on the atmosphere, and it will be a vacuum domer theory. Pretty good.
Dude, I'm pretty sure Walter's gonna take down that model. We keep pushing this.
Yeah, maybe so. Especially if Thanks Walter catches on.
They took down Null School, but we kept a copy.
Yep. And did you know that I guess the same guy that made that, bobwins.com, he went and bought whatsitgetsit.com, and he heard Bryant talking about, we can map out all the clouds. We can map out all the clouds. And he's like, yeah. Jaren's trying to tell him, dude, here's a program that says they can predict the clouds on the Earth for like, decades. And he's like screaming. He's like, no, it's all definitely not from satellites. Admittedly, here's where they say they get their website data. It's actually from the balloons. They put one up every day in all these different locations. He's just like, no, we can see the clouds and they match the data. He's like, yeah, so does this program. And it comes from real life data. And he said Flat Earth could never do that. So he actually took that website domain and put on there all the cloud data mapped onto a flat Earth. And it's like basically live data. It's a couple hours late.
And they called it whatsitgetsit.com.
Yeah, but then I contacted him. I'm like, dude, I want that domain. So I'm trying to switch it over to like my website. So I think it might not even pull anything up right now. Still pretty funny. He's like, I captured this domain for you. I figured we would do this while we're at it. It was funny.
You should be able to. So you should be able to claim that domain based on your public expressions. You've been out
Oh,
there.
he gives me for free. All right, he's a flat earther. Like he made bobwins.com.
Which is awesome. It's an awesome resource.
Yeah.
It seems like some of these guys that have the computer skills and the graphic design skills could even make something like Walter Bisland's, but even better, like even with more detail and a better map, because the AE map thing he has on there is pretty shoddy. And there's a bunch more features that could be added onto it. It'd be cool. Like
that would be cool. That's what I think we should do. And we should keep moving. We should integrate, like one of the things you could check off would be a toroid around the Earth and like keep building the model intricately. I can't do it. So.
Yeah.
Could put toroidal ether wind in there, showing why the pendulum drifts.
There's no ether
If
wind.
you could overlay Bob Wynn's data, if you clicked it on there, you can like it just all in one place to go. Explains the sky, explains the magnetic field, explains the precession, explains the sidereal rotation, explains the magnetic field, the magnetic flux data, explains the ocean currents, the wind currents.
We should take back the sky as flat earthers, I think.
Yeah,
It shouldn't be something that we just point from. It's something that we should like dominate.
I agree. So I've been trying to get Glovers to answer my question. Why are these shapes? Why do ice crystals create this shape? I was trying to say, oh, it's refraction. And don't you know that refraction is relative to the different angles that it enters? I'm like, why wouldn't it all be the same angle in your model, though? They're parallel. So then why would we have like an equidistant displacement based on random ice crystals in the sky? That means that if they're all parallel rays hitting different angles of the ice crystals, then the refraction should be in all kinds of different angles, not equidistant. Also, there will be ice crystals everywhere, so you have circles all over the place. And
But
why
those-
does it curve up the wrong way? And why do you have to assume that they're parallel to a flat Earth?
The ether is the medium, and
Those are like
something is moving.
Semi-permanent
That doesn't
static
mean-
ice crystals.
That doesn't mean we are on a spinning ball.
Ice
Right.
crystals
Those-
only reflect if they stay in place for hours during time lapse and then stop at a perfect distance out from the sun.
That's what I was gonna say. And also, we could replicate this, and they can't with ice crystals. I guarantee that.
That's right.
Oops. It's getting fun, isn't it?
Yeah, like when we really iron this out, it's going to be really brutal because literally all the Glovers talk about is the sky, dude. They talk about the sky over and over.
What are
Did
these
you hear
kids
how
up to?
Arma got backed into a corner earlier when I'm asking him to explain the anticorpuscular rays? So people
I never
should
got
really-
backed into a corner.
Yeah, you kind of did actually.
When? So explain.
Do you remember when you got dunked on a second ago? Why are you jumping in the lane so fast again, man? Like, if you not learned to chill a little bit, like, I'm just gonna say what it is, and you tell me why I'm wrong. So,
Yeah. Did you think he wasn't going to explain Arma? Like,
Fair enough. That's a good point. Yeah.
okay, thanks.
yeah. So, basically, what Arma's saying, because I'm telling him that you can get anticorpuscular rays when the sun's not all the way below the horizon, or when it is perceivably below the horizon, and he didn't think so. He wants me to show it to him, which I'll find a video of. I saw one yesterday, but. Anyway, he's saying that the reason it looks like it's converging down is because the sun is up above the earth and the rays are shooting down and then going down below the earth physically. I'm like, no, your model claims that this is just perspective. This is not a physically going anywhere. This isn't physically showing. No, this is perspective in your own model. And he's saying, first he was saying, well, it's perspective, but it's going under the curve of the earth or whatever. So I'm like, oh, so you're admitting that even though these aren't actually going here, perspective can make something look like it's going down to the horizon and then behind it. So yeah, you did actually step in it because now you're admitting that sunsets do work on a flat Earth because you're saying that perspective can cause something to optically drop in the sky and then go down behind the perceivable horizon.
No, you're kind of missing the context. I'm saying that if the sun, right, on the ball Earth, right, is above the horizon, right, and you have rays that are parallel, right, if you follow those rays, right, from the sun that's above the horizon, those rays should be then below, all right, the horizon on the other side. I mean, I could maybe model this out on Blender or something. That just makes sense. You're sort of
either way, they're not curved.
That's the most insane thing I've ever heard. If I have a sun up above the ball and I draw a straight line out from it, it's going to go down below the ball.
Well, yeah, because I mean, the rays are shooting out from it, right? So you want to do 180 degrees from that, right? And I could model this out in Blender if you want, but that it makes sense.
Oh, you're going
though.
to use divergent rays.
No, I mean, I'll be using straight rays.
You said 180 degrees.
Are you saying that they're warping around the sphere underneath?
No, they're not warping. The thing is, they're parallel. They're straight. The thing is, the sun is above the horizon, right? So I'm saying, so if you turn around 180 degrees from the sun, all right, then those rays should be below. Those rays should end up below, all right, the horizon, whatever. I can once again model this. What?
They're still straight.
So you're saying that it's impossible to see anticorpuscular rays if the sun appears to be down below the horizon?
No, you still see them. You would just the anticorpuscular rays would just then be above the above like the horizon or whatever. I can once again model this because maybe I'm not really explaining myself. Maybe I'm not really.
You're just not making sense. And then also where he ran into a problem is he tried to say that you see the curve, just like with a dome, you see a curve. You see the curve of the rays converging down on the point on the horizon, then converging back down over here. He said that this is because they used a wide angle lens and it bent the straight line. So I said, okay, then if we used a normal lens, what would it look like?
Wow.
He couldn't answer because there is no answer. Because if you're saying that this is an imposed curvature based on lens, so that if I use a lens that doesn't impose curvature, then it would have to flatten this curve out down to the ground. So now you're claiming that the ray is literally just going directly over the ground parallel to the Earth from point to point. Obviously, if you draw a point right here where it appears to converge, and then you go over your head, which is what your model claims, and you come back down to where it appears to converge on this horizon, you have to draw a curve to connect the 2 points.
Let me see if I can model this real fast.
It's cool how that looks like a rainbow.
Isn't that crazy that like it literally does that? Like, I just think that's wild.
It just domes everywhere.
Yeah, domes,
Like
and
the-
then if
but
you look
like-
up at something, it looks like a circle. And
So like in both models, though, in reality, it's physically not doing that, right? It could be continuing out from the source from its original direction. Like consider the crepuscular rays just kept going. That's what it's probably doing in reality, but it's so far away, we can only see so far that we see this counter-induced convergence point.
right, so then he stumbled into saying, well, then yeah, it may just be a product of perspective. So now he's saying that the perspective field of view, looking at it, makes it look like it's curving, which
That's
is
pretty
our whole
close.
argument.
Pretty close to the truth, yeah.
Yeah. It's so bad for the Glovers at every turn, dude. Like legit.
This is a good picture to convey the concept, though. Like literally, that's even in the Glober's model. Like in our model, it's not really doing that either. It's coming up from the source, and we see it because it's the limit of our curved visual space. In the Globe model, it's a parallel light ray from a source 93 million miles away that just happens to look like that due to perspective. Same explanation, right? Like,
Yeah. Of course, we're seeing through an Atmos that exaggerates our perspective. This is why when it's clearer outside, you can see further. Because now you have your curved visual space. You throw a thick atmosphere in there. Well, it's gonna exaggerate this curved cutoff, so you're not gonna be able to see as far. When it's clearer outside, then you're just gonna be limited to your actual perspective limit, so you're gonna be able to see further. The Globers claim that when it's clear outside, that's when there's the most refraction that lifts things up from the furthest away. For those of us that go into reality, we realize if I go out to the beach 10 times, one of the days it's going to be really, really clear outside. And then I can see stuff crazy far away. That's what happens in reality. If you ask a 7-year-old, like, can you see further when it's clearer outside or when it's less clear? They're going to know the answer. Can I see the Hollywood sign whenever it's got more fog in Hollywood or less? Yeah.
Well, in Hollywood, the more fog, the better you see, apparently.
I think the true objective at this point is to boil down some of our current understandings to very digestible, concise points. Bring the true earthers together to polish the points.
exactly. I think we need to consolidate the basic answers and the basic arguments. Like seasons, we should have down pat without a variation. I think there's not much disagreement about that. Sunset, I think gravity, we could probably refine to a nice point, and then everyone argue the same.
Yeah, it's electromagnetic.
Exactly.
Yeah, and this should be the case, and then we should make a model. So when they say, "Where's your model?" It's like, boom, drop one that has more on it than any model they can offer. See, there is no flat Earth model. There is no globe Earth model. That doesn't exist. You model different phenomena, right? So that's how it actually works. So they have Google Earth, which is just a cartoon for adults. And then if you want to map out sea level, then you use something else. They have WGS84. That's to try to take the plane survey data, bend it around an assumed ball. But if they want to map out sea level, they use a geoid model that's completely different than that, right? Well, like if they want to explain the magnetic field, they have a geomagnetic model. If they want to explain the core of the Earth and how it sustains the magnetic field, they have a geoid model. Okay, they have different models for each phenomenon. Just like with flat Earth, if you want to explain north, east to west circumnavigation, then you can show a compass on a circle and then show a model of it going around. Right? You
Right.
model
Yeah.
individual phenomena. Now imagine when you go to one website and you have Walter Bislin's overlay with bobwins.com, overlay with the toroid, overlay with the distribution of the magnetic field, including the flux, overlaid with all this different phenomena on one page. We have a better model than they do.
Right? But which map would we use for that? Because everyone seems to disagree on that.
That's true. That's where you have to bite the bullet.
You got to rewrite the map.
Well, at
you'd
this
be
point,
wrong.
all the maps use the globular longitude and latitude coordinate system that they made for the globe, and they forced upon it via the Royal Society. Even Gleason said that's why he used it in his patent. But like technically, feasibly, we could remeasure latitude, right? If we work together all over the world.
Of course we could. Of course
It'd be a bitch, but then we could have a map.
Yeah, that's true. But the Southern Oceans gets tricky.
Yeah, yeah. But I mean, like we could at least map out, the 88% of the world that most of the people live in with, accuracy and specificity on a flat surface.
Of course, they took angle measurements to Polaris and made it on a flat Earth. Then they wrapped it around a ball. Then they turned it into a tube.
Well, and then they made sure that no maps could be issued without using that specific coordinate system, which is why we're fucking now.
Yeah, exactly. like what a joke. Like you can't even issue a map without using their coordinate system, and then they took the flat Earth angles, put it onto forced it onto a globe, and then they made it a cylinder, and then they flattened the cylinder out and gave us the Mercator projection. And people now think that if they look at the sky and it matches the globe, it proves the Earth's a globe. Oh my God. Like hurts my brain.
Pretty dang weird.
It's dumb, frankly. That's dumb. If I say, look, there are fireflies in my backyard. There are always fireflies in the summer. Okay, now look, here's my theory about why fireflies exist. Right? The ether actually hugs them and gives them an energetic exchange to their heart that then radiates a magnetic field. That's probably more accurate than whatever they say. But anyway, and then I say, look, you see my theory? Come out here, watch this. My theory predicts that when it's summertime, that there's going to be fireflies. And then we go out there and we see fireflies. And you're like, oh my God. That proves your theory. You would think I'm crazy, bro. I know, we know there are fireflies. You're trying to explain. No. I made a model from the fireflies, so now that I see fireflies, it proves my model's true. Well, no, the fireflies existed before your model existed. No, doesn't matter. It matches. If I take a neighborhood that's a circle, and then I map it out on a globe, and when I go out and show you, we walk around the circle, I'm like, oh, look, I followed this map around the equator of your globe, and then now the circle to accurately let me walk around the neighborhood. I'm like, okay, did you know that actually you're walking on the equator of a globe? Look at my model, it matches. It's just insane that people don't get that part. It's like the biggest part. It's how they did everything. Then look into the limit of our eyes and the average distance of the horizon that they used to engineer the globe, and they're like identical.
It's kind of ingenious. Kind of gotta respect it, right?
It's ingenious, and honestly, majority of it could be derived from innocence and ignorance, right? Like, then people would really go out there, see real observations, try to explain it with the presupposition of a globe. So it would only take a couple of people to make the genius decision, if you will. You would have tons of people just do it innocently and ignorantly.
And then having like Euclidean math and trigonometric functions work perfectly, and just think that applies perfectly to visual space, right? We'll use Euclidean geometry and visual space, and then we'll forever have people using math to prove the globe after that.
Yep. And then when you go look into the history of Euclidean geometry being decided, like very powerful people literally shut down the conversation when it came to the debate about the accurate geometry of visual space. Like very powerful people came and shut down the opposition and then pumped out Euclidean geometry. What?
Really?
Oh yeah. That's all the way back to Thomas Reed, the philosopher that first came up with it. And then there was an ongoing debate, and technically there still is. You can find professors to this day that are like,
Yeah,
"Oh, we're wrong."
yeah,
Dude,
totally.
is Gleam
Doing it.
still here? Thank God for Gleam dropping me those 10 things from before to get me looking into it to figure it out. That's a huge part of it. I think that's super clutch.
Yeah.
What a good Glober. I mean, flat earther he is.
Like we look at, you're a true earther in the making, bud. We accept you with open arms. If you look at the rainbow, it's a dome, but it's actually a circle. So I don't know. Seems obvious to me, at least.
You got cut off at the last part of that. But it's a dome, but obviously it's a what?
Circle.
Yeah, well, that's your perspective. That's what I think you guys are saying, really, right?
That's right. That's right. So you can see the rainbow as a dome and a circle.
But like, so this
Clearly
explanation of
barrier. Something's there.
this explanation of stars kind of works with all my other kind of mental modelings of how I think things work. There's no conflicts. It fits in nicely. So till we have a better idea, I think this is it. This is exactly it.
I think it's 100% the foundation, the accurate foundation.
What does everyone else think? Did Dave leave? Yeah. No, he's here.
I was just going to say I wish more people had seen this last couple of hours because it's been brilliant. I wish Tim had seen it, Shane, because I've been arguing with Tim for like a week over this shit.
Oh yeah, no. Tim thinks this is stupid and not right, but Tim also doesn't think that there's a counter rotation at all. So I don't know. I guess you can just deny it, but he doesn't have a suitable explanation for it if there is one, and that just seems like a weak place to argue from.
But no, I know flat earthers that have taken the videos, so that doesn't make any sense.
This has helped me out no end. I just wish you could smack it into, I don't know, it'd take a long time. I don't know what sort of video you could make, a shortened version. 10 minutes is asking a lot.
I'll try.
He does do like a 10-minute wrap up that he speed goes through. It's kind of every concept and every slide in about 12 minutes, but I thought that needed some embellishing by itself. Maybe not. An action-packed Wits at 12 minutes could do it.
Yeah, like if I just record a video, then I'll know that the sound will work. So I can just go through my PowerPoint super smooth. It'll be aesthetically pleasing,
There you go. See, that's a good idea. Then we can disseminate that 10-minute clip. I mean, dude, it took me 2 hours to explain it the first time. It took me an hour and a half to explain it the second time. It's just it's a complicated thing to get across in 10 minutes if you've never seen or heard of it and you think you live on a ball.
Especially when you have like even flat earthers asking genuine questions and you really just wanted to click with them.
Right.
So, like for a lot of people, what I did at the very end is what made it click for them.
But playing around with it, you mean?
Yeah, well, more so just how I re-explained it, I guess. Like I don't
Oh
know.
yeah, you went over it like 4 or 5 times. That was clutch too.
Yeah.
Absolutely. Like I saw people in the comments were like, I didn't get it the first, second, or third time, but the fourth time it hit me.
Yeah,
Like,
it is one of those things.
Yep.
That's why I wanted to make sure that Gio was getting it a little bit more. Gio, do you have any questions or any kind of like insights on this at this point, or are you still here?
Oh yeah, I'm here.
It kind of clicked for me when I was watching Witsit's stream from last night. Actually, I hit record on this. I don't think you were sharing screen for the live stream, so I recorded most of what we just had. Then my phone died while I was making food, but I started recording it again so we could have the visual along with it. But yeah, it's like the rainbow thing, and the sun dogs, and the fact that we see like we all have that experience of being at the ocean where the water goes off the water. We each have our own personal line of light that we can't see the other person's line of light at all, and they're standing right next to us. So it's like a perfect small example of us having receiving light individually, completely, in a totally different way. Well, not a different way, a totally different way, but an angle from our perspective, right there on the water.
Check this out. This is a trip as well. So I took a little dome and I shot a laser through it. And when you shoot the laser through it, what'll happen is it'll like create this like offshoot straight line down Like it'll come up from the ground and it'll shoot up the dome, like in a straight line. And let me show you what I'm talking about. Well, we see this in nature as well. Most people don't even know about this. But I'll share the screen because I think this is also probably personal perspective. And I originally thought it was the dome. Okay, so watch this.
Whoa.
What is that, bro? Dude, I can replicate this perfectly with a dome. This is exactly what happens if you shoot a laser through a dome on the ground and you begin to bring the laser closer to the dome. It shoots up like that.
Hmm.
So that would be it reaching our limit. That's why it happens at sunrise and sunset.
That's wicked
It
cool.
could be directed
Wow.
energy, like focus magnetism, too, to a focal point.
How crazy is that? I have a video somewhere. I'll try to find it right now on my
It's the
phone.
first time I've ever seen it. You've
Sick,
seen that
dude.
personally?
Sick.
No, but I've seen it a ton of recordings and like no one's ever heard of it.
Hmm.
Look, there it is in the opposite direction. This is again what you can see with the dome. Look at that, bro. That's your limit of view, bro. It's just
Irrefutable.
It's interesting how that's like part of the sundog structure almost. Like it's almost starting to form that.
yeah, it's
Well, that's just
Or
because
it's
it's
like
directly over your perspective point of view when you see a sundial, right?
or it seems like it could be like one component of it. The thing about sundogs, there's like all these different components. They have all these different names for the different parts of them. Like the flare up thing you were talking about that's at the top, and there's like I have a diagram that shows all the different name that astronomically they use for all the different parts of it.
yeah, they don't have a legitimate excuse either, like I was looking at. Or even their current excuse. They literally just say they say that the crystals are exactly parallel to a flat ground.
They have to. They have to.
Yeah, but how do they think that's a good idea? Like, I don't-
It's so crazy how everything's a fractal, like we have our personal energy field, our biofield around us, our aura. And then we have our dome of perspective that extends out further. And then there's like
Well,
larger dome for all of us that are inside that.
I do think everything's fractal, right? I think that's one of the reasons why I want to talk to that flat Earth philosophy guy, because he says man is a fractal of the Earth, and it's kind of like a metaphysical way. And he also says that everyone has their own arc of horizon. A lot. That's the phrase he uses, and I got to think that's what we're talking about with this personal azimuthal grid of observability thing. And that's kind of what I want to check with him about to see if the way what we're talking about it is what he envisions it, because it sounds like it's exactly the same, but I'm not sure.
Oh, this one's not good.
No, this is good shit. Every single time, it's a straight line.
That's crazy looking.
Did you just look for light pillars? Yeah, sun pillar. Oh,
Yeah. Sun pillar. Look at that, bro. That's crazy looking.
Right?
You think that they don't really know what it is? Like they just no one's ever heard of it.
Yeah. What would the ballers say to this? Well, it's going up. It's parallel.
I don't know.
That's when it becomes a religion.
Yeah, like
Have all the ballers left? Have they just like given up and are crying on their pillow right now, or what?
they did seem frustrated when we started, and now they don't seem to be saying anything.
What could they say?
Well,
bendy light rays. So
yeah.
That's the bendy light religion. Yeah.
We don't actually need them now, though. I mean,
I'm just still waiting to see that shit. Every single thing is straight line.
It's so goofy. Oh man.
Hey Shane, that video what you sent me during Austin's presentation that I asked about, the guy that's doing it. I have like a whole channel that I put his other videos on because I was picking them up from Telegram and then putting them on a YouTube channel. And I know it's the same dude, but does he go through the stars too with Walter Bislin's? Is there more of him describing that model besides that one clip?
He usually has like a video of someone else modeling and him adding commentary with his hands, usually, right? He doesn't actually manipulate the model. And I've only ever seen that one video of him, to be honest. When I saw he was scooping up the rest of his stuff, I was like, that's funny. I've only seen him once on Twitter because he tagged me in something.
He goes by Divine Being 1618.
Oh.
Right.
Where did you find him?
On Telegram, on Flat Earth and More channel.
Oh, yeah, okay.
People were posting a bunch, but there was none of the stuff about that model. But I mean, it's similar in that he's got other things that he's drawn that are talking about the same thing. But I know it's the same voice, the same guy.
Yeah, I watched one of your videos and I was like, yeah, that's the dude.
That's him. Yeah.
Oh, there's the other one with it. Yeah, that's a really good one.
So, Gio, did we clarify? Did we get kind of an explanation that worked for the reason that we don't see half and half the stars the same way? Like we don't have our own celestial equator, no matter where we are.
Yeah, it's bendy light.
Yeah, Gio, do you know what I'm saying? It's further when you get to the horizon. So it's still kind of like there's a spot. The horizon still works like it's splitting the stars, but that's because you're further south, and you guys think it's because you're closer to the outside dome that makes that appearance, or is there an actual? That's the other point. Do we clarify? Is there an actual point, a quote unquote, where the southern stars are like? Is there a seeming rotation point, and does that change with where you go? Obviously, it has to, right? For the south. Because that was my question all along. Like, if it's just your personal dome creating the idea of a celestial equator, then why don't you have a celestial equator no matter how far north you are? I think that clarifies, it summarizes the question.
Or you would have it everywhere, possibly. Yeah.
Right.
You would always have that. If it's the stars that are being constellated to your local field of view, then if that's the full explanation for why we see the southern rotation in the south, then yeah, it seems like you would always have a southern rotation in your sky, no matter where you are, because the stars in the south, or I mean the stars, sorry, kind of like the corpuscular and anticorpuscular, they're going to have those two, opposite each other. So it seems like you would get that everywhere, but we only get it in the south, and then we get the equator thing at the center, and then the one in the north.
Just on a way bigger. It's on a way bigger scale, and when you look south and north, you do see a difference in the star trails. If you're in the northern hemisphere, but you take a time lapse south, then the star trails look different.
Yeah, but you can almost see like the other, like it looks like it's buried in the horizon almost.
Yeah, because I think it's because it's actually physical. It's something in the actual sky field that's different in the different locations. Like it's a different actual tracking of, like, the stars are actually sort of like if you had, like, in your ceiling, if you had like a bunch of dots on your ceiling and you moved to different locations, you're going to see different parts of that system.
So you think that there's two rotations or counter, and the outer circle goes like back the other way?
I think there's four. I think we live in a quadrupole. So there's so like if you have like the North Pole at the center, all the continents seem to come out in the four cardinal directions. Like in a lot of the ancient texts talk about the four corners of the earth. There's also a lot of these like ancient cosmological mandalas that show the four corners and these four all coming out from the center. So I think the continents all come out in those four directions. And then, yeah, I think there's like literally four corners of the earth in a sense, at least in this area that we're in.
So what if we compare it like this then? What if the limit of our perspective is about a 25% of the sky of Earth, and then each person standing at those 4 people would just about see their personal, like, the observability limit of each one would just about touch, and then you could kind of get 4 people doing exactly the same thing that we're talking about.
Wait, say it again. I don't know if I fully followed that. It's just say it again.
So that using that like quadrupole model over there that P-Brain has, which it had it, and there's 4 people looking, in the 4 corners. If we just say that the limit of our visual perspective, if we're saying that like the size of the grid over the person is about 25% of the Earth or a quarter of the Earth, and then 4 people standing as far away from each other as they can get, then their little hemispheres of observability would almost touch. So literally, it'd be the same concept. We'll just say we increase the limit of each personal observer to 25% of the sky. Because I don't actually know how much you can see of the sky. I'm trying to figure that out, right? I know it's not half like the globe says. Is all I know.
Yeah, no, I know what you mean. Yeah. Well, I mean, the thing that P-Brain has is, I mean, I don't even think he's talking about it being a quadrupole and having 4 actual southern rotations. I've never heard anyone else say that. So I don't think P-Brain was saying that. I think he was kind of just showing. Well, but that little animation he made does happen to show kind of 4 clusters in that way.
Yeah, I told Witsit that that one, it was confusing to me before I understood. I watched that one and it didn't add clarity. It added more questions. I was confused, and then finally, when I clicked with Bisland's model, then I looked back at that. I went, oh, I see what he's trying to model. But before that, it was confusing as shit to me.
Yeah, I don't think P-Brain's. Yeah, but he's not saying that there's 4 rotations, right?
No. Usually they aren't when they use that, but that is kind of what it lends itself to, right? It's confusing. That's why I said I don't really like that one.
Well, I think he's kind of using it to show something different. Well, yeah, I think he's trying to show what happens if you're looking south.
This is like 30 latitude north here, looking south.
Right.
We see the stars going clockwise.
Yep, and you don't see the other convergence point because it's too far below the horizon. But if you move farther south, that would move itself up to be visible to you.
And what we're going to see, though, we're going to start to see, like, just like the anti-crepuscular rays, once it finishes the time lapse, you start to see where it's going.
Right there, yeah. See, buried.
Yeah, but if it's caused by your personal field of view, Dome, why wouldn't that already be the southern stars? You know what I mean? If it's caused by your personal view and not something in the actual larger dome or the larger Earth, you know what I mean? Why wouldn't it always have the southern rotation? Why would you have to move on the Earth in order to see it if it's created by your personal field of view?
We just obviously, apparently, we're splitting off here where you don't accept the other explanation. So I'm like, apparently we have different understandings of this, like where you have, like when you say we'll still see them in the sky, like when we look at anti-crepuscular rays, right? This would be interesting to test, but like, so based on where the sun is, if you get closer to it and you see anti-crepuscular rays, like, do they look different? But my overall point is that you're not far enough away from the source to see the actual optical convergence.
Yeah, but when you say there's a source, it makes it sound like you're saying there's a southern star source.
Yeah, it means the center of the rotation, the focal point, the North Pole, Polaris, underneath Polaris. That's what I think that's what he means.
Yes.
Well, I'll throw one statement out there. So I would say that whatever the northern sky, the northern pole, we see the stars rotating. However real that is, meaning it's there, we see it. I mean, we could get into like our stars physical and all those other things. But as far as that is what it is, I would say that the ones in the south are also physical things. Like, well, like I said, with leaving physical out of it, because whether they're physical or not. But I'll just use that term. Like the southern rotation is an actual rotation of stars, just like the northern is.
But like the sun is an actual sun, and we see actual rays. And when we look away from it, it looks like it's converging to another sun, but there isn't another sun there.
Yeah, right. Think of the coffee cup caustic. Think of the coffee cup caustic, but with the stars.
Yeah, that kind of concept comes into it as well.
There also must be a stationary point of reference to even bring these discussions to the table.
Well, with the crepuscular and anticripuscular rays, my thoughts on that is that if you have the sun, fairly local over a planar surface, and the quote unquote light rays, I mean, I don't think they're rays. I think it's just the way that the sun emits its energy, and then the way the atmosphere and all of that, it can look like these lines of light. Sometimes that can even be caused by shooting through clouds, which is often what makes the anticorpuscular rays, is because there's clouds cutting off part of it and then allowing for some of the quote unquote ray to be seen. So it ends up being like a band of light. So my thoughts is that as that sun, like the light is kind of coming from the sun in that sense, kind of the way P-Brain describes it, where you have that divergence of all the light and they're just spreading out over your environment. And that does make sense to me that those are then converging on the other side, because they're basically like splaying out, like
Exactly.
almost, yeah.
Exactly
They're
that.
splaying out, but like you're not just going to see them splaying out forever. Like you can only see in a local region, so they're going to then converge, just like train tracks. If you're
Right.
looking down one way, you
Right.
see it converging. You flip 180 degrees, they're converging the other way.
Right, so the stars are just emanating outward from the center focal point in perpetuity, right? Like, or until the southern edge. That's exactly what they're doing. Only one rotation.
So are
Only
you guys
one-
kind of almost saying that there's, okay, if you have your personal field of view dome thing, are you guys almost saying that there's like a slightly larger one, like either the larger dome above or some larger one that is like another set of perspective, and that's why we see the north and then the equator stars in the south? Like there's almost a bigger one that, so instead of it only being caused by your personal field of view, it's caused by like a larger one, another layer of the onion that's larger, and then now you're in that larger field of view.
Yeah,
So-
that's what I was saying. Like if there's a bigger dome and we're inside the smaller dome, then you get out to the edges of the bigger dome, that reverse effect starts to happen.
No, I don't think that at all.
But then it's still kind of good. Okay, so this is the problem, because like, okay, when we're arguing with the ballers and they use that zoom in model that we've all seen, where they show, okay, all the stars are going one direction, but then if you're at the equator, it seems like they're going the opposite because you're upside down and all that. Then our argument against that is saying, well, then if that was the case, then we should be able to see the stars going opposite directions no matter where we are. If it's just a matter of you looking, up at the stars and seeing, looking in one way as opposed to another.
Maybe this is what's not clicking. So,
right,
with the stars or with the sun, we get to where the edge of how far we can see the sun, right? And so they converge. With the stars, you have to get out to the edge, closer to the edge of this rotation to see that optical convergence within your field of view.
Thinking of the rotation as one giant ceiling spanning rotation, right? It's like one painting, one static painting on all the sky of flat Earth. It's huge, man. Huge, right? If the whole sky of flat Earth is rotating above flat Earth, right?
Yeah, we can only see so far. So we see we see the sunlight, right? And it looks like it's converging. When it comes to the stars are huge. It's a huge, like you said, a huge painting over the Earth. It's way bigger scale than these local, quote unquote, light rays from the sun. We're just saying it's the same effect. So when you get out to the edge, like to the edge of where these stars are, and you're looking at it through your personal view, you're going to have that same perspective effect applied to the stars towards the edge, and that's where you're going to see that optical convergence around one point. And you're going to see them go the opposite way. And there's no other way. Like, say that we're claiming that there are 4 different sets of stars and they're moving different ways, or that there's magnetic field and there's 2 different stars going the opposite way. Dude, when we're looking in the opposite direction, they would have to look different, right? Like, perspective necessitates that it will look like it's going the other way when you look the opposite direction.
But yeah, the question is, if it's just a matter of perspective, why don't we see stars going the opposite way no matter where we are? So it's what is it that causes the opposite direction, and what is it that when you get further out where that illusion starts to happen, and what causes that illusion?
Because you have to get out to the edge of the phenomena, in this case, light, that we call stars. Same with crepuscular and anticrepuscular rays. Like, you begin to see the optical illusion that there's a convergence in the 180-degree direction from the sun, because you're seeing out to the edge of your perspective as far as there is visibility. When you're talking about the stars are on a grander scale. They're way bigger. When you get out towards the edge of these stars that we can see here on the Earth, and you're looking through your personal view, you're going to see them appear to converge at a singular point, just like the anticrepuscular rays, but on a way bigger scale.
Right, but if that is caused by the constellation of them coming to your personal field of view, why would you have to move in order to see them? Why would you have to move position? Wouldn't you get that?
We see them everywhere. If you look south in the northern hemisphere, you still see it. You just don't see them fully converge because you're not going all the way out to the edge. It's like there's this huge painting on top of you, and you're just seeing a little bitty piece of it. So you have to get far enough out into the painting to see the edge of it, so that you like closer to where you're actually seeing the edge. So that's when you're going to see the convergence happen. You have your personal convergence, but you have this huge painting way above you. I don't know.
You know what? You know what I think of what why you explain it? I don't know if you just even went to like a YouTube video of the way that a disco ball works. Like, you know, that we all remember being in the roller rink where you have the disco ball in the middle, and then we see these counter rotations of lights, but you're like, wait a minute, why is it going this way on the ceiling? But then when I look at the wall, it's going the opposite way, even though it's coming from one disco ball, right? Kind of similar to that, maybe, like almost like that, like we get, or what I was thinking with flat earth philosophies, like a little tunnel idea, right? Well, when we get past the one, like the center point of the tunnel is the highest where the equator is, right? But then when we get out past that point, that illusion starts to happen because of the angle of this, outside dome almost, or whatever it is.
What is the angle of what is the outside dome?
Well, the way he has the tunnel, in his flat earth philosophy on his channel.
Like, this has nothing to do with the firmament, like really, like the stars. I'm not invoking the firmament at all, right?
Well, I'm saying that maybe your personal dome is affected by the larger firmament, and that's why the illusion only happens on the outside towards the edge or whatever.
It happens all the time. It happens everywhere. You can only see varying degrees of it, though, right?
Right, but why does it only happen in the south?
Because that's the only time you're far enough away from the center focal point to not be able to see it. That's why you get the southern kind of rotation.
But what's the phenomenon caused by?
The limits of your visual curve space.
Because the problem, I think, for people, and me included almost, is that when you get, like, we know that there's a certain point, it seems as though there's a certain point where the stars seem to converge, right? And we can go to any point on Earth, and we know that that's where the celestial equator is. Orion's belt runs perfectly up the middle of it consistently every day, right? So for that to be a phenomenon that makes it seem like a counter rotation, only at that point, when you get out to that point, right? What's that phenomenon caused by that makes the illusion of a completely separate set of stars? Why is it in the south only?
Separate set of stars. Where are you getting
that? It seems as though there's two sets of stars.
How?
Well, that's what we see. That's what we see with when we get to the celestial equator. It seems like a counter rotation as opposed to a clockwise rotation.
The celestial equator, which I showed a bunch of time lapse of that. It looks like it's going diagonally across the sky, and you can barely see the curves of two poles, but you see neither one.
Well, like I was thinking of this, like if you were in a room, like let's say a big room, like 100 feet by 100 feet or something, and on one side of the room there is like a circle of stars, like the Southern Crux and all that, and the other side of the room there's like the Polaris, and then in the middle of the room there's like straight lines. And if you were to like walk around that huge 100 foot by 100 foot room, trying to kind of think about it in terms of related to the Earth, you're only going to see the northern ones, the Polaris one, when you're over on that side of the room. And then once you go to the middle, you're going to see the middle straight lines, and you might see a little bit of the north and south, if you can see the overlap. And then once you start walking to the other side of the room, then you're going to see the southern one. Now that is the case because those things on the ceiling, like the kind of pretend stars I'm saying, those are physical things. Like you could put little sheets of paper or whatever it is. Those are physical things. So that's why when you walk on one side of the room or the other, you're actually seeing that. It's like an actual physical, like seeing.
Yeah, like pause it right there. Like what we see right here, right? It looks like two. Like there's. If you go back to that, what's it? Like if you paused it right there, or even just all this. Yeah. Okay. It looks like two. They're going in opposite directions. Why is it only there that we see that kind of illusion?
What's
they're
the
going
field
the same
of view?
direction.
I mean, there's so many more questions rather than just like looking at something. There's way more questions to be had.
Have you ever seen a wheel?
Well, whatever questions you have, but I'm asking this one.
Listen, have you seen a wheel in a car spin so fast that it appears to go the other way?
What makes the celestial equator special, right, is that you're far enough away from the northern pole to not see it, and you're not south enough to see the counter convergence. So literally, you see no pole. That's why you see the celestial equator star trails.
Well, when you say see it, what do you mean by it?
I don't know.
Yeah, and why is there? If it's only caused by your field of view, why is it only happen in the south?
I
Why
think
do
it's
you
both,
see a
bro. They say
real
the sun is
star?
lower down in the south, right? Real quick. I waited for a while, but I figured it best for me just leave and let them discuss it out. But let me say, if they say the sun is lower in the southern hemisphere during during their summer and stuff, when the sun is out there further, it's lower. So to me, there is some sort of a dome, not the way that they show it in animations, but a slight curve to the firmament. And that would help describe what y'all are asking for, like the rotation being more, because it's getting lower down. It's perspective as well as the elevation. Because why are they claiming the sun is lower, or we're closer? They have to say we're closer to it, but because it appears lower in the southern sky.
Well, okay, we're talking about the stars here. Just real quick to clarify, like when we have like Shane, when we see like the time elapse, or we're seeing two circles, right? It looks like a northern
you're
and a
seeing no
southern.
circles. You're seeing half of each and not a whole one, right? You don't actually see a focal counter rotation point in either direction. That's the point of the celestial equator. See, that one's a little bit too far. That one's crazy, actually. Wait, is that one real? Wait, that one's crazy. You can see both at once? That seems weird.
Well, if you do a 360 or if you do a panoramic view, you can see both the counter and the counter and the clockwise, right? What is that, and why is that an illusion for the southern rotations? And it seems like an actual point of rotation. What's causing that illusion?
Interesting. Look,
perpendicular. It's perpendicular.
Right there, like that one. Pause it right there.
Wait,
why does it look like two rotations if it's just your personal double cosmic?
This one is not real.
And they keep going to a certain.
No. There's some that are like that I've seen.
Go the other direction.
There's plenty of them.
What do you mean that's not real? Why is that not real?
You guys have all seen this. You see the spokes on a wheel, or a car, or a bicycle.
What's the field of view there?
And they go so fast that they appear to go the other direction.
Like almost
right.
like 270.
That's a slightly different phenomenon.
No,
it seems to be the same phenomenon.
The center of rotation is going to be exactly perpendicular. Wherever the stars are exactly perpendicular is going to be the center of rotation working its way out to the point.
Okay, Shane, let's say this is real. Why would this not be real? What would be the problem?
No, I thought it looked too perfect. I guess it probably is real.
You see what I'm saying about the two?
I thought it was a rendition.
Okay, so the illusion is that there's two points of rotation. What's causing that?
Your perspective, your limited perspective. If you look at that Steve Torrance model, he actually shows you it panning, and it looks very similar to that. And it actually shows you the stars moving, so they're not lit up. So you can follow it tracing down like what it is on yours from the top right-hand corner coming down, and then you can actually trace it going up. And again, it's just one motion that he's got on his model.
Can I just also jump on New Perspectives argument? Because I'm sort of kind of in the same spot, whatever. Like, what's causing this other rotation? Because like, if you were, and I've said before, if you do this with the giant ceiling fan, right? Are we expecting to see a second ceiling fan? A rotation.
Think about this, bro. Think if you got an airplane doing a circle around you, but it's too far away from you until it gets right there lined up with you, and you only see it right above the horizon, just long enough to come in for a second and then go right back out of vision. And then as the airplane gets closer doing circles around you, you're going to see a little bit bigger of a circle, So that's just the extent of your vision, and that's just the tiny time that you're seeing the star above the horizon to do, and you only see it doing a portion of an arc because it comes in and out of vision the quickest because it's furthest away.
But that would be like seeing the plane do like the opposite rotation now, because the thing is we actually see the entire we do see the entire southern rotation, like the actual center point, and like for example, see this picture right here, see how that I'm assuming that's the north maybe, but see how we see that circle, man. We see this. We sometimes see this the south just like that too, where we have like the circle above the horizon, or whatever.
Right. They're always going east to west, bro. Why are you asking that, bro? You turn around and they're doing counterclockwise. They're going to do counterclockwise. You turn around, they're doing clockwise. I mean, that's not. Why are you going backwards?
Because that'd be like seeing the plane do that, or that'd be like seeing the ceiling fan do that.
But here's my thing, dude. I've never seen what's it showing right now. I've never seen this. I've never seen a time lapse that shows this. So I don't know.
You never see that's like a wide angle.
Yeah, I've never seen that.
There's lots of pictures of this, so Shane, I think Witz had even used one of these types of pictures in his presentation.
Yeah, but not
I
a
brought
moving
this up
time
in
lapse
the
it's a
too,
picture.
guys.
That's what I said. I've only ever seen it as a picture. I've never seen it created. Like, show me the black sky and then the stars doing this from one frame of reference.
Right. I brought
I
this
think
up
it's
into my debate. We see the Big Dipper and we see every orientation of it. We see it upside down, sideways. How come we don't see the Milky Way? Like, why haven't they showed us we see the dome part of the Milky Way? I just call it the dome part, whatever you want to call it. It's lined up looking south from the equator. And how come if we're across Antarctica, why don't we see a bowl? And then we should, it straightens out. That proves its perspective, because instead of seeing it upside down and seeing a bowl, we see it straighten out as it gets closer to the horizon. We don't see it exactly opposite like we do the Big Dipper and shit.
Wait, what do you mean a bowl? What do you mean?
Well, if we're at the equator lined up with the Milky Way sideways, then it makes a dome, and that's perspective. Because if you're opposite of the Earth, on the opposite side, we should see a bowl. But we don't see that, and that proves the North ain't the same as the damn South, because with the Big Dipper, we see it completely upside down. So that dome would be a bowl if we're antipodal on a globe. But that's not what we see.
You see it go around because it's going around the edge of rotation. That's what the Big Dipper looks like. It looks like it's like a center of rotation, like a spoon. That's why they have that Nazi sign. It's like based after the Big Dipper. Is that the
Because
center sphere?
that's a hint. We see it all four orientations. So when we see the dome part of the Milky Way,
that's the quadrupole.
Okay.
Yeah, that's the quadrupole. It's the four seasons, the four positions of the Big Dipper throughout the seasons. And there's the four rivers at the north as well. The four rivers, and four islands and four rivers. I think that's the way this whole realm. It's like a seems to be this north, south, east, west, like quadrupolar magnetic system coming out from the center.
But have we not played with Bislin's model publicly? We should do that. You should bring it up. What's it?
Yeah.
I can't share.
My point was to show that. My whole point was to show that the North is not the same as the South. It's similar, but it is most certainly not the same. Because I've been looking for a few years, and I've mentioned it randomly every now and then, but I've been looking for a few years. I've cataloged about 1,000 pictures of the dome part of the Milky Way, and I see where it straightens out, but it never bowls, and it would have to if the North and the South are the same. That shows its perspective.
It should look the same no matter where it is in the sky. But if you wanted something that will do something similar to the Big Dipper, you got to find something closer to the pole. So you got to look for something that's fairly close to the pole.
But if it was perspective, though, it'd look different, though, right? If it was perspective causing that dome, wouldn't it look different?
Shane, you can. I gave you the role to share, so you can, if you want to, just screen share.
I was anticipating Gio's question, so I didn't hear what you said, Brian. Sorry.
I'm saying, but if it was perspective, we'd always see it as a bowl, right? No matter where we're at around that big circle, it would never look like if it was perspective, it would always appear as a dome or straight, depending on where it was at.
It always looks the same when I see it, if that's what you mean. I don't understand. When you say the Big Dipper, are you talking about the entire stretch, like the long line? Because it's are you talking about just the very center? Like that bowl?
I'm talking about compared to the Milky Way. I'm comparing it to the Milky Way. We should see the Milky Way the same way we see the Big Dipper. We should see it in all four orientations. And all we see is from the dome. We see it domed, and then we see it flat. It never inverts. So somewhere antipodal, like if somebody's on the other side of America for me, of the North Pole for me, they're going to see the Big Dipper completely upside down. So if I'm looking south instead of looking north, and I go south a little ways and I'm looking south and I see a dome for a Big Dipper, for a Milky Way, then somebody antipodal across the southern hemisphere should see a bowl. But if it's just perspective, then everybody who sees it when it comes around or whatever is going to just see a bowl, and then it straighten out as it gets toward the horizon. I've never seen the bowl. I've looked and looked and looked and looked. That to me proves its perspective. And so there's subtle differences.
Was anyone able to follow that? I'm just asking.
I was, but it's just there's fundamental differences between.
I follow the first one, but I don't know what he means by bowls and domes. Like why? I mean, I understand what he's saying about the Big Dipper being upside down depending on if you're looking at it on the other side of the North Pole and all that. And then he was saying Orion's Belt, or the Milky Way, he was saying, which is more around the equator. And then he was saying, why should it look like a bowl on the other side?
Well, the dome is south of the equator. The dome part is south of the equator. It stretches across the sky. So in other words, yeah. So the Big Dipper, if I'm in Canada and then I'm in, let's say, Norway across the North Pole, let's just use them for two crazy examples. We're going to see the Big Dipper upside down from each other. Okay. So if I'm in, let's say, Argentina, or let's say I'm just a little bit south of the equator, and I'm looking at the dome part of the Big Dipper, which is like southwest or whatever, is when it shows up the best. And then if I'm across the South Pole, I should see it upside down. So I should see a bowl. Why would it change orientations just from moving if it ain't perspective? You know,
it keeps the same shape in the sky, man. If you're in Norway and if you're in Canada and you're both seeing the Big Dipper, like you said, then you're gonna be looking. It's gonna be the same position in the sky at the same time of the night for each place, right? So, like I said, the Milky Way is much further south. I'm sorry, it's much closer to the equator than the Big Dipper is. So the Big Dipper is going to obviously do that rotation, right?
I'm not talking about the part of the Milky Way over the equator, bro. That'd be a waste. That would be a no.
No. I'm not talking about that part either. Even the center is still is before 30 degrees. So it's just after
you
the
look southwest. If you want to see the dome part of the Milky Way, to see it the best, you look southwest from the equator, from say a little bit south of the equator around North America and South America. You look southwest, and you see the dome part of the Milky Way. So antipodal to that.
That's not all night. It doesn't stay in the same spot all night.
Right, exactly, bro. It flattens out, bro. That's half of my point. Is why is it changing shape at all? I gotta post all my pictures, bro. I got them all cataloged, and you never see it fucking any a bolt. Would you agree that if I'm looking south or southwest, and I see a dome part of a Milky Way, just a part that curves, I should see that in all orientations somewhere on the globe, right? At some point.
Like upside down, right side up. Well, on any given night, if it's the further north or south you are, the more everything will rotate in the sky from one horizon to the next horizon and look like it's like going upside down. Basically, that's the stars that are closer there. But stars that are closer to the equator aren't going to really appear like that.
But you agreed that if it's perspective, then I'd see different. I would never see it upside down if it was perspective, right? I'd never see a bowl.
Yeah, I guess.
Welcome to Flat Earth, bro.
Are you still there, New Perspective?
So at band camp.
Well, I was wondering, I was New Perspective because we were right in the middle of that combo, and then I know Brian came in with that, but I just didn't know if he was still there or what.
I apologize. I like this presentation, by the way. It's very interesting.
Well, I was trying to be patient, Gio, bro. Every time I come in with a show-stopping fucking humongous point, bro, I feel like I'm interrupting.
You guys, much patience as the dog I'm trying to train right now. Yeah.
Thank you, sir, for your expression. Thank you.
Well, I guess, I mean, okay, like if it's an open panel that anyone can just bring up any topic they want at any point, then obviously it's kind of jumps all around. But if we're on a topic, there's also the idea of like going with that flow of thought, you know. But then it makes sense to transition as well at times. And what you brought up was related, but it was, I don't know. I guess I felt like we were right in the middle of something with the Southern Stars, and then, but so I don't know. I guess that's a whole nother thing, whether just bringing up a kind of a different topic or something that's like kind of going to change.
Yeah, I agree. agree because it felt like it's the same thing, but then I'm thinking about it and it's really not, right? Yeah, because you're talking about a different function, like something else happening. Yeah. I mean about the Southern Star Trails. I was going to say that that's it. That cut in the sky is it's a direct place. It's not like a place that changes due to where you are on Earth. It actually always looks
Right.
like it's over the same place,
Yeah.
no matter where you are.
So I'll say this: if you're, like I said before, if you're in a room, like a huge room, and you have little things you're putting on the ceiling, little fake pictures of stars or whatever. If you have, like, on one side of the room, you have ones that are like the Polaris, the other side, the ones in the south, and then you have ones that are, in the middle. Then as you move, you would see exactly what we see in on the Earth. Meaning you would be able to see both rotations, if they're rotating in places in the middle, and then they would meet in the middle, just like magnetic fields do, toroidal fields, water, rivers that flow, electric fields that create that vortex pattern. So you're going to have that meeting point in the middle, which is like what a toroidal field does. Like in those ferrocells, you can see that middle point. And then you've got the two parts of the field, the two polar magnetic flux lines. And the reason it doesn't work in my viewpoint on a globe is because if you're on a globe, the stars are spinning because you're on a particular position on the globe. Like you're at like 10 degrees north or whatever it is. So you should only see a 10-degree north equivalent circle of stars in your sky because you're making a circle on the globe. Therefore, the stars will be circling. You would never see two counter rotations on a globe. You would need to be in two places at once to get that on a globe. You need to be in the south and the north simultaneously, have one eyeball in each area, and then you could see that. So that's why it's not happening on a globe. And then I don't think it's only due to perspective, because if it was only due to the field of view perspective, then everywhere we go, we would get that effect. But instead, when you move on different places of the Earth, kind of like you're looking at different parts of a ceiling, you're actually seeing different parts of the ceiling, different parts of the rotation.
He talks about parallax.
That's a
good point, bro.
I still don't understand the argument that you should be seeing that all the time. I don't think, because like the scale of the stars is huge, spanning the entire Earth, right? Most of us live close enough to the center to see the center, and only those of us who live outside of the equator, far enough away from the center, to not see it, even see anything remotely, like the celestial South Pole. Right? It was a lot of flat earthers didn't even say it existed for a while. Right? There's still those that deny it.
The Globers still won't. The Globers still.
Sorry, go ahead, dude.
The Globers still won't admit what we see at the. I can't talk right now. My voice is fucked up. Never mind.
Well, I'd say this. So picture a circle, like a spokes of a wheel. Draw a ton of circles. For any one spot where you're at, there's only ever going to be two perpendicular points where the stars are perpendicular to that point. The inside rotation or the outside, no matter how far you go, no matter where you go, you're going to have two perpendicular points where the stars line up with you, like side to side. They're only going to line up there in 2 points, and it's going to be bigger toward the equator as and then to me, that's why there has to be some sort of firmament or something, like to explain the sun getting lower in the northern hemisphere and to explain the stars, like that point converging. To me, there's got to be a little something else going on with perspective. So to me, that answer is the firmament. It ain't like a dome like they draw and show us to scale, but it does taper down a little bit.
Do you not remember the Star Trail arguments we had where they wouldn't even agree on what we saw at the equator?
Well, yeah. So, like, I have stellarium going and seeing at exactly the celestial equator what an observer would see, looking south and looking north, right? And then I compare it with Bislin's model on the left-hand window over here.
No, I agree with you, dude. That does all map out really well. And the way, like, the celestial sphere kind of, but that's the thing, the celestial sphere tilts. You know how on his model it's tilting? How you get the south pole that kind of, I'm looking at your screen. Yeah, can you make it to where you move the sphere in to the north to the south, like in and out? Yeah, that one. See how the tilt is changing?
Yep.
Yeah, so What are your thoughts on that? Why is the
so this is exactly the relationship that Witzer was talking about. At under Polaris, it's at your zenith, right? And then the latitude literally derives from its elevation angle as you go out.
Right.
65, right? So that's the elevation angle. That's the elevation angle. When you get to the equator, it's at 90, almost drops below. That's to B to C. I think they derived that rate from distance of Polaris.
Yeah, it's 39.59.
Yeah, I think Brian made some good points about that. That kind of opened up my eyes to this too.
Yeah, that just describes the sun. The tilt only applies to the sun.
But the south, the north going down makes sense because it's the declination angle, but then the south one starts to perk up or starts to come up.
Right there, but never more than like right here. Never more than this angle, ever recorded it. Right? Parallel, parallel right there. Exactly, right here. Because you can go around this whole outer edge and see this southern rotation. And
dude, we had him denying stellarium for a while. Shit.
Yeah, we did, Jeremy, and I documented it very well too. I have a lot of them contradicting themselves when me and you were talking about the equatorial star trails. You pulled up that one that I show over and over, where the Astronomy Society legitimately claims it, stellarium claims it, but they deny it, and then they'll agree with it, then deny it. Yeah, it's hilarious.
So you see how in this position in the south, this guy's in like Australia on stellarium. If I move him around, you can't see the northern rotation. That's buried, right? Because you're too far away. You can see it, and you can sort of see it, and that's exactly what this model shows. When you're too far away from the center, this sort of oblong spheroid just receding into nothing, receding into the horizon because you're too far away from it. If you keep moving it, moving this thing literally back and forth is what made it click for me, honestly.
Yeah, it does show how it maps for sure.
You just don't think it matches reality.
No, I think it does.
Oh.
On a grand scale, but it's
I don't necessarily think I don't think his proportions are quite right, but
No, I don't think so either. I think there's definitely some issues with that, but overall, as like a analogous concept, like if you took a manipulable stellarium and put it on a map, an interactive map, I mean, it's almost identical. Because you guys know that you put this little azimuthal grid thing on, and then you can see.
Yeah, exactly.
Exactly the circle.
It basically makes that thing right over you. Yeah.
Exactly.
If he had the proportions right, and then that map that he has is pretty.
Yeah,
I think I think the stars are in an ellipse, but doing a circle. Like I think if you're gonna match it up as accurate as you can, you got to make like a tight oval of a star trail, but then spin it in a circle. And so that's why I would be interested. For perspective, the only place that would be bustable is at the very, very north center. But here's the thing: it's hard to imagine something doing a circle around you, and from the outside of that circle, but then just coming up into your vision, and literally getting higher in your vision to make an arc, and then going right back out of your vision. It's hard to imagine that, but that's what would have to happen. But to me, I didn't mean to say a tight oval, but a slight oval, I meant to say, like just a little bit off center, but then doing a perfect circle as that oval, like almost like the breath of life, if you picture it spinning and being a little bit. I think that's their tilt, but we don't need their tilt because every star stays on the same latitude. That's how, like Austin said, that's how they map the world. So they tilt the Earth to explain the tropics, and nothing more really, because the sun at any time of year stays on the same latitude for that whole day.
Bro, the Globers were literally denying what stellarium showed. It was fucking ridiculous. This shit went on for like a week.
It's still going on, Jeremy, depending on what question you ask them.
Jeremy, your voice must have just gone because earlier today you were talking fine.
So I was putting out. I know.
You must have something just shifted.
So, do you guys know what squared degrees are? Anybody?
No.
Because I was trying to figure out, what is the size?
Like bendy light. That shit sounds like bendy light.
Thanks, Flack. I was trying to figure out what the size of that like personal grid of observability would be, like in percentage wise to the whole sky, because the globe misconception is that everyone sees half of the sky at any given point, and I don't think that that's the case at all. I think it's much smaller. But if you look up what squared degrees are, they're like this non-SI unit of measurement of a solid angle, and it literally describes like the spherical viewability. And if you do the Earth, like the world sphere is what they call it, it's like 41,252 squared degrees. And I was playing around with ChatGPT to see how much of the sky, you can get it to see. And if you ask it straight up, it tells you half. But if you, do the thing where you make it, you inform it that it's lying, it's incorrect, and you bring it to these things, then it actually ends up saying that, a person can see about 4,300 square degrees. And if you figure that out, it's like 11% of the sky. And I sort of like put it on this picture thing over here. I don't know if that's right, but I think it's way less than 50. And I'm trying to figure out how to deduce those measurements.
In their world, bro, no matter what we're on, we could be all the way to Pluto. If it rotated the same as Earth, it'd be the same star trails, and then you just shrink the spots. In other words, latitudes and longitudes, everything would shrink.
Well, planisphere shows. I'll post one in the chat. One of these planisphere star charts. That's for a particular latitude, though.
Right.
Well, that one's particularly 40 north. So you can get them for different areas, but at least for that position of 40 north, it will show, that because that you can spin that disc within it. It's like 3 sheets of like cardboard, basically, or paper. There's the base one, then the one that the stars are on, and then the one on the top, and then you can kind of spin the stars. The star one.
That's perfect. That's a perfect way to figure this out, I think. So they make them for each latitude?
Yeah, make them for different ones.
All right, so then that one would show any star that person at that latitude would ever see if they never move. So literally, if we can figure out what percentage this planisphere represents of, the cumulative total of all planispheres, then we can get the percentage.
Yep. Yeah, was that you? I mean, not barring like refraction or cloud layers down to the horizon and all that, but with just the actual visible field there. Yeah. And then, and that's basically what a planetarium does too, because on a planetarium you can put in just like with stellarium, same thing. You put in your coordinates, you're going to get that whole section of the sky. But I know what you mean, how to get that exact size and then how the field of view plays into it. Yeah, to really get the modeling down, that's what would need to be looked at.
And like the mental conception when you're trying to convey it to people, because it's hard to convey a sphere of whose size I'm undetermined, right? Like this portion of the sky that you can see, whatever that amounts to, but it could be good to have a measurement for that, or a number, or even a variable, for Christ's sakes.
Hey Shane, if you can share the video I just posted. I recorded a guy that was talking about the planispheres that Geo showed, and there's 2 of them. You get one for the southern and one for the northern, and the southern one is smaller. I mean, actually, they make them like the same size sometimes, but the original ones, they showed a smaller portion for the southern, and then he goes into detail about how it could just be the outer ring of the northern that the southern's showing, and he breaks it apart and shows how they could make it seem like it's its own rotation, but it's actually the outer ring. I was going to bring this up earlier. It's perfect that Geo posted that, because he shows how.
Yeah, I'd like to see that. They literally got the people thinking that their night sky shrinks as they go north or south, like it shrinks. Like when I ask them about the Southern Cross, because Ross said it goes all the way across the sky from horizon to horizon, basically. For the time you see it, it goes from basically not exactly down at the horizon, but damn near. And then I'm asking, then like Trouble would say that it doesn't, like it stays in tight. Then what the fuck is at the horizon? If you're looking south and you only see the Southern Cross do like a small portion of a circle, then what's beyond that? I mean, I don't get it. In their world, they're thinking of it in 2 dimensions, man. In other words, there's got to be something further east and west of that circle at that location. Like they're picturing it getting tighter and tighter, like the whole world just shrinks with the fucking star rotation or something. It's weird.
Yeah, I'm looking at this video, New Perspective you just posted. Yeah, so that one shows at 3 minutes and 11 seconds. Actually, I could share it if needed, but that one's interesting because it basically shows like a disk of stars, almost like a flat disk of stars, like that star map, kind of like basically what the planisphere is, if you were to take off the top part of that planisphere model and just look at the star chart, you would just be seeing a disk of stars. Basically, there'd be like a center north and then all the stars in that type of arrangement. But obviously that's not a sphere. That's just a flat plane of stars. And then he shows how kind of like he has a little circle. He has most of them grayed out, kind of like the planisphere, but it's a little smaller than the planisphere one. And he's showing it in the south. So basically, like, imagine like the outer edge of like a minute hand on a clock, as it kind of passes over the numbers on the clock, that would be like the stars passing, in that southern region. And so how could perspective, alone twist those into an entire, rotation, like an entire circular kind of magnetic vortex? Oh, bro, something's up with your mic. Yeah, you got to fix it. We can't even hear you.
You answered your own question.
So, if I'm understanding this correctly, and I think Shane posted a screenshot at 57 minutes after the hour. Basically, you're not seeing the entire southern stars, so it can't be a celestial sphere or whatever. Is that?
Well, you're seeing all of them, right? If you have that thing rotate one rotation around, they would see the whole southern thing pass above them. Right? That's just a snapshot of what they would see from at one time. That's why it's
can you hear me now?
You could see the whole south, bro. And I said, okay, where's your Southern Cross in this picture? He was showing me his night sky from Australia. And he's like, oh, I don't know, I'll get back to you. And we haven't discussed it since then, but he showed me a picture of the south with no Southern Cross, period. Like, I'm trying to tell him it's not in your picture, bro. It's around, it's going to appear below your horizon, but it's not, you can't see it. They can see it from South America when it gets dark, right?
Hey Shane, I don't know if you were planning on sharing that video if Geo wants to, but I think it would help because it's kind of talking exactly about what we're saying. You were kind of going into detail of your description of what you were seeing on that video, Geo. I don't know if you want to pull it up, or if Shane, the one I posted.
No, chirality, you were wrong about how they spell Allah. Allah is spelled with and without an H, just by the way.
Shane, did you hear what I said?
Yeah.
Did you want a Geo to share it? Or does anybody want to share that? Because it's kind of talking about the two planispheres.
Yeah, I could actually, that is a good point. I could just share it. Although I was actually getting a screenshot to describe, because the last part that I had said, I just wanted to, because I was skimming through the video. I just did it. I just took a screenshot. That's the one I was referring to. So like if you have like, it just sort of shows, it's basically similar to a planisphere, but it's a little bit of a smaller circle.
Yeah, they have the southern and the northern. The southern, first of all, why would the southern be smaller, like to begin with? But then at the end, he shows how all of them could actually just be the outskirts of the larger one, and then he kind of breaks it down on how it could have been. I don't know. You have to watch the video.
Why does it always have to be a sphere?
Shane already took the screenshot of it. Oh, I didn't even see that you already did it.
Ionosphere, stratosphere, mesosphere. Why does it always have to be a sphere?
Because we have our own personal azimuthal sphere. We have our own personal grid, azimuthal grid sphere that we see in, and then we're a fractal of the larger sphere that we could possibly actually be in. In, not on, mind you.
Well, I think of it as, you know how when you, like I've said this many times, but it's worth saying as many times as is needed, because it's such a cool thing where if you take just like a paddle and you drag it through water, I love that, like the vortexes that it makes. Like you can take a paddle or like a wooden spoon or anything like that and just drag it through water, ideally like, calm, not like, rough water, but just calm water. And if you drag a paddle through it, it creates like just this incredible, because you're kind of displacing the water. And since you're displacing the water, it's like a dam. You're like making a dam that's moving through the water. So because of the pressure, and it's like creating that whole kind of little cavitation thing in the water. As you pull the paddle, it moves all the water. It creates these two counter rotation vortexes on either side. It creates like clockwise and counterclockwise rotations, and then those vortexes like spin, and then they meet in the middle, and they kind of there's usually multiple of them. So when you think about like hurricanes and like weather patterns and all of that as well, but I think of the sky as having that same component to it like that. It's like it's almost like the creator like dragging these luminaries in a sense through this magnetic field, and it seems to have these like polar location points that are these like nodal points for the rotation. They're like cluster nodal points is how I think about it. It's like that dual vortex, dual rotational pattern that is in the toroidal field and magnetic fields, and it's in nature. It's in the way the air moves, the way the water moves. So I just think of the sky, and especially if the sky does have some kind of liquid or like the water's above, then that would even be more correlative with the way that the vortex happen in water.
Yeah, getting the toroidal field idea into this whole thing would be, the magnetic field lines and the toroidal field, and even the black sun. Like you should watch Shane's presentation on the black sun. It was great. And how would you incorporate that into what we're seeing with these stars here, Shane and Walter Bislands?
Come on, man.
That's huge.
That's the next thing, dude. I haven't
Rome
quite
was
figured
That's the
it out.
next thing, right?
bro.
Right. That's the next thing, though, right?
Yeah, it could be crazy, dude. I don't know how to quite work that out. And if I add anything to it now, it'll just stir the pot of confusion of the thing we're already trying to convey. So I'm going to leave it alone, dude.
Right. Well, I'll post it for anybody that wants to watch it. It was a really good presentation because it does seem like there's a lot of answers there, and there's a lot of answers to this. And if we could have the grand unified theory at some point, it'd be great.
Well, think about this, dude. No, if the stars, if there is an actual dome of like a not a big giant steep dome, but like a gradual little dome that ends somewhere outside of the AE map or something, then the further you go south, the lower you're going to see the stars anyway. And they're gonna that with the perspective, you're always gonna have a perpendicular point, two perpendicular points to where you're at, with tiny points of rotation in the south. To me, I'm gonna try and model that actually.
It's an unseen.
We got to address that problem, right, y'all? What if we're on the ice wall of an AE map? If we're on the ice wall of an AE map, then if we're looking south, then I'm not going to say 90 degrees because I don't think anybody's ever proven anything but let's say we're at like 70 degrees. Well, let's just use 63 degrees because that's the farthest south in CellNav. That's the farthest south star, which that's suspicious right there. Like, why does it only go down to 63 with the stars? But it still seems like it would have to extend out a little bit further. Than
how do you measure an unseen source of projection? How do you measure it?
Well, let me ask this, and related to this whole discussion, if we see the Polaris star rotation and we all look at it and we're like, yep, there it is, all right, and we can see it from different land masses and all that, the one in the south looks very similar. Like, it's a little different, but it's quite similar just in terms of the general, like, obviously the speed that it moves, the kind of size of it, the layers of the stars. Is there any reason not to think that possibly that is another pole? Meaning, if there's land under our North Pole, who's to think that it's not the same in the south? That whatever that one in the south,
possible,
or whichever one you're looking at in the south, that under that would be another Polaris type situation.
It's possible, but then why couldn't Rube see the Southern Cross, bro, from Australia? Why, it is possible. I mapped it, with that one drawing, but why didn't Rube see the Southern Cross?
I mean, because in that idea, then there's like another star system or more land with a whole nother star system, and we're just seeing it from afar.
But that means, that means like someone. Oh no, Griffith's here.
By the way, Brian, there is a navigation star. It's almost 70 degrees. By the way.
Okay, but real talk, that's nice. But real talk, that video, I think Witsit might have shown it to me or whatever. But in the video, they make a very good point. The only two objects that you can see from anywhere in existence is the sun and moon. No human being has ever been to a location that's not underground where you can't see the sun and moon.
What about Orion's belt? I think isn't Orion's belt visible from everywhere?
No,
too?
even Orion's belt at some because of daytime you won't see it. So that's a good point. So at some time during the day, you're going to see the sun and moon. But if you're at the wrong point, then daytime is going to ellipse Orion's belt.
What
So
he's
you
saying
wouldn't even
is
see that.
either way, you're going to see the sun and moon no matter what, no matter where you are.
Yeah.
That's what he's saying.
Outside of if you locked some human underground in a box, there's no fucking human who's ever lived who has been to a location where you can't see the sun and moon. It's a universally seeable fucking object in the sky, no matter where you are.
That is an interesting point, bro. But Rui, if you
Well, hold on. Well, then do you think that the sun? Wait, you're just saying that you can see it at some part of the day. You're saying, right? At least half the day,
It
kind of thing.
doesn't matter. It doesn't matter. He's saying that we all see it. Nobody's never not said they haven't.
Right.
Nobody's gone to a place, and in that place you can't see the sun or moon. There's no place like that. The only way you can do that is to obstruct your vision of the sky.
Admiral Byrd
Or if you're
in a
an
documentary said there was
astronaut,
9 months
if
of
you're an
sunless winter.
You got enough money, you can go outside the 60th parallel for real. Maybe.
You're doing that thing again where you talk through everybody.
Yeah, I was trying to say Admiral Byrd said there was 9 in the documentary. It said that he hunkered down for 9 sunless months of Antarctica's brutal winter. That 9 summer months. That's how it would be if it were flat and we were to get like beyond a certain point. Then we instead of getting 6 months or 3 months, it would just get longer and longer to where only when the sun or the moon came near you would you see it for that time for that portion of the year. You'd never be 9 months though.
Well, if we like what I was saying before, like if we're looking at Polaris and let's say we're at the North Pole and we're right under it, and then we walk away from it, and as it starts to lower in declination, you have your latitude and going out from the center, and then obviously at the equator around there, it's going to start to not be visible, and then you're going to going south. But if that's what we experience going to the North Pole, well, obviously we're not really able to freely go there right now, but conceivably that's what would happen, as it would just keep getting higher in declination in your sky. But if we were to go south, and there's the question of what's beyond Antarctica and all of that, but the fact that the further you go south, that the southern thing that we call the southern pole, that kind of star rotation, even though there doesn't necessarily seem to be a star at the center of it, which is interesting, but it does seem to be a center of rotation either way. And who's to say that since it looks the same as the one in the north, why wouldn't it potentially be something that if you kept walking towards it through the ice or whatever is there, that southern one, wherever you are, if you're in that southern position, whichever location you're in, let's say you're in Australia, that would start to raise in your sky in declination. And then at some point, if there was more land to keep walking on, if there's more land to keep traversing, you can get through the ice or whatever it is, then potentially you would then be under that, that star.
The only problem with that is that means people in like Australia and the southern tip of South America could see the same physical point in the sky, right?
Or
if
they're
it's not
looking at different ones, or they're looking at different ones, yeah.
Or it's an optical illusion induced when you're in the south, looking south by the limits of human perspective.
So then, what would happen in your viewpoint if that's what it's linked to? What would happen if you kept going south?
I mean, you would see it higher than the 45 degrees that we typically photograph it at, but I've never seen that. As you said, only the military has.
A better point, though, bro. You're inadvertently bringing up a better point. So they've tilted the Earth so people don't think about this, Gio. You're right on target. So, like I said, they could easily prove this in the north or the south, because if it's the center of rotation, the sun, the moon, or the stars, we should be able to see a time lapse of even half a day or a quarter of a day of the stars, the sun, the moon staying even. Whatever elevation it is above the horizon, and doing a half arc, basically at that. They've confused people, talking about the tilt of the Earth, thinking that's going to change shit, but it doesn't. If we're at the center of rotation, then we should see the stars or the sun or the moon stay the same elevation above the horizon. If we're near the center, doing a circle without going up or down at all.
That's caused by the sun moving between the Tropic of Cancer and Tropic of Capricorn. That's why they have to tilt it.
Right, we'd still have to be at the middle. We'd have to be at either pole, because that would, if we weren't, then that would explain the up and down movement. But if we were anywhere near the center, like within a degree, then it would just do a circle around us at the same elevation. roughly the same elevation. That could be easily proven, dude, because they can't say, well, the stars or something like that. Just do the moon or do the sun. Do any fucking thing. Show it the same elevation circling around us. They haven't even done that with the north, much less the fucking south.
I'm going to get you guys a photo of Sigma Octantis over the next few days.
You got one?
No, I'm going to take one.
Yeah, there is a very dim star there, right?
Yeah.
Yeah.
Yeah, when you say declination, Geo, that's relative to the celestial equator, not your observer location. So it's altitude or elevation.
Well, you can have declination from your observer position. Declination is just it comes from decline, so it's the
they call it
the celestial body is declining on your.
If you want to confuse people, sure.
They call it different. They label it as a declination, bro, from the celestial equator, Geo. That's just how they label it. You ain't confusing nobody. We all know what the fuck he was talking about. But
No,
technically, they do.
Well, go ahead. Sorry. No, I understand what Ruhup's saying. I don't disagree that that's how it's used in astronomy. But I'm just saying the word declination also just correlates with like the XYZ. You have your azimuth, your elevation. There's within your personal field of view, as it were, like there's still a declination position of every celestial body within your sky.
True.
Right. Ruip was right. Let me respond to him. Bacon told me 63 being crux, whatever, or a crux. But there is one that goes. There is one that it goes down to 69, which still leaves. That still begs the question. Like that's 1,500. I mean, they should be able to just do this mathematically with their model, and the stars basically. That leaves almost 1,500 miles of uncharted. I mean, doesn't that piss you off a little bit, bro? I mean.
Not really. I mean, I don't think they even explored the Antarctic until like 1800 and something, right? So.
No.
What about Captain Cook?
If you got the model, you don't need
to. When did he go?
It was way before the 1800s.
Did he have an almanac with southern stars in it?
He's the one. He was one of the first sailors they gave the credit to mapping that shit, dude.
Cool. Did he have an almanac, or did he map the stars himself?
Oh my lord! Here we go.
I'm just asking.
He mapped 56,000 miles.
No. Did he have an almanac with southern stars in it, or did he map the stars? Like, who mapped the southern stars, and when?
What do you mean map?
Well, so you agree they haven't done it. Rup, would you agree that if we're at the South Pole, the South geographical South Pole, then we would have to see the sun do a circle around us at a certain height? Basically, let's say in the summertime, but it wouldn't go up or down at all. It would stay. It'd maintain the same elevation and do a circle around us, right?
Change a tiny bit, but yeah.
Ruin,
the equinox should do a circle.
Do you think it's possible? To go to Antarctica as a regular civilian, not involved in any militaries or governments, to be able to go there and see the 24-hour sun in the south?
Yes.
Okay, because that's not that expensive to do.
Well, maybe 50 grand. Depends how much you call expensive.
I don't even think it would have to be that much, but I hear what you're saying. I mean, depending on how many people went and what your whole plan was. But I'm just saying that's not out of reach. It's kind of amazing that after 7-8 years of this discussion raging on, that no one's done that. Not one person. Isn't that a little strange?
Yeah. No.
I don't think it'd be 50 grand. I mean, you can do like $15,000 cruises, 10,000. I don't think that's be 50. I haven't looked into it lately or whatever, but I mean, you can do. Now, I don't see. Well, one speculation I have. Okay, let's say that there's not an actual 24-hour sun. The one thing, meaning, let's say that there's 24-hour daylight, but not 24-hour sunlight. We've talked about that, like in terms of the coffee cup caustic and some of those potentials, like because that would obviously, if you have an AE map and the sun is circling, then you're not going to be able to see. There's no way I can think of seeing that actual yellow circle of the sun in the sky for 24 hours. You would see it for part of the day, and I could see it the way that you could get daylight for 24 hours because of the way that the light, I think, could refract, like the coffee cup caustic, and the way that could occur to where you could get daylight. Although that would be a unique, like, magnetic phenomenon that would be having to occur in the southern regions. But I wouldn't put it past the southern regions because that's where the magnetic field is. There's a major force field there, as it were, in terms of what the magnetic field, in terms of this sun system and this system that we're in. So Sorry, I've gone off now too long. What was I?
Yes.
Yeah.
Why haven't you guys gone to the Antarctic?
Yeah, why hasn't? Yeah, I mean that seems like what I was going to say. The last thing. Here's one possible thing. You know, they have the ability to chemtrail the skies like crazy. They can just fill your whole sky. At this point in the game, they can just absolutely fill it, and you can't see anything. So what if they actually would just be heavily chemtrailing the skies? But if we went there and did those cruises or did whatever, we could at least be able to report, hey guys, it was just chemtrails the whole time, can't see anything. Otherwise, it doesn't seem like that expensive and that big of a thing to do to actually get that verified. And that would make a huge difference.
Yeah, do it.
We'll go together, you and I.
I don't want to go. I'm fucking terrified.
We all want to do it, bro. We definitely all want to do it, but we just would you say there's any image of the sun staying the same elevation even in the north, doing a circle around us in the north or the south?
North to south. Yeah, the south. There's the Let me find it. Hold on. There's a great one. What's his name? Bobby Thompson.
Yeah, I would ask.
I mean, you don't think it's odd, Ruth, that after all these years, like there's like a bunch of fake footages of it, but like no one's actually gone and done it and just been like, yo, here's the 24-hour sun. It definitely happens in Antarctica. Like, to this day, I just...
And there's always some kind of weird glitch.
Yeah, it's like, even if it's true, even if there... Okay, let me just say this, Ruth. I'll say this right now on the record. Even if it's true that there is a 24-hour sun in Antarctica, like absolutely there's a circle sun in the sky for 24 hours. Even if that's the case, the current status of that situation is very bizarre. Like it would have to be some kind of weird glitch in the system to where after all these years, there's these weird limited, like this one guy that does all that stuff for the BBC and he's the one releasing most of them. And every single year they're fake. And every single year we look at him and we rip them apart. And then he corrects that mistake that we all pointed out. And then the next year he makes another one where he fixes the last fakery part. And then he does a new fakery that we have to figure out. And his actual recent one's one of the best. It seems like he's using a 360 camera and he seams them. The seams are we were looking at that one for hours that night. So his newest one's the best. My point is that he's been faking them for years. So that's that guy. There's another guy that's connected to big media who claims to be doing that stuff. There's like sketchy ones from he's like,
yeah, Anthony Powell. So your point is that you will not accept anything from anyone that is a glober, right? So
no, I never said that. Hold on. I never said that.
Wait, real quick, Brian. I think the point is we're not going to accept shitty footage from people we've caught lying to us before and repeatedly catch lying to us over and over again.
Right. I don't think he lies. I think he's been very upfront.
Pretty easy to see.
Robert Schwartz is one of them.
Robert Schwartz, yeah. Anthony Powell's the other. You think he was lying about looping that clip? That's not a lie.
You're fucking ain't right. He's lying, bro. He's lying about when he started it. We seen the mountain with snow and then not with snow.
He never
said it was uncut. I pointed out the two cuts in the new footage. There's still two cuts, bro. I pointed it out. Even if you don't agree with all my other stuff, there's still two cuts.
In the looped one? The one in the documentary, right?
No, not in the looped one. In the new one. In the new one, bro. They called it a glitch and then a but there's still two cuts. Glitch, whatever you want to call it. And the new one, it's not unedited.
What Rufy is saying is he's honestly presenting a deception.
I think you guys are just claiming that it's edited because you have to claim it.
It's not a lie.
We know it's edited. We know it's edited. He even admitted to it after the first one was released that it was edited. What the fuck?
Yes, he said it was looped. He never denied that it was looped.
So now you're double speaking. You just went back on your own word.
Well,
we never denied that it was looped.
Hold on, let me just say we could look into those. I mean, yeah, there's several different ones, and if you guys are obviously picking up on a previous thing. If we wanted to actually go through them, we could, and then someone could share the screen and show it and all that. We could look at if we want. But the main point I was also making is just even if it's true that there is a 24-hour sun in the south, I just didn't feel like I got to fully make my point there, even though I mostly did. But I'm just saying to me, it would still be very, very bizarre that there isn't. By this point in the game in 2023, I mean, yeah, those cruises might cost 5, 10, 15 grand, whatever they cost, but that's not that much money to be able to, someone could crowdfund it. Somebody could afford that. Ruhith, you claim that you have the wealth to afford that. It's not outside of the realm that someone in all of these discussions, because there's been many people that have been many professional fields as well, and people that likely have connections to wealth and whatnot. I'm just saying after all these years in 2023, all we have are these very sketchy, shady videos that are looped and hacked and cut. like what I've always said is that there needs to be a series of frames. That's what a consistent video is. Frame 1, frame 2, frame 3, frame 4, and they all match. The lighting, everything matches. The ones that we've been presented don't have a consistent frame order. They're hacked up, they're cut. There's some problems with them. So I'm just saying, after all these years, the fact that there's not one that exists is very bizarre.
Right. So again, what you're saying is that you won't accept anything that someone else does. So go there.
I never said those words at all, dude. I'm open to check out anything you got. I've looked at every single.
Yeah, really. Why would you have to go and say exactly not what he said as if he said it?
Right, because I don't believe the errors that he points out are actual errors.
Okay, let me help Rube.
That's different than you saying that you won't accept anything that gets posted when the only things that have been posted have been totally shown to not be real. And if it was the case, we would have so much more. Common sense tells us we would have plenty of evidence, just like we do for the North.
Well, Ruhif, also, hold on. Ruhif, if you think that, let me just rebut it real quick. Ruhif, if you think that the footage is legit, that's fine. We could go look at that, and I could share why I think, or if someone thinks it's not, someone thinks it is, whatever. We can do that. But the thing is, your response to what I said was that I'm not going to accept anything, and that wasn't even what I said. If you wanted to say what you were going to say, or it sounds like you would have said, "Oh, well, I don't think that they're faked, or I think that they're legit. I don't agree with."
Yeah, exactly. You would have said that instead of, "You won't accept anything," which shows that you're in a losing position.
Let me help Rube think critically. Okay, Rube. So in his very first one, he showed the mountain with no snow. So if it's a 24-hour sun and the mountains have a steeper angle to the sun, so they're closer to 90 degrees, so they're going to get way more energy, and that snow is going to melt. Okay, why did he show that mountain? And then when he shows the 24-hour sun, this is just one of the problems of the many, besides the two cuts. Why is there thick thick snow all over all that mountain? That's supposed to be the summer. I mean, he obviously didn't do it all in one shot, or the mountain would appear the same.
Right. So is it a problem that he comes up to the camera and said this? Well, first of all, those two shots are in different locations, by the way. Right. Is it a problem that he walks up to the camera and says, "Oh, it's 12 o'clock midnight," and then the next shot is a shot of 24-hour sun? Is that a problem? Is that evidence of fakery?
Yeah. If you start mixing locations, bro. If you start cutting film together, mixing locations, bro. Okay. Now you just told us something we didn't notice before. So now you're telling me that that it's a whole different location than his presentation?
Yes.
See, that shows you how easy it would be, bro.
But you should totally believe on that. It should be okay. There's no problem with that. We should just have this one video as evidence and accept that, even though there should be tons of it. Don't you think there should be tons more that we shouldn't be arguing about these one or two examples, Ruhif? Why isn't there a lot more?
How is it evidence of deception? How is it evidence of deception that he sticks a camera in the ground towards him, films a shot that says it's 12 o'clock midnight, then on a different camera on a different day, films the 24 hours? How is that deceptive? It's obviously a different location. How is it deceptive? That's retarded.
Well, can you prove what I was going to say is
basically,
someone wants to rebut that.
So basically, real quick, he sent the first video. We found out it was clipped up. We called him out on his bullshit. He cleaned up the bullshit we called him out on. He sent the second video. We called him out on additional new bullshit. He cleaned up that bullshit, and each time he just cleans up the bullshit that we call him out on for, and you think he's not deceptive. Great. It's like
would you like to
as
read?
If Zanuck was a photographer or something.
It's honest.
I asked about it years ago.
We have been doing this for years, Ruhif. We've been going through these for years. But let me jump in though, because I was going to get in. Let me just go once. I was just going to say real quick. Oh, Scott, we've been
going through this for years. You said
this conversation goes so fast. I'm like half out of breath, but it's okay. No, what I was going to say is just that. It would make sense that there would be less of them in the South than the North, because the North is more populated and it's warmer and all the rest of it. Like whereas the South is pretty.
Not like just a few compared to several in the North. I mean, there should be more than we. Yeah, is that what
right, it would make sense that there would be less in the South than there is in the North. However, by this point in the game, there should definitely be at least, I would say, 10, 20, 30, 40 very solid ones that have a solid order. Because the ones in the North, here's the thing, Ruhif. If we look at the ones in the North, we could go through them even now. I could point out many of the ones I've seen to where They're very consistent frame by frame by frame. You can actually go, which I've done, frame by frame by frame, 1, 2, 3, and you can see all of the frames. And it's footage, of course, so it's not going to be perfect representation of reality. Although we're looking for legitimacy, because we do know that footage can get legitimate representations of representations of reality. Meaning, if I take a video camera and video myself dancing or whatever, I look back on it, it's like, yeah, that's definitely me dancing. We know that. We all look at media all the time. So the point is that video does have the ability to represent that. And so when we look at the ones in the north, there's many of them that have the order of frames. They're consistent. Some of them might have cuts or whatever, not because they're fake, but just because the way the person, the way they looped it or whatever. But if you get one that doesn't have that, there's many of them that are very solid. Whereas these ones in the south, like I said, dude, I mean, if you think they're all legit, we could go through and you could say why you think that these problems are not there. But I just can tell you from my analysis of it, there absolutely are problems with them, meaning that order of frames is faulty. Now, what is it? Can we prove 100% that it's fake? That's tricky. But the thing is that it's already shown to be faulty. Like the order's not there. And, the thing that would need it to be for sure true is lacking.
And there should be a lot more just by common sense deduction.
Okay, so I wrote to Anthony Powell years ago and said, blah, 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 flat earthers do this. And he goes, I've mentioned a number of times in public to flat earther groups that there is a cut in the middle of the footage where it overlaps over 2 days. The editor did this. The editor did this because he wanted to start the shot with the same view as in the previous shot in the film of Observation Hill for visual continuity. If you want to see lots of flat earth comments, read what they are saying on my 24-hour sun clip on YouTube. Also read my comments in the description. Strangely, no one has taken me up on my
right,
offer.
but it's presented deceptively. It's presented as if it's a continuation, and that should be there should be like big text that comes up when that happens, so that it doesn't seem like anyone's trying to deceive somebody.
Hold on. There are still 2 cuts, bro. In the new one, there are still 2 cuts where the clouds change and where the clip goes into the rainbow looking screen. There are still 2 cuts. He hasn't gave us 24-hour like he claimed. He hasn't done that, bro.
Hang on, we'll do the newer one later. But we're talking about the one that overlaps, right? The clouds are the same when it's pointing at the mountain. Right, the editor did that to provide visual continuity for the scene before, where he walks up to the camera and says it's 12 o'clock midnight.
So you said he just handed this off to an editor, like he couldn't do it himself?
Excuses.
The editor?
Was it deceptive? Was it deceptive?
No, it's not meant. It's not meant as a video to prove to flat earthers, right?
Well, that's how it was used.
He claimed.
Yeah, I know that's how you use it.
Well, he claimed it's a 24-hour uncut, and not just him. A lot of people claimed it's an uncut 24-hour Antarctic sun, bro.
Well,
and it's not that.
I have his words in front of me, Brian. I have his words.
Okay, so you're not claiming it is either, and we don't have any video of a 24-hour sun. So what are we even arguing about?
I'm claiming it is a 24-hour sun.
Oh, but you said there's a cut that you admit to. So why is it a 24-hour sun?
It's looped.
Doesn't matter. If there's a cut, it's not a 24-hour sun footage.
It is a 24-hour sun because from the cut around to the mountain and then back around to where it was cut is 24 hours.
Okay, it's not an uncut 24/7.
Yes, the cut is more than 24 hours.
I mean,
it's not an uncut. It's not the uncut footage we would need to have proof.
As in the unlooped footage? Maybe ask him, get it? Yeah, sure. Maybe go and ask him.
Oh yeah, sure. If he had it, he would have posted it. Come on now, come on. You're just like you're striving. You're like hoping us to believe in one video when there should be hundreds already. So the point.
He's desperately trying to get us to believe in one cut up video that's been fucking re-edited multiple times. Each time we call him out on his bullshit. It's kind of weird.
Okay, so that one's looped. The first one's
looped. Kind of desperate, Rudolph. You're sounding more desperate the more you plead for it.
Okay, I'm not the one that denies every single video that comes up for whatever reason.
Another straw man. No one denies every single video.
Which 24-hour sun do you accept?
No, there's no 24-hour. How many videos do you have of 24-hour sun? How many?
Stacks. I don't know, fucking 20.
Post the ones that actually are uncut 24-hour sun in the south.
I posted one like 10 minutes ago in the chat.
An uncut one?
That's his. It's Rich. It's his newest one. We looked at it a couple. Is it a month ago? 2 months ago? We looked at it. Wits at 9. Others in here. We all went through it, and It looks like, I mean, from what we looked at, I haven't done a full analysis myself on it, but we were looking through it, it does look like the best he's done yet. But the thing is, it's like a 360 camera. We even looked up the model of the camera and how many cameras it has and the lenses. And so the thing is that like there are creases in it. There are several creases. However, that is how 360 cameras work.
That is correct.
So,
Yep.
yeah, so it's kind of a little bit of a gray area. Hard,
Oh, but I thought there was stacks for us to go through. Stacks of uncut 24/7. Where's the stacks?
Oh, sure. Robert Schwartz. Let me find a link to him. He's on Vimeo.
I think I've heard his name debunked before too.
I'm sure that you have. So what is the point of me posting that then?
If all I showed was a background, you agree that I could drive down the road with a camera and make it look like a quarter of rotation, basically, just from walking or driving or putting the camera on a. So if I'm not showing anything in the foreground, so anything that doesn't have 360 foreground to me is automatically bullshit. But I just posted the problem with his new video, and there's even problems I haven't pointed out yet. I'm waiting for enough people to call it out. There's some worse problems that I even pointed out, but besides the 2 cuts that are in his new footage, I can't believe you don't at least call question to this guy's work. When he's made
Brian,
wrong.
Hey Brian, you know what the craziest part is? The craziest thing is there could be a video that looks like it's totally uncut, that totally shows the 24-hour sun in the South. It could be like totally undetectable that it's fake, and it could totally make it seem like they got the 24-hour sun. What would that prove? Absolutely nothing, because we're obviously not on a spinning ball.
What are the cuts in this new one? The one that I posted
If even strangers, they don't even
It's
have
not in my
that.
video, bro. I just posted it in live text. Pointed the cuts out in my my video where I did a little bit of scrutiny. There are other problems, bro, that I haven't even mentioned yet.
Did you tag me? Oh, okay. 2:31. Sorry, 31 minutes past.
I can want me to DM it to you?
Yeah. 31 minutes past, yeah?
I'll DM it to you.
Okay.
DM me the other one, please. DM me the other one, please.
Cool. 1 second. Jump.
Just in case my point was lost, someone could make what seems to be a seamless 24-hour sun in the South that no one could really detect a problem with. Does everybody agree? Even if it's not a 24-hour sun, there could be a video made that makes it seem like there is. So what are we even arguing about? We're not on a fucking spinning ball.
Yeah, they had fucking space seamlessly fucking produced in all kinds of movies. It looks even more realistic than the shit they give us.
None of this means anything at all. None of it means a thing.
I got a lag on this thing, but they were doing that in the 60s and 70s, and before that, with the old world photography and photoshopping and shit.
Globe debunked.
Well, it just does make a huge difference, though, because so obviously on a globe there would be a 24-hour sun in the South, just considering their model. On an AE map, like Dave, do you think there's any way that on an AE map that there could be the yellow circle of the sun in the sky for 24 hours in Antarctica, if it's generally laid out like an AE?
Yeah, but no video could ever prove that, because videos can't prove anything, right?
I think
No, but I'm saying that if it's the AE map with the sun circling, I'm saying, is there any way in your mind that there could be a 24-hour sun in the South? So my point is that obviously if there's not, that's a huge.
The sun's only apparent. There's a possibility that it's an apparent version of the sun, or a parent sun that looks like, there's anomalies. Could be like a sundog part of the sun or something. I don't know.
Or it could be in it could get eclipsed by the blue sky or something.
Yeah, you never know. I mean, it's an apparent sun anyway. I mean, we're all accepting. We're totally begging the question, which is what irks me about these conversations about these kind of details. When we just went through a very detailed representation of how the stars work, with we're coming closer to see what seems like a very, very possible good flat Earth, quote unquote, model that outdoes any kind of globe Earth model that doesn't exist already.
If they could show me a video from the South Pole with the sun 23.4 degrees above the sky doing a circle without changing elevation, then I'm gone. I'm out here. But they've never even done that for the North,
Do you
bro.
think
That's
that
why I don't think
debunks
they've been
flat
to the
Earth?
North Pole.
Do you think a 24-hour sun debunks flat Earth?
Yeah, to me, if it doesn't change elevation, bro, if it stays the same, this is what would have to happen on a globe. And if they could have done this, they already would have, bro. They don't have to show. It just stays the same elevation and does a complete circle. They've never even done this in the fucking north, bro. Which shows me they don't know exactly where the North Pole is, because that'd be the only acceptable proof to me. And they haven't even done that in the north. But I'd jump immediately if it was real.
You're bugging, bro.
Well, in a way, Jeremy, I hear what you like. Yeah, are you saying that nothing from the sky could actually prove what the Earth is, in a sense?
Yeah, even if you went, even if you went down there and saw it yourself, that wouldn't mean it's not flat.
Right. Well, that's why I was asking Dave if there's any way he could think that could be possible on an AE map, and then he mentioned, yeah, like the apparent sun and.
Yeah, and I mean, Brian, I'm surprised you're saying that 24-hour sun would make you jump immediately, because there's so many other things. There's so many other things that would have to be answered besides that to make it actually.
I know, Brian. That makes the Earth all of a sudden have curvature and all this.
Yeah, come on. All these other things would have to go out the window.
Wait.
Come on.
In my fairness, not just the sun. Hold on. I said it's going to have to be the same. This is something they haven't even showed, period. It's got to be the same elevation. If I'm at a central point of rotation, then that sun can't go up or down. It's got to do a perfect circle right at that altitude. They can't fucking do that, or they already would have, dude.
This is going in your file, Brian.
I'm just saying they come near that.
Why would they look away from their feet to measure the shape of what their feet are resting upon?
Jeremy's going to go very light.
That's just weird.
He's going to go very light on the roasting for that one.
I can't think of a way.
I'll only roast you like once a month on that one, maybe.
Granted, we are talking about something that doesn't exist. So I'm asking for something that doesn't exist. There's nothing even close to that with the sun at the same elevation. Even, like I said, even in the north, bro. If they could do that, that'd be a hell of a phenomenon to fucking film. And that would prove to me that it's possible I'm rotating, is if the sun didn't change fucking elevation at all. It just did a perfect circle.
But to be extreme, like, couldn't you have anything over a planar Earth surface in terms of the sky? You could literally have anything.
I would ask for a rebuttal, right? I would be open for rebuttals, but that would lean me over toward. But like I said, I'm asking for something that doesn't have. That would look unnatural, bro. A sun doing a circle the same height above the horizon. That dude will never see that, because that's not natural, bro.
You're talking about the North Pole. If you were at the North Pole.
Well, the only other thing, Brian, that could possibly explain that would be the figure eight. The figure eight sun that goes around a loop like that around the south.
The thing about the North Pole. Wait, not North? Well, okay. That's not what you're talking about?
No, I'm saying they haven't even done that with the North, but the North, if they did that with the South, though, it would lead me over to the other side until I heard something feasible against it, just being reasonable. But the North, like I said, they haven't even done that in the North.
Brian, what do you think about the sun going straight on an equinox if you're at the equator?
I got no problem with that, man, because we're only, like I said, if the sun's doing a circle,
how do you explain that?
Easily, man, with the azimuthal perspective. Let me tell you.
Pac-Man map.
If we take the sun and it's doing a circle, and then we take the sun over Cancer doing a circle, okay, and we're at the equator looking east or looking west toward the set. The one that's closer to my overhead is going to naturally appear to deviate from the one that's doing a tighter circle because it's doing a wider loop. So, and perspective has things converge. I mean, so it's not only diverging, but it ain't even staying parallel. Like, at least it would stay parallel if it was just spreading out a little bit. But that shows they're going in two different paths. Right. The fact that they literally diverge. They fight against perspective.
Yeah, so you're cool with the sun. Go ahead, Joe.
No, you can go ahead. No, I think I was actually following Brian there, but yeah, go ahead.
I'm just saying, if the sun goes straight on an equinox at the equator, how do you reconcile it passing you again the next day? I'd have an easy
talking about
to see that, bro.
Wait, you're talking about the fact that it comes back around, or because he was talking about the diverging? Because I agree. Like on a globe, it wouldn't do that. anyways, yeah. Well, I was going to respond to what Brian was going to say, but
Yeah, because of the ecliptic, the sun is not lined up with you on like a quarter of the way around the globe. The equator tilts. You're tilting it. So I'd like for them to prove the plane even going straight. I think
They
everything always
incorporate
has to
that, though.
crack north.
Well, they incorporate that in a way. Like on a globe, it would just be like if you're at the equator and you're looking at the sun above the Tropic of Cancer, like let's say it's the northern summer, and you're on the equator. Yeah, on an AE map type Earth on a planar surface with an AE type map, you actually would see that diverging because it's actually making a tighter circle, as it were, in your field of view there compared to the celestial equator. Because in my viewpoint, the celestial equator is the meeting point of the rotations, of the actual magnetic field rotation points, just like in a toroidal field where they meet at the center, like the dielectric inertial plane part of the toroidal field. Well, that's what the equator is, except the equator is the dielectric inertial plane part of the magnetic field, but it's not a plane, it's the line of the equator. And the dielectric inertial plane part of it is when you go from the center to the equator and then to the south. The equator is like the center, and then of course the sun on the equinox is right there, and then of course it goes between the tropics as well. But still, the equator is obviously like a major center point in a sense, and so it's not like planar in that sense, but it's that part of the horizontal magnetic field, horizontally.
Yeah. So when they say the sun's going straight overhead, it's still not coming from straight. Like it's like kind of angled across the sky just because of their tilt. So even when it's going straight, bro, it's still angled. I mean, no matter what their explanation is, bro, it's not like doing a fucking artificial looking straight line from dead center east, compass east to dead center west. Even that's an angle because of their tilt.
What's the issue with the 8K VR one?
I gotta look at that one. But in other words, if the sun
I already mentioned that one.
Yeah, what was the issue with that?
Well, I was saying we looked at it for quite a while. Yeah, Witsit, myself, and others on the stream, like we looked at it for quite a while. No, it's pretty good for what it is. There are some problems with it. We could look over it if you want, but there's a couple creases, and then there's also a part where it looks like he puts a layer over the sun. There's like a layer that's put over it, and that happens to be right like after the crease happens. So, but see, this is what I was saying. So those cameras do have creases, those 360-degree cameras. So he does have a plausible explanation for that. However, like I said, there's like a layer with the sun that happens right around the crease. And then we were also trying to look at how many there were, because that camera claims that there's only supposed to be 2, but we found like 3, and then there was a possible 4th, but we didn't like get the finale on it because we didn't like zoom in enough, I think, and do the contrasting. So that's
a lot of work to put into one video. That, I mean, there should be hundreds. This feels like a waste of time even talking about like one or two videos.
The creases didn't even match. The creases didn't even match.
There's a barrel in the front yard of right where his shit starts, and it's the best view of any fucking obstacle to see a shadow, and it happens to show a shadow that's about 55 degrees. It's even worse than 45. Like, it's about a 3-foot barrel. It's a normal looking barrel. We could contrast it to other things. We know how tall it is, and the shadow is way less than 23 degrees, bro. And you can't have a big steep shadow like that. You can have a short shadow if you have a 24-hour sun. That debunks itself.
Is this on the one he's talking about?
Powell's, right?
Yeah, but hit the 8K one or whatever. Is that the one you're talking about?
I don't know.
I was making sure that's the one. That's one we were talking. I just wondered if that's the one you're referring to. But yeah, Jeremy mentioned the creases don't match. That's what he said as well. But Brian, is that the one
creases don't match? What do you mean?
They weren't
I might be talking about a different one. I might be talking about a different one. Sorry.
They weren't in the right spot. They should have been. They weren't in the right spot for where they should have been.
Where should they have? I don't understand how you're concluding where they should have been.
If there's 2 creases, you'd expect. Well, how many cameras are they using?
2.
So, yeah, so there should have been 2 creases, right?
Yeah.
180 degrees.
Right.
Yeah, they weren't 100. They weren't 180 degrees.
Were they 175 or like what's the point?
They were way off, bro. They were way off. Your shit sucks.
Oh, okay.
Well, you asked about that one, so yeah. I mean,
Yeah.
we gave you a couple, but I mean, we'd have to pull it up and look at it if you really want to go into it more. But that one is one of the better ones I've seen. Yeah, it is kind of his latest and greatest one. Yeah, I mean,
That's virtual reality, though, right? I mean, the one that I'm looking at. Why would we be arguing about virtual reality? I mean, anybody could do a virtual reality anything, right? VR.
No, it's
reality?
like it's like a 360 camera. It's a 360 camera that's then converted so you can use it with VR, but you can also just use it on YouTube and just pan it around.
Right when I looked at it, I'm like, dude, this looks like a video game. And then I looked at the front and it said VR. I'm like, well, I don't know, man.
Virtual reality, yeah.
I'm waiting to see Pac-Man come by and fucking walk.
Well, that's one of the better ones, like I said, though. But there are multiple creases, and like I said, there's a layer over the sun right after one of the creases, so it's pretty bizarre. There's also a part where the sun almost goes completely behind the clouds, which, you know, you might kind of think, oh, it's not a big deal. But at the same time, if there's any of that, that means that we don't have actual consistent frames of the sun the whole time, meaning it's varying, it's changing, it's going in and out of clouds, it's changing in reflection, and then there's this crease, and then it looks there's like this other layer that's put on top of it. So there's just a bunch of weird stuff. Like I said, when we look at the ones from the north, we're not having these problems. You know, the ones in the north are like, I don't even know if there are any fake ones in the north. Why would you even need to? Like, it just definitely happens in the north.
I wanted to say this about the straight sun at the equator. Like, even on equinox, if you're at the equator, and when the Earth that's on the other side, antipodal to you, is 23 degrees offset from straight. So I wanted to example that a little bit better. Like, so when you're looking where the sun sets, it's at an angle. So the sun never like goes right from the center of the sky straight over the center and sets. You know, the center rises in the center, sets in the center. Even that's at an angle is what I was trying to describe a little better.
Okay. I can barely see the second scene. Just there. There it is.
I think that's a concession from Ruhiv right there.
Oh, I found
just the tone in his voice. I think that's not the most you'd ever get.
5, 6, 7, 8.
I'm just playing around.
You know, aren't people going to Antarctica to pet penguins all the time?
Yeah. Mr.
Beast. Why aren't they just...
Probably never since they started thinking the air is killing them. Probably a lot less.
Why? Yeah, why are they just...
You probably locked it down. I don't even know if you can go anymore. Can you even go after this lockdown bullshit?
To Antarctica?
Yeah.
Sure. Why not?
I'm just saying, after all the whole last couple of years, they probably added a lot of restrictions. I mean, they're probably afraid you're going to get the penguins. You know what? The boogie juice.
Right. Pregnant or?
They're going to turn them trans and give them jabs. Yeah, that's what they're afraid of.
Yeah.
No, they're afraid of giving the penguins the old
Rona.
Yeah.
In fact, does Jeremy have the loogie at the moment?
I don't know what we're calling it these days.
Jeremy doesn't sound too good.
I don't know. I don't know what I got.
Yeah.
I mean, not to turn it into that topic, but the thing is, dude, people have been getting sick. I mean, in terms of like 1800s, 1700s, who really knows? That's a whole nother story, what was going on back then. But in our modern day, dude, I mean, yeah, like, there are these things that, you know, whatever they are, people have different viewpoints of what they are, but I don't think they're quite what they tell us they are. But I don't think this Rona thing, I mean, they're cooking them up all the time. So they're making these things left and right. You know, RSV, there's pneumonias and flus and RSVs, whatever the fuck they are, they're definitely made by them and they're pumping them out.
They literally try to make it sound scarier. They try and make it sound scarier every year, like bird flu, like swine flu, SARS, fucking, all, you know, NH, fucking. They literally rename it every couple of years and make it sound scarier and building up to this shit. But I think Jeremy got Zackley. He got Zackley. Fucking with you, Jeremy. Hope you get better, bro.
I mean, has anyone not had one of these things at least one or more times in their life? Like either a flu, a pneumonia, a really bad cold, where you just lose your voice, you're sniffling, you're sick and tired for a couple of days. And obviously there's other types of things too, but I'm just saying this has been the norm. Yeah, it's always, at least in our modern times, this has been happening. pretty
I
just.
lost about 50, 60 pounds, bro. When I was about 27, I think. It knocked me down pretty good. I got it a long time ago.
I see you put it all back on though.
You what?
I said I see. I see you put it all back on though.
What do you mean?
No, because I'm chubby, man.
Oh.
I still do 10 pull-ups, dude, even at my fattest. But yeah, I put on a winter coat, man, but I'll shed it during the summer. It's like a cycle. But I never go less than about 200, man. But I'm like almost 6 foot with shoes. But I could do way more pull-ups, bro. I'll be honest. When I'm thin, it does make a difference.
Bro, there's no way you can do 10 pull-ups.
Next, I mean, we could shift to another topic, but just
I'll bet
one
you
more.
anything you want right now on camera. I'll bet you any amount of money you want.
All right, Ruhiv, I think Brian can beat you in an arm wrestling competition. I don't think you should even try.
Sure could. Yeah, he'd outweigh me by like 15 kilos. Yeah.
I don't
Bro,
think
I'm
you
real
should
good at
even
wrestling,
try.
dude.
Honestly,
My dad won state a long time ago, bro. I beat him like when I turned 18. But I beat a guy who got second in the Orlando competition a couple years ago. Everybody told me to do the competitions, but I never do because I don't know, man. I'm just kind of scared to. But I don't lose. I'm not getting no younger.
so Ruhiv, back on the top,
I
on
got
the
real
topic
short
we were
arms,
talking
dude.
about. On the topic we were talking about, if you went to South America, if you went to the South in Antarctica and you were there during the 24-hour sun and it was not a 24-hour sun in the sky, what would that do in your mind for your globe belief?
Oh yeah, disproof, sure. If that
Because-
didn't happen, yeah.
Like we were saying that it wouldn't really disprove planar Earth because the sky could be anything. It could be the whatever it could, anything. But on the globe, you guys have it. It's pretty physical. Like you're on the sphere. Those things out there are physical balls of light or whatever. And so it does seem like in your model, it's just that observation of the sky would you say as far as to go, the whole globe is debunked?
Oh, it would break the model very badly, very badly. Yeah,
Really?
I don't know how much would keep
me,
it.
bro. Sorry, go ahead.
Second?
Break
Yeah,
it.
it would break it very badly.
Yeah, so you would actually at that point, for yourself, if you saw that, you would have to be like, all right, I might be wrong. It might not be a globe.
Yeah, yeah. I don't know how much you'd be able to keep.
Send me to Antarctica start a GoFundMe, dude. I mean, even if it takes a year, and I'll get flat earthers to pitch in, globe earthers to pitch in, and send me to the South Pole, the closest station that we can get to the geographic South Pole. And if I see a fucking sun up in the air for 24 hours, bro, then I will fucking, and I don't get a sufficient rebuttal, I'll fucking instantly fucking switch and scratch and claw, at least tell my perspective. But I think nobody will do that because I'm not going to see it.
Oh, I know that
That's
you
my
will.
opinion.
I'm not gonna pay money for you to go, and yeah, it's a waste of money.
Bro, you spent money doing all kinds of shit to prove the globe, and I'm not asking you to pay for the whole thing, dude. I'm not asking for you to pay for the whole thing. I'm just saying nobody's going to take me. Yeah.
Ruhiv's got to live on his money and his family for the rest of the deal here. So he's got to keep what he's got. We're not going to.
Yeah, I understand that, but if he does it, I mean, he knows me good enough to vouch for me. I'm not going to go down there and fucking lie. I would hope he knows me good enough to where if I see a 24-hour sun, I'm not going to come back and say I didn't.
Yeah,
and I'm not asking him to pay for it. I'm asking him to just like do a GoFundMe. People take him serious. Bro, I literally bought 2 miles of, no, why am I saying 2 miles? 1 mile of fishing line to do a preliminary test and fucking went out there and made a preliminary stretching the line out across the water and shit and couldn't get anybody pitching 50 fucking cent, dude, to even see the fucking experiment of 200-pound test. It was pretty depressing, bro.
Yeah, no, yeah. I don't think any global would have contributed that because it wouldn't have demonstrated anything.
All right, so Ruhiv, let me ask you this: if somebody paid for it for you, and you had the chance to go, all expenses paid, all you got to do is pack a bag and just all good, even food, everything's supported, your whole sleeping arrangements, all that stuff. Would you go?
No,
you would not.
No, the isolation would kill me. That I would be terrified. Yeah.
Well, not to live the rest of your life.
No, but the isolation of being so far from civilization, so far from medical help, the food, like it's just not my thing. I would not go.
Okay, so if others went, it depends on who they were, I'm sure. What would you need to actually, like, who would have to go to verify it that you would trust enough to be able to be like, oh, wow, okay, that's really the case? If you're not going to go yourself.
Brian went. If Brian went and said, there was a full day of darkness or whatever, or half a day or whatever, yeah, sure.
You would trust, trust Brian.
Yeah, if he says, it was cloudy and I didn't see it, I'm like, okay. I think the excuse of clouds is incredibly weak.
Yeah, dude. If I could see the sun through the clouds and I see where it's at when the clouds go away, I'm not gonna fucking use clouds as an excuse. I don't expect to see the actual sun the whole time, but I'm saying you could see when it's under the horizon, and like if the whole damn side of the sky is blanketed for 4 or 5 hours, then to me that I'd have to wait till the next day. But I mean, it seems like I'd be able to catch a day where when it gets to lowest, it's not cloudy. I mean, the rest of the sky is not in contention, bro. It's the part where the sun gets its lowest, and I just need one day of that part of the sky not being blanketed with fucking clouds the entire time.
I think it was New Perspective posted a link to Flat Earth and Coffee, and that's Bobby Thompson. And he proposed a bet to me. He said, "Look, you pay $50,000 for me to go down there. If I see the 24-hour sun, I'll pay you money back." And I was like, "Okay." But then he goes, "Oh, and if it's cloudy, that counts as not seeing it. So you just got to pay for it." And I was like, "Fuck
Yeah,
off."
but that's why I'm asking you to start a GoFundMe, because if everybody just pitches in $2 or $3, bro, I would never ask you something like that, bro, because I don't have the money to pay it back. But I'm saying we get flat earthers to put in $2 or $3, dude. No, I mean, I believe people know I'm not gonna lie. I'm gonna see what I see, whether it proves anything or not. I'm gonna still call it how I fucking see it and let everybody decide from there. And it wouldn't cost that much for both sides of both communities to freaking pull together and fucking send me to fucking Antarctica, dude.
Yeah, I mean, I think what needs to happen first is do some research into what you need to do to go, like what permits and travel. And yeah, there are companies that will help you plan a trip. So I think that's probably the first free thing to do. And if you do it and cost it up, then yeah, I'll stick in, I don't know, maybe $1,000 something like that.
Once again, bro, you don't. I do appreciate it, but I think we could split the, help stop the bleeding across the board. But yeah, I will do the and see just what is the closest I can get, and see if there's any exceptions. Like I do hold a couple trade licenses and stuff. They might even be able to do something while I'm down at one of the places. But yeah, I'll probably just have to go somewhere, vacation-y. But I'll look into it and see what's the best time of year, the furthest south.
Have you got a like a public email address that you can read out online? Or you can just DM me or something?
I'd have to DM you. I mean, I got an email address.
Yeah, just DM me and I'll send you some shit.
Okay, that'd be great. I heard some people say, dude, that I've heard a couple flat earthers come forward and flat out say that. I heard one of them say that he was a plumber, said that there was 24 hours of light, but the sun set, like it literally set, and that's
like twilight.
The best thing. Yeah, there was no 24-hour sunlight. I mean, sun, but there was 24-hour sunlight, like it was twilight. I don't know. I've never heard a flat earther say that there was 24 hours of sunlight, but I just don't know why. I mean, if somebody like even Bird, I don't give a fuck if it's Edmondson, Bird, Ross, McMurdo, any of them motherfuckers. You say you went to a geographical south or north pole. I want to see the sun the same height above the horizon, or the moon, or whatever. Stay the same height above the horizon for half a day.
The travelers do talk about the midnight sun, like back in the 1800s.
How come they don't never mention it in the southern hemisphere, like Ross and Captain Cook and all them? Why ain't those?
Let me find a couple of mentions, shall we? So this is Fram. Sorry, the Nielsen voyage, midnight sun. Blah, blah. But right against us on the other side of the Nansen Mountain, raised its splendid ice-clad summit high towards heaven, gleaming and sparkling in the rays of the midnight sun.
That shows you right there that it can't be in Antarctica or nowhere near it if it's raising up high, because it'd never get above a certain height above the horizon. That shows you he's full of shit right there.
Only on the night of the 5th did we have sun and fine weather when we saw the midnight sun for the first time. On the night of the 15th, we saw the midnight sun, unfortunately, for the last time. Another one.
A midnight sun, bro. I'm not even arguing against a midnight sun. I'm arguing against a 24-hour sun.
Is there a possibility of having a midday night and a midnight sun? Is that even possible?
Yeah. If the sun is barely above the fucking horizon at midnight and comes up at, let's say, 6 in the morning or something, then it's on its way down.
The midnight sun was not seen till the night of January 7th, 1912, to the south of latitude 77 degrees. It was already 9.5 degrees above the horizon. Yeah, so that the explorers do talk about it quite a lot.
Hey, Nielsen, the guy who couldn't find, Ross had documented, he named it after the royal, what you call it, a 1,200-mile island that he couldn't find. And Niels went down there and followed its coordinates to find it and couldn't find it. And then one of the other people, I forgot the person who went back and supposedly rediscovered it because Nielsen or whatever, I think that's him who went down there and followed the coordinates and couldn't find it. Like, I don't trust that guy if he can't find a 1,200-mile island. And why are they finding stuff and then trying to go relocate it and wiping it off the map because they couldn't find it at that coordinate? And then somebody going back and refinding it and putting it back on the map. That doesn't make you at least suspicious, bro?
It depends. Witset's here, right? Witset sent me this PDF the other day, and I have found about half the quotes from it, but there are two. One of them is Nielsen. Where is it? There's the Nielsen one, where Nielsen supposedly had this 100-mile error. Oh, where is it? Hold on. Nielsen. I can't find it. Basically saying he was off by 100 miles or something, 110 miles. And I was wondering
That's not
if
what's
it's had a link.
Not according to D's, bro.
Here we go. So Middleton, who is a flat earther, says, I've sailed, blah, 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 and the captain said he was out by 200 miles. And then this escape, coupled with Captain Nielsen's 110-mile error, caused me to smell a nautical rat. Cannot find any source for that.
Dude, that's not what D said, bro. That's bullshit.
Yeah. This is a flat earther document.
Hang up all for it.
You're not going to fall for a document written by a flat earther?
No,
Okay.
I said that's not what D's claimed. Exactly opposite.
Hang on.
Didn't even care.
I'm trying to find what you're talking about. About Wilkes Land, I think. I think you're talking about Wilkes Land. He goes, what kind of observations of latitude and longitude did Captain Scott make when he failed to find Wilkes Land, a stretch of land over 1,200 miles long, equivalent to the distance from New York to Havana?
Did you calculate in standard denial?
Standard denial. That's funny as shit.
Indeed.
There's turbulence in the truth field, Ruhif.
Indeed.
Ruhif,
you gotta line up the light rays for truth.
Ruhif, you never fucking read D's?
D's nuts.
D's nuts. You won't follow for it.
You know, there is a gradient with denial, but there's always denial.
Nice one. Did you get any measurements of the denial? The denial gradient?
Just on paper, though. We don't see it in real life. In real life, we have to stand up and be men.
Yeah.
Oh, Ruif, we got graphs, bro. Have you seen the denial graphs yet?
Nice.
We're following in your footsteps. Yeah, it's the
nice.
It's all calculatable.
We call them
If Wits is
BNS
around, we
waves.
can go through. Nice one. If Wits is around, we can go through this PDF.
Well, Ruif, you think people are denying your mind blowing globe ideas, right?
Yes. Denying data. Yes.
Right, but of course, if the Earth isn't a globe, would you then admit that you actually are the one who is in a denial of some sort?
Not denial, no. I would not consider denial. I would, like I said, I'd be crazy before anything else.
Well,
just
you're not crazy,
bro.
Just to figure out you were wrong about one of the biggest mysteries in the human experience, the Earth.
It's just not a mystery.
You can't beat yourself up for that, dude. It's a big question, man. It's like, why are we who we are? Why are we here? What is the Earth? What's the nature of this world? I mean, those are big questions.
Well,
some of them. Think about it though. They just
but you're going with a
fucking
story
Earth.
that you think other men have done, kind of put together for you, basically, at least partially.
Yeah, but
I mean, if it was
in my
wrong,
mind,
like, is it that it's not that you're crazy. It's just that you were, I mean, I'm not trying to use it as a dig or anything, but misled or misinformed or whatever.
I don't. My belief or knowledge of the globe, whatever you want to call it, is not related to other people. I've measured it myself.
But they did use the stars in the heavenly body, sun, and all that to map doing perfect circles around. So you're just going by the fucking model, bro. It's very possible, bro. I know you realize that, or you wouldn't be in this argument if there wasn't some shred of possibility to it that it's not exactly the way it's been modeled.
Zero doubt. Literally zero doubt. Like I said, if it was somehow proven to me that it was wrong, I would assume that I was crazy first.
What if there's really no such thing as craziness, and it's just all a process of learning? And
Sounds like what a crazy person would say.
Okay, let me ask you this. Let's say you are crazy. Okay, that's it. You are just somebody labeled you that word. Okay, whatever that means. What then changes? You're still you. You're still trying to use your faculties to decipher things and look at information and do. You know what I mean? Like you're still you.
But I wouldn't be able to come to a rational conclusion on anything.
Okay, so you're saying that if you messed up on this globe one, you're saying that you would question all of your other judgments to such a severe degree that you would just feel like someone has to take care of you or something, or make your decisions for you? Where do you go from there? You can't be your own person.
Don't know.
Dude, come on. We can't get you. You can't end up in a mental hospital just because you were wrong about the globe.
But flat earthers often describe how much of a mindfuck it was to realize, quote unquote, that the Earth is flat, right?
Yeah.
Yeah. I think mine would be catastrophic.
More than really? You think more than others? Why?
Because I know why the Earth's a globe.
Okay.
If I'm wrong about that, my reasoning faculties are entirely broken.
Okay, yeah, because you've looked into it a lot. That's what you're saying. Yeah, you've got a channel. You talk about it. You've been involved for years. I see what you mean in that way. Yeah.
Yeah, but he does go out a little bit, but I mean, just walk out, bro. I mean, that tells us it's flat. Then you got to start from there. And then like I was saying, if it's modeled as these stars doing perfect circles. That's how we map the ground, bro. So yeah, you're gonna double check everything, especially in the mountains, bro. Like when they try to use the mountains and the angles, the mountains is not. We didn't plane survey the mountains, bro. We used theodolites and angles and mapped it geodetically, so it's gonna match these globe figures for the most part, except the first of the mountains, like they probably got more accurate elevation data. The rest was mapped with with angles and shit like that. Not thick in the mountains, bro. It's not that easy, bro.
Yeah, I know, but they do actually do plane surveying to get elevations of some mountains, right?
Yeah, like the first mountain coming up to a stretch and shit like that, and then judge off that, the other stuff. That's what I'm saying. When you're looking at these mountain ranges, you're going to be more inclined to match a globe because that's how they were measured and that's how they were documented. That's why the altimeters don't match up, bro. Because they're not going to match. They're giving you real world readings. I mean, maybe sometimes they're off or whatever, but for the most part, they're never going to match because they're agreeing with just the pressure and all that stuff from the actual elevation and not the modeled elevation. So altimeters are never going to hardly match. And you'll have a different experience.
Altimeters are going to be
No,
inaccurate.
they're not really inaccurate. They might be off a little bit. They have a little scale in the margin of error, but they're always going to be beyond that because in the mountains, because the mountains aren't mapped correctly. They're mapped, they weren't the ones that weren't planar surveyed, the majority of them.
Yeah, but they're not going to use an altimeter to get the height of a mountain. They'll do a theodolite from a benchmark that's been done by differential leveling. Yeah.
You see what I'm saying? So once they add in the R and all that stuff and calculate its elevation, for the ones that they didn't plane survey, then even an accurate altimeter is going to be off, right?
Yeah, but altimeters are not accurate. They're just not accurate. You've got to calibrate them to the mean sea level pressure.
Right, but you don't think it's ironic that in the mountains, in the majority of the mountains, it's off by more than the normal margin of error. I mean, they say it's like gravity shit. They say there's gravity anomalies and all that shit, bro. It's just, I think it's simple. They're mapped and rated their elevations and stuff based on a ball and not physically measured.
Right. But
it's a fair explanation, though.
Right, but yes, they would have included curvature in those geodetic measurements to an elevation of a mountain, right? If you don't include curvature, the elevation that you get will be wrong. If you can differential level up to a mountain and get an accurate elevation, and then if you go a couple of kilometers away and take a theodolite vertical angle measurement from a benchmark, you will get the wrong number if you assume a flat Earth.
Wrong based on a globe. My point is yes, they are wrong because they were calculated geodetically instead of surveyed fucking planar, and that's why they're wrong, because it's not a globe.
Yeah, see, that's the thing. That's the thing, Ruhith. That, like, instead of going crazy, I think you'd probably just figure out what happened and what information you had that was faulty, and then I think you'd probably just correct course and be good to go.
Okay, so the planar elevation of a mountain, right? Do we agree that's correct regardless of the shape of the Earth?
Elevation above sea level?
Yes.
Yeah, I agree. From point to point, when we're doing planar surveying, even after you add R, once we've surveyed the elevation and we know it exactly from direct measurement, then that's going to be the right height. It's going to match if we actually measured the mountain. Yeah, if we physically measured the mountain, it will match flat or plane.
So you agree that if we measure a mountain using planar surveying, that elevation is correct, even if the Earth is a globe?
Yeah.
Yes. Okay. Cool. So then, if we back away from that mountain a couple of kilometers or whatever, and take a vertical angle to it, right? There will be some amount of drop theoretically between me and the mountain. Right. If I don't account for that.
Right. Yeah.
If I don't account for that, the elevation will be wrong.
Or something else. Yeah.
Yeah. But if I don't account for it, the elevation that I calculate will be wrong.
But the altimeter, if I've physically measured it, I think the altimeter is going to be pretty fucking close. And I think if we didn't physically measure the mountain, we just charted it, I think it's gonna be off.
Altimeters are not going to be that
every
accurate.
time.
Where's Left Lane? Left Lane knows what QNH is, doesn't he? He's not here. Any pilots in the house? No pilots. Anyway, when you're in a plane, right, just with a standard barometric altimeter, you have to calibrate that to mean sea level pressure, just like you do any other barometric altimeter. They have to tell you what the sort of normalized value for mean sea level pressure is, so that you can plug it into your altimeter. And if that changes 5 minutes later, your altimeter is not going to be accurate. So it's not a good way to get elevation at all. In fact, I did a presentation yesterday on whatever Shane's ADL service.
Yeah, I know, but you made my point for me. Like all these mountains and shit. I think you're over giving them more credit for physically measuring a lot of these mountains. Most of them are done calculating it, and
measured or calculated?
Would you agree this? If they were just calculated judging by the angles and stuff, even if an altimeter was perfect, if the Earth is flat, the altimeter wouldn't match.
Sorry, the altimeter would or would not match?
It would not match if the Earth is flat and we use the angles and
and the R value and all that stuff, and put it in a model, you agree if the Earth's flat, then it would be wrong, right?
Well, if you've got it like perfectly calibrated to mean sea level pressure, then yeah, it'll be fine. What's wrong with that?
No, I'm saying if the Earth was flat.
Yeah, fine. Either way.
Okay, if the Earth is flat and I did like 4 shots around a mountain, all the way around it, I did 4 shots from 4 different corners, and then I put it in my model as a R value. Okay, it couldn't possibly match a flat plane, bro. I mean, that's not putting your model in any kind of contention, bro. That's just thinking. Like if I put an R value in my angles, after I measured the angles and then you equated it on a globe, it's not going to match if the Earth is flat. I'm not saying the Earth is flat. I'm saying if the Earth is flat and we calculated the elevations based on the angles and the being on a globe.
Ruhif, you didn't make that stuff up about the pilots having to calibrate that, did you?
It's okay if you did.
Just
I mean, not really, but
kind of looking it up. Here's something about it.
maybe he was freestyling.
Sorry. What was I saying?
It's going to show the elevation being higher, though. If the Earth turned out to be flat, all these mountains that they calculated are going to turn out to be a little too high. So the elevation is going to,
Right. But then we agree that the elevation achieved using differential leveling is correct regardless of the shape, right? But then we back away and do a vertical angle with a theodolite from varying distances, right? And if we do the trigonometry on that with like a flat assumption, we will just get the wrong elevation.
bro, without making adjustments and stuff. I mean, it's going to be wrong anyway. I mean, I can adjust it for the model. But I'm saying if we didn't physically measure it, then we didn't account for the optical drop. No, let me say it like this: if we do account for optical drop, then the elevation is not going to match up. If there is no drop in reality, if it's just optical instead of Earth curve drop. I wish I could explain this better. Somebody help me out here.
Optical drop's a bit of an issue. We got the Sydney Tower here, right? The Centrepoint Tower. If I get close to that with my theodolite so that curvature is not a factor, really, I can get an accurate height of the top of the tower, right? And then I go, 5 kilometers away, 10 kilometers away, 15, 20, 25, take all these different measurements of it. I probably should make a video about that, actually, is go and take some measurements to tall things and then go far away.
But the actual height of it. And so, that's going to be no problem for a flat or globe if you know the actual height of it.
I'll measure the height. I'll get close enough so that curvature is not an issue and measure the height of it.
Ruhif, when they adjust these altimeters, it's so they can match the pressure where they're landing. They have to set it where they're landing. They don't calibrate it so much. Well, I mean, I guess
there's field pressure, but there's the one they use, is QNH. The main
that they wing it with a standard. They just throw a standard there, 29.2 inches of mercury.
Yeah, but then the field elevation, right? Like it's.
There's a standard. They just throw a standard in there too.
Yeah, then you go from one airport to the next. If you're traveling, it's just a mess, right? You should calibrate it to.
Why don't you just use the standard?
Because it changes. The pressure changes, and if your altimeter is not calibrated correctly, you might be 500 to 1,000 feet off.
All right, so I'll mention that next time you use standard refraction.
Why?
Because you're adding a complete thing in out of fucking nowhere.
What do you mean? Have you not seen like a weather chart that shows the what do they call it, isobaric lines?
So tired of this.
You might have like, I don't know, 980 hectopascals.
To use an average and chuck it in there like it's fucking okay. It's not good.
It is an average. The graphs tell you that it's an average.
And the conditions aren't always average.
Right.
So occasionally we can fucking see clearly.
Yeah, black swan. You can see further.
All right. So, do people talk
Still love
openly
you.
about the different things that obfuscate the vision of the black swan that's not refraction?
Say that again.
How many other factors are happening in black swan that are not refraction?
That is the primary reason why you can see further on that picture.
So, what about the effect on the crane?
The bendiness of the crane.
Are you saying the crane is closer to its actual position than the rest of the tower due to refraction? So the crane is closer to its actual position than the whole rest of the tower because it's bending down, so it's actually closer than the rest of the tower.
The crane's all sorts of fucked up as well. Right.
It's
If you have a
distortion,
the fire boom.
It's a
Yeah,
different
it-
form of
Yeah.
construction.
Yeah.
It's not refraction, right?
it is refraction, right? But
It's the
if you have a
it's fire boom. It's the
Are
boom
there
of the
forms
boom.
of
Fire
distortion
boom.
that you're not going to
Well,
categorize as refraction?
No, the bendy
It's
boom
all
is
refraction.
refraction. Yes. The bendy boom is when you have a non-uniform gradient. So your gradient is already a rate of change, right? That's what a gradient is. When the gradient itself is changing, that's when you get distortion like that.
So the heat from the atmosphere is making it appear lower, right? The heat, and then the further you get away from the fire on the boom, the less it's bending. So the heat in the atmosphere is making it appear lower.
I'm pretty sure it's all, as a whole, appearing higher than it would sort of geometrically.
No,
It kind of has to be the
it's
case.
bending down, bro. What are you talking about? It's
Light's bending down. Light is
No,
bending
the
down,
boom,
right?
the boom, yeah, and it's making the boom appear lower.
As in it bends. It's got a bend in it, like a concave bend in it.
So don't you think all that shit is what's making your half a boat on the horizon?
No,
Why not?
because I can see the top of the water, but it's intersecting at the middle of the boat.
But what if the boat was bending downward?
What do you mean the light from the boat is bending downwards? Then I would see it.
No, the entire boat. The entire boat is bended away due to optics. Half
Due
the
to
boat's
light
gone.
bending up or down?
Due to
Which
all
way is
the
light bending?
Due to all the optical effects that you're describing, that's why half the boat's not there.
Right, but which way is light bending for that to hide the boat?
Whichever way you're fucking saying it is.
Well, the
You
upwardly
say
bending
both.
light.
I'm bending downward, but I'm looming upward. Well, how the fuck can I
Yes.
answer that?
Hang on, let me share my screen. Let me share my screen. That one, that'll do.
It's like I tell my baby, loom upward, baby. Loom upward.
Oops. All right, can you see my screen?
You're nice. Only because you're a nice guy. Oh, it's more of this. What about it?
Okay, so you can see the path of the light is bending down, right? The red line is bending down.
Due to what?
Refraction. Yeah. But where do I see the star? If my eye can't tell that the light's bending, right? So I just presume, my brain presumes that that's where the star is the same angle that it comes into my eye. So that's the projected line of sight. That's where I see it.
Yeah, but compared to everything else, it appears lower down.
No, it appears higher up.
Like the
Light
example
bends
I
down.
showed, when he shines that light on that skyline. Okay, it doesn't appear higher up the building. It just appears the whole building looks lower, so it appears higher up the city skyline.
If light bends downwards, the apparent position will be above, higher. It will appear higher.
You're imagining that we're catching the light rays that would have went over our head. I think that's too drastic of an example, man. I think.
Of course.
It's not, I don't know, man.
Yeah, it's exaggerated, but that's just demonstrating the principle that it will appear higher when light bends downwards.
Okay,
Not really.
Can you look
Really?
at this again? No.
Sorry.
You're showing two things. A projected line of sight. I'm just going to call that, a lake. And
No,
then
the projected line of sight is the angle at which that light comes into your eye. Right? Your eye doesn't know that line of sight is not straight.
But when I'm standing over a body of water, it really fucking helps. And when I can see it day and night and see the shoreline left and right, I'm pretty sure that there isn't any distortion in my view.
Right? There doesn't have to be distortion. If you've got a uniform gradient, if your gradient is
Your
constant,
standard refraction gets reduced to less than standard. Way
no,
less.
standard refraction. If the gradient is
Now let's just
constant, there is no distortion.
hypothetically, if we reduce your standard refraction to very fucking little, do you think this drawing here applies still?
No, because then you've got projected line of sight equals the actual path of light. That's no refraction.
Thanks. So you're admitting it's possible. Thanks. You're a good man.
What did I admit?
That it's possible to obtain line of sight.
Is it possible to have no refraction? I would actually say no to that.
It's like this. If sorry,
you just said it would match.
No, you just said if you gave me a conditional. If there was no refraction, then I agree. There's no refraction. All right.
think about this, Riff. So if we got to confine all this within, we got to give it limitations. So we'll say it's all limited to the light that hits our iris. Let's say the color part of our eyes. Anything beyond that, bro, we're not seeing. So it all falls within that little area. So the light that was going to hit the middle of our eye, a straight line of light, straight ray of light, now hits the bottom of our iris or our pupil, and because it's bent down, it's going to make it appear lower. I know on paper you can make it seem like it's going to appear higher because by drawing the angles higher, but it's all confined within that pupil, bro. And that pupil itself is curved. So if it hits the bottom part of the pupil, even if it's coming in from a smidge higher, it's going to make things appear lower, bro. There's no getting around it.
It all depends on what angle the light comes into your eye. Just like a lens, right? If it's coming in, this looks like 30 degrees or whatever, we don't know that the path that it's taken is curved. We just don't know that. So where we see it is where the apparent position is, the faded one.
Right? The lower part of our pupil, though, is going to detect things no matter where they're at. If it's hitting the lower part of our pupil, then it's going to appear lower.
Hey, Bruhif, I have a question for you.
Yes. Okay, buddy. Can you go and get dressed?
Yeah, I like coffee.
Okay.
Check. Just right there.
Okay.
So can you right there in Rapido? Like.
When you have
you go and get dressed, please, buddy. All right, go, no problem.
Yeah. So, if we lived on a planar Earth, right, what everybody would call a flat Earth or a true Earth or whatever you want to call it, and we are at the ocean, and we had the assumption that the water was flat and stationary, right, and we saw things in the distance. On the ocean, we even saw land further away, maybe some buildings, blah, 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 yada, yada, yada. What would you say upward refraction would look like in a situation like that? Let's just say we have a boat going off in the distance. Beyond the boat is some buildings, tall buildings that are, 25, 30 miles away. What would upward refraction look like in a situation like that on a flat plane?
Both inferior mirage.
Just upward refraction. So there would be miraging.
Yeah.
Can you give me an example? Like, would this be miraging where, typically lots of times miraging is on the water, right? So you would say that there would be the appearance of something up higher than it normally would appear.
The inferior mirage appears below the sort of, I would say, actual object.
Okay, so you think things would appear lower?
Yes.
Is what you're saying.
Yeah.
So in their lower appearance, would there be cutoff points in that at all whatsoever?
Cutoff points? Like you know the idea of the vanishing zone of an inferior mirage?
Yeah.
Okay. Is that what you mean by a cutoff point?
So would you say that there would be mirroring in a situation like that, like on the water or something like that?
Yeah, there often is. It's inferior mirages, sure.
So does upward refraction always necessitate mirroring over water?
I believe so, yes, because if there will always be a path of light that touches the surface, and beyond that there'll be a hidden area.
So a mirror would do the same thing. An actual mirror would do the same thing, right? It would reflect exactly. It would basically, we'd see the real world image flipped. So an actual mirror would do the same thing. Hey, Roof, tell your wife that you've been dogging me out and you called me an imbecile, please.
Why's that? Yeah, she's texting me. Hold on.
I was just joking because Roof the other day was talking about she thinks that Roof is like bullying, kind of, like.
Oh.
Yep, she's upset with him. And then I'm sure it impacts other areas of their relationship.
Roof, that fucking Discord's more important than me and your family.
Pretty much.
No, she's
Hey,
upset.
Gio,
Yeah.
Gio, what do you think about this so-called path of light, this corridor of light? For me, I don't believe there's any sort of corridor or path of light at all. What you're seeing is the image has shifted. The image has distorted and moved its position. It doesn't mean that the light is bending. It just means where the position is, the apparent position, has shifted in its frame.
Yeah, I would agree. Yeah, I don't see it as a corridor bending, warping things either. Yeah, it's like a medium that is sort of like if you have a glass of water and you look through the water versus not looking through the water, there can be all kinds of distortions and misplacements.
Yeah, like I saw in a video yesterday, I don't know if it was Witsit's one, that was quite cool. It's probably really elementary, but you get a glass of water and you have a card behind it with two arrows, both facing the same way. You fill the glass half full to cover the bottom arrow, and the arrow will face the other way.
Yeah, that is cool. Even if the light was making light look higher, our eyes flipped, reversed everything. It would appear lower to us, even if the light did do what they say.
Yeah, well, in that simple explanation, does that mean the path of light has changed, or does that mean the image is distorted because there's a lens at the apparent location?
Refracting it, yeah, exactly. So I don't think that light can even bend at all. I think it's like I think there's a vortice nature to it, of propagation within the XYZ axis of the geometry of this realm as well. But the medium can change the direction of that, or the propagation, I should say. It's like it can sort of temporarily displace or alter the actual propagation path, not through the light bending, but just through the medium impacting it, almost like a prism, where it kind of refracts the light, out into a whole spectrum.
Yeah. What about the laser in the? Well, that kind of explains the bending laser, like the medium, like changing more than the light itself. Kind of. I kind of see what you're saying.
So the thing about the laser, though, right, is that's like a extremely coherent light source, not necessarily something we experience in like daylight or ambient light or anything like that. That light is.
Oh, sorry, I thought you was done. Fuck.
Go ahead, man.
Well, they say the sugar has dextro rotational, like a dextro. What do they call it? Dextro rotational. Yeah, dextro rotary. Like the molecules in it, so that they're unique to other things.
Is salt dextro rotary?
Yeah, but not nearly as much.
So here's the thing, also, right? Like the things that we call sundogs is apparently because there's ice crystals that have a specific shape that refract the light in a certain way that give us a sundog, right?
Yeah, we were just going. Were you here earlier? Or did you listen? Yeah, Witsit was sharing.
No.
Oh, dude, we went all. Yeah, we were. Witsit was shared a screen. He was like kind of going through his presentation from the one he did the other day on his channel. So he was,
Oh,
like, going
shit.
through it, and yeah, we did a whole good at least half hour, 45
I
minutes.
missed that. I caught
Yeah.
like
Yeah, no, it was a
I
couple
caught like
hours. It
the
was great.
20 minutes. I caught like the 20 minutes right after it was done, right before my hockey game. But
Go back and watch it, bro. It was great.
okay,
Yep.
yeah, I'll have to.
Yep.
Well, the whole session went for a while, but yeah, it was sundogs were brought up several times, and but yeah, because he was talking
Yeah,
about
so that's
crystals, yeah.
So that's the thing, like, right? So you're shooting a very coherent light source through something that is not necessarily analogous with the medium that we're trying to claim the effect that we're seeing in the fish tank is actually taking place, right? So you not only are you like completely affecting the medium, you're going through multiple different actual mediums, right? Could say what you will about any of those things, but that laser has to go through glass before it even hits that sugar water, period. And to say that, if you slightly bend that laser light up, it's not directly on the glass. It's going to take a deflection in some way, shape, or form, anyways, and then you're putting it through a medium that's completely full of these kind of like crystalline type structures. So you're going to get an effect that may not be something that we would typically see within our atmosphere. And then I feel like, especially Ruhif, you guys tend to just use light bends downward, right? Light bends, right? Do we agree? Light bends downward towards the denser medium. Ergo, everything that we see is this, right? Light bends downward. Here's a laser through a fish tank full of fucking sugar water. This is our proof that light bends downward. And just keep repeating the phrase, light bends downward. Don't we agree? And then you try to explain the pictures that we are, or the images that we see in reality solely based off of a laser through sugar water.
Should I whip out the graphs?
Dude, I don't care about your little balloons, because the problem is I don't know. People say you have money. Would you want to take like a gentleman's handshake bet, something very simple, small amount of money, to say, you kind of put your money where your mouth is, as far as do you think that there is a predictive quality to what you think you understand about refraction?
Yes.
Okay, cool. So if I gave you parameters, or you say this is what I would need to make a prediction, you would take like a gentleman's bet to say, okay, either A, I can provide you with an image and I can take all of the measurements you want. I can provide you with an image and you can say, based off of this image, this is the observer height, this is the distance, this is whatever other parameters you want me to gather. I can provide you an image and you can give back to me within an agreed upon range of accuracy, or whatever you want to call it, that you could guess what all of the parameters you would need would be within specificity to say this image is XYZ temperature differential between water, air, blah, blah, blah. You could predict all of those things, set out the parameters, or the inverse of that, right? Like, I could give you all of the information and then you could predict like exactly the height that would be hidden on an object over a distance and blah, blah, blah. Basically, you would paint the picture for me and then I would provide you the picture and we could compare and do like an actual prediction.
Right. The proposal that I would put forward is my usual sort of theodolite thing. Go up on a mountain where refraction is predictable, and we both either make a prediction for the angle that we'll measure to something in the distance, or what the photo will look like in terms of hidden, something like that. So we both put something forward, and then we compare who got the closest.
Well, I
Yeah,
would do this for because most of the images that are provided by either side for any type of proof or evidence is typically not from a mountaintop, with the exception of maybe like Canigoo for the FE side or something like that, right?
Make a prediction for what that should look like under your model. Let's compare. But we already know what it looks like, right?
No.
So,
I'm asking. No. I'm not asking for like a burden of proof shift reversal. Now I'm making the prediction. I'm holding you to it because you guys seem to have this some sort of like mental superior or like superior high horse that you guys like to ride with refraction. Like you come in on your Clydesdale, like, here we are with refraction, light bends down constantly. This explains everything, right? So you guys are the ones with the claim. So I want to hold you guys to your high horse and see if you have the predictive abilities.
yeah, if we're a decent height above the surface, I'll stick to pretty close to 7/6R.
All right. Well, unfortunately, I don't have the ability to do that. It would have to be way closer to sea level.
Can I ask you, Ruhif, is it just possible, just using that word in your mind, that balloon data and your 7/6R does correlate to something that is real, but it's just not a globe? Meaning that if there is like that occurring just has to do with the refractive effects of the environment and does not have to do with anything about the Earth actually curving.
The data says very clearly that once you're above about 100 meters, it will always bend down, like 99.9 something percent will always bend down, right?
Well, I don't think anything is bending, though. It depends on how you're interpreting that data. But the thing is, like when we look at Skunk Bay, for example, and you see how the whole horizon
So here's my thing
water
about
level,
that, right? The data says it will bend down.
Yes.
So can you provide me with visual confirmation of a laser bending down at that height?
How would I do that?
What can you show that anything is bending down? Let's start there.
The measurements match predictions. Like
See,
I said,
that's
I'll make
the
predictions.
conundrum,
If let's
right?
go up against each other, make predictions for what angle we will measure.
No. We're holding your guys' feet to the fire, right? Because you guys claim it's all easy peasy, predictable.
Yeah.
Right?
Yeah. Above 100 meters. Yeah. Above the surface.
Well, let's take all the images that most people provide. You know, how many years have we been around and see that the text channels are just pasted over and over and over with pictures, and from the Glober side, I don't really see too often pictures from mountaintop to mountaintop or any shit like that. It's usually right around sea level.
Would you like my pictures from mountaintop to mountaintop?
Well, if you're so confident about your shit, why can't you just do a prediction at sea level?
Because refraction is not predictable at sea level. It's too hard to measure, and it's highly variable. That's what the graphs tell you.
So then how do we know for sure that what we're seeing above sea level isn't just a product of perspective, not necessarily refraction? Can you give me a refraction example with the conditions, like the air pressure, the thinness of the atmosphere in some sort of fish tank, and you shine a fucking laser through it and you show me that it bends down?
Sorry, atmosphere. What? You don't want sugar water, right? So what do you want in a fish tank?
Just pump some rarefied air in that bitch, right? And shine a laser through it and it should bend down, right? Because you're saying at elevation, it's bending down, right? Or get some sort. Can you replicate a gradient that you could try to shine a laser through that would give us the same conditions that we would be experiencing over 100 meters or whatever you always claim with your little
Over
balloons that
100
you put in
meters?
various graphs that you just post, like, look, this is it.
Yeah, I
Earth's
was
a
going to
globe.
say,
100
can't
meters.
you scale it down and reproduce it
No.
in the lab, and then show us an orthographic view of this
If
light
I have a
bending
fish
down?
tank, if I have a fish tank of like, I don't know, 2 feet, and I put atmosphere in there with a gradient in it, I don't know. Will it bend a nanometer? Maybe. I don't know.
You tell me, man. You guys
Yeah.
have all these refraction predictions, and you
Right.
guys know it's down pat, right? So I
Yes.
want to physically see light bending in an orthographic view, the way that you guys try to put forth the
how?
image of the laser going through fucking sugar water, and then saying anything that we do at elevation or wherever we want to take it, any picture that you provide, no matter what it looks like, is perfect of Earth being a globe, right?
How am I
So
meant to do
you
that
should be able to
in the atmosphere?
predict
You got to
any
do it.
situation,
How?
what it's going to look
Explain to me
like,
how
or
I'm
if
meant
I
to do that.
provide you with an image, you should be able to predict various things that are taking place, right? Pressure differentials or temperature differentials that would be taking place in the optical corridor, whatever you want to call it. This should be simple for you guys. Can you do that or not?
You realize with standard refraction, it bends less than the curvature of the Earth, right? The curvature of the Earth is a greater curvature. Yet we can't see that unless you get like really high and have a really wide field of view.
I
You're
mean, it's
expecting
fine
to
if you
see a
can. It's
laser
just
from the
the
side?
projection of
Yeah, it's
like,
a ridiculous challenge. Ridiculous.
why is it ridiculous?
Because it's
Then
impossible to do. How do you propose that I do that?
So what you're saying is I'm giving you all of this stuff and it's unfalsifiable,
No,
but it
not
proves my
unfalsifiable.
position. And if you don't accept it, you're a stupid idiot flurf, right? Because
You're asking for an author, like a side-on view of something that just can't, you just can't do that. How do you
Nope.
propose I do that?
Well, you'd have to show it's happening to have any backing to your assertion.
Right. Number
Right.
one, does light bend in a
I'm
density
from
gradient? Yes or no?
Well, you're trying to get us to follow this breadcrumb trails of ad hoc ideas that might possibly lead to that conclusion, but if it's not demonstrated and backed up, then it kind of it just falls flat. No pun.
I'm making a very simple deductive argument, very simple logical argument. Does light bend in a density gradient? Yes or no?
No, I don't think anything bends. I think things get refracted through the
Okay.
medium.
Okay, if I shine a laser through a sugar tank, is that bending? Is light bending?
No.
No, it's
No.
refract.
Wow. Okay. Does light refract through a density gradient, if that's what you want to call it?
Possibly.
Okay. Well, I'll take that as a yes. Do we have a density gradient in our atmosphere?
I said possibly, and you
Okay.
asserted that it was a yes. So are we
Okay, then
being?
go away
Are
and
we
do some
being?
research until you come back with an answer.
I'm familiar with the research, buddy.
Okay.
But what I'm
And you don't
trying
have
to
an
say
answer?
is, you just need to actually demonstrate your claims. I'm from Missouri. Do you know what the slogan of the state of Missouri is?
Bogan rednecks? I don't know.
Is that like an insult or something? Or are you trying to claim that I'm a redneck because I'm from Missouri?
Maybe.
Okay. That's cool. I'm done with the conversation then. But you
Okay,
can
no worries.
Google it and figure out what this slogan is.
What is it?
You have a computer in front of you, right?
Could, but I got my hand on my cock.
Ruf, this is what your wife's upset at you about, man. This is all.
Come on, Gio.
You're going down the wrong path here, dude. Something's off.
It's a simple question. Does light refract in a density
All right.
gradient? He knows the answer is yes.
Let's just.
But he's just
You
lying.
can't.
Right, but
You
we'll even
can't
follow
show.
your little thing
Why,
though.
why am I lying? If I said maybe, why is that a lie? Because I don't know for sure.
Because you
I
know
haven't
the
tested
answer is
it.
yes. You've said you've done your research. You know the answer is yes. You're too afraid to say it.
So here's the thing. What is the density gradient at the atmospheres you claim, and can you prove it? Or can
The
you just
density gradient, yes. Yeah. Where do you say
So is
from?
pressure
Missouri. Let me.
analysis with density? Is
He-
density and are density and pressure synonymous?
No.
So what did your balloon measure? What did your balloon
Hang on.
measure?
Let me bring up Missouri graphs. Hold on.
I think Jeremy's trying to get in as well. Jeremy?
Never mind. I can't.
Can't even talk, Jeremy. Fuck.
Yeah,
Oops, wrong one.
he's got a sore throat. Or
Missouri.
yeah, that's the thing. I mean, we can even walk through it if you want, Ruhif. Like, okay, you got this weather balloon data from the internet, you downloaded it, you think it shows something, you plugged it into graphs. But even stepping through those things, what Napalm was originally asking you for would still need to be validated. Meaning, for example, if I tell you, hey, Ruhif, I can use glass and water, and I can totally displace an image. I can make it look like it's 5 feet over from where it actually is. And you say, oh, okay, well then show that to me, or show me that's the case. And we say, all right, and we go down. There's the one kind of famous one. Have you seen the one where it's like a pool? It's like a glass pool, glass wall that's holding in all the water, and someone's like behind the glass wall. Have you ever seen that? It's like a famous like YouTube
His
short or whatever.
head's, yeah, his head's like way over the left or whatever. Yeah.
Yeah, yeah. So if I were to then set that up in the pool and the water and the whole thing, and then I was to take you down there, and then we could validate that. Like, okay, here we are. Yep, there it is displaced. We could measure it. We could do whatever. We could take pictures. We could look at it from all angles, and we could say, okay. Now I know that what you're claiming, these long distance observations and all this stuff, I understand that's harder to validate because we're talking about long distances, the equipment that would be needed, the time, the research group, all of that involved to be able to do that. However, nonetheless, even with that being the case, until you've done that, the claim and the assertion you're making doesn't have the backing that's required.
You seem to have an issue with deductive logic. Like I'm asking, like making simple premises, right? Does light refract in a density gradient? And then premise 2, does our atmosphere have a density gradient? The answer to both is yes. Therefore, light refracts in our atmosphere.
I mean, dude, the reality of it is that the atmosphere is multiple levels of complexity. There's so much going on there's different temperature layers. There's wind blowing through. There's gusts of wind. There's all kinds of different pattern, with the water and all of the different components. So there's not just like one medium that's just something like a fish tank with sugar water. I mean, it's a complex. So there's not just one gradient that you could just say, oh, there happens to be a gradient out there that just perfectly matches every time when I need it to fit an explanation for curvature.
On the screen, Springfield, Missouri, right? Every single dot on there is a measurement of the density gradient. And can you see a pattern in those dots?
What is it
measuring?
measuring?
An average.
What is it measuring?
The density gradient.
No. What is the apparatus on the balloon, and what is it measuring?
Right, it's a radiosonde, and it measures temperature, pressure, humidity, plus like wind direction, blah, blah, blah.
So temperature, pressure, and humidity.
Yes. There are three that I need.
Are those 3 things what makes up the density of the atmosphere? Or what needed density of the atmosphere?
CO2 content is a very, very minor thing as well, but we don't have measurements for CO2 gradients. So here's Springfield. Can you see an average?
Dude, you can't show the...
Jesus, please.
I can see an average. I can infer from that graph that once the elevation gets above 100 meters, that green line is the equivalent of 7/6R in the curve calculator. That's a pretty good average once you get above the surface.
What is the density of the atmosphere compared to sugar water?
Oh, sugar water is heaps. It's a fucking liquid, right? Like, what sort of question's that?
So what are the refractive effects through air compared to like just water or sugar water?
Well, water itself, it does have a density gradient, but it's not going to bend much, right? It's the sugar that makes the gradient. Right? But through the air, the gradient's very, very small.
So there's little to no gradient? Is that what you're saying in the air?
The gradient is on the screen. That's a graph of the gradient. It's small relative to sugar water, obviously.
So how much does ambient light refract?
Okay, the refractive gradient is across the x-axis.
So how much does ambient light refract based on a density gradient?
Right. So the gradient's on the screen now. So the average there, or that line, green line, is equates to 7/6R. That's a gradient of negative 0.0000221 or 224, sorry, change in refractive index per kilometer. If you want to know how much that
You
bends,
just said refractive index. So why don't you ever use that word more? Well, he's asking what's zero on the fucking chart.
Yeah.
So he can measure what the fuck your index is all about.
Yeah, he asked what the gradient is. The gradient is measured in change of refractive index.
There's something called 1, isn't there? Isn't there a
This is the change, right? The refractive index is usually measured relative to 1, right? But the change in refractive index is just a difference between the two.
Well, does it go to 5 or 10 or 3,500?
No.
Or does it go to 1.000? Who gives a fuck?
It goes from 1.0000300 usually at the surface
A
up
bunch
to
of
1.
who gives a fuck, right? A bunch. I mean, this chart, depending on the scale of this chart, could look massive. It could be crap. It could look.
It is massive, right? So the
look at the
difference
size
between
of your squares. Jesus Christ, what is
Size of the what?
Just the squares of your graphs are fucking huge, right? So I mean, you're taking in all this space into consideration that we're not even dealing with.
Hey, Ruhith, do you know in the sugar water and the laser thing, what is the difference between the density at the top and the
You're right,
density at
Jeremy.
the bottom of the tank?
I have no idea. I don't think anyone's measured it. I can tell you that it's huge because it bends light
It's a huge differential, right?
Yes.
So how much does ambient light deviate based on a small percentage of difference between atmospheric conditions in a viewing corridor?
Okay, so this
Jeremy
graph,
wants
right?
to know if you can demonstrate that.
Yeah, I'll ask for that eventually.
Yeah,
Well, I
that's
already
the
have asked
simple
for it. But
simple deductive proof, right? Does light bend towards the denser medium in Snell's law? Do you accept that?
see, this is the game you guys have to play. Like I said before,
Deductive logic is not a game. It's a
you have to
simple
play
syllogism.
like I said before, you have to play the game of, we know light bends downwards. Do you agree light bends downwards? Therefore, anything I'm going to say after that is somehow going to prove what you're talking about. So regardless of direction, can you give me a percentage of change based on a percentage of gradient change within a specified area?
Right. I can tell you that gradient of the green line will bend light, and that light will have a radius of curvature of about 45,000 kilometers.
What do you mean light has a radius of 45,000 kilometers, is what you're saying?
It will bend in a curve, right? And that curve will have a radius of about 45,000 kilometers. That's how much the light will bend with that gradient.
Can you demonstrate that to me?
That's what fucking Snell's law and Fermat's principle says. It's a deductive argument.
Snell's law deals with two different mediums, not a gradient. Would you agree?
That's why I said Fermat's principle.
You said Snell's law.
Yes, and Fermat's principle. Snell's law is a simplification. We can use it.
It's
not correct, but we can use it.
What experiments did Fermat do to establish his principle? Is that something that's been replicated?
No idea what he did.
Do you know? So you don't know how Fermat's principle was deduced?
No. Do you?
No clue. So that's the thing is, I want to get to the heart of the situation, find the truth. I don't know if
go away and do some research.
Do
some research. Come back when you accept.
Do the research. Well, you're the one that's bringing up Snell's law, and you want to try to get me to say, "Can we agree light bends down?" Like I said, and half an hour ago, that's all your shtick is, right? Like, get people to agree light bends downward. Show them a visual of laser through a sugar water, and then try to give ambiguous graphs
that lead
to atmosphere to say here's the establishment of a gradient, therefore light is going to bend down as if it's some sort of coherent source even though it's ambient. This is enough proof for us to claim that it's a globe. It's because of Snell's law, which has absolutely nothing to do with a gradient. It has to do with two different mediums. And then you say Fermat's principle, but you have no idea how that was established. And I would need to do more research on it myself to rebut it.
I'm asking you very simple questions in a logical order. You're just afraid to answer them because you know what the conclusion is.
So do
you
you
accept
have
Snell's law?
evidence of ambient light bending in an atmospheric density gradient?
It
Simple
deductively
question.
has to. Yes.
Well, hold on.
So
Again,
hold on.
I'll
You can't
demonstrate
say
it again.
yeah.
Do you
When I
accept
say, do you
Snell's
have
law?
an example, and you say it deductively has to? That's not
Yes.
an example. You're
Yes,
being
I have
deceiving.
examples. I have examples,
No,
right? But what you will say
that's
is that my
disingenuous.
example.
I'm
Okay, are we
somebody
done?
else can talk
But
to
he's
you.
asking.
Okay.
Hold on, don't break up here. Come on. Okay, because you're right at the good point. All right, so, but Ruhif, he is asking for the actual, the meat and potatoes. Because the fact that you've deducted things, I mean, that's fine. Anyone can deduct things all day. Oh, I deducted this and that, extrapolated from this and there, but that doesn't necessarily mean that you've actually validated your claim.
It does, because what will happen is I'll show you an observation of me taking angles to mountains or whatever, right? And I'll include the curvature of the Earth in that. And then you'll say, oh no, maybe light's bending upwards and it's not curved. That's what's going to happen. I know that. Right? So I'm asking for a very simple, logical set of steps that I'm pretty sure Napalm accepts, so that he understands that light bends downwards in the atmosphere. He just refuses to answer because he knows the conclusion.
So you're saying
No, I'm asking for
you're saying
specificity and examples of your claims, and you're saying just agree to this generalization, and therefore I win.
And then
It's
I'm
fucking
sorry,
Bush
Ruhif.
League.
Yeah, I don't want to.
Why can't you answer the question?
Hold on, I'm going to say this, and I'm not trying to roast you at all. But then what you are doing, I'm just saying this very calmly, is you actually are doing gaslighting, because you're trying to. What gaslighting is it tries to make the person question their sanity. So instead of actually responding to what he's asking for in terms of the particular, validation of the claims, you're just saying, oh, the gaslighting part is when you say, basically the thing you're saying, where you're like, oh, he just doesn't want to know it because he's scared, and then he's gonna. That's all gaslighting. You're trying to make him question, like, oh no, am I
Sorry,
Am I
Gio.
scared? Am I
Asking him if he
That's the
accepts Snell's
gaslighting.
law is not gaslighting. That's bullshit.
No, the part that's gaslighting is this rhetoric you're doing, where you're saying, oh, he doesn't want to know because he's scared. That whole part is what I'm referring to.
Yeah, so why won't he answer? Does he accept Snell's law? Yes or no? A very simple set of questions.
Well, at least that's on topic. The gaslighting is just useful.
Yeah, use Snell's law.
Yeah.
Yeah.
Why are you bringing up Snell's law again when you're talking about atmospheric gradients? Can you
We're
cite
trying.
where
Okay, so
Snell
then
talks about atmospheric gradients?
fine. Then I'll say, does light always bend towards the denser medium? You can do that with Fermat's principle or Snell's law. Either way, does light bend towards a denser medium?
Can you provide me with any type of citation?
Napalm.
See, he's just trying to do it again. Like I've
Because you're not
exposed
answering.
the whole room.
You know
knows
the
exactly
very,
what
very simple steps that I'm trying to take you through, but you refuse to
Gio
go
just
through them.
called you out on it, and
Well,
then you try to
Gio's
say
full of
like,
shit.
then this is the whole Xanac thing, right? Where you try to demoralize me and try to talk down to me as if like, oh, it's just so simple, and you can't do this simple task, right? It's the same BS that you guys try to do. Try to come in and be like, well, this is such a simple concept to grasp. I don't understand why you can't grasp it, right? And then you try to like act like this is bolstering your claim when I've asked you for specific evidence.
Yeah, I'm giving it to
and
you.
you can't
You
provide it.
refuse to
You
come
just
along.
have to answer with rhetoric, which is
All right, let's try to get past all that and just get to the base of it. So, okay.
Unfortunately, I don't have the time, Gio. I literally I got home from hockey and I have to go to bed. But
all right, good night.
No, I hear you. I just didn't know if there was a conclusion to that or.
Yeah, he has no evidence for his claim, and he wants me to agree to some generalized phrase so that he can tout victory, even though he has absolutely nothing in his corner. It's stupid.
But light bends down.
The light bends down.
Yeah. So
well,
let
I have
me ask
examples. I got examples.
Does light bend towards a denser medium?
Yeah, it would appear so. I mean,
Yes.
if
Generally in our atmosphere, is the denser medium towards the surface?
I believe so. Yeah.
Arma, it happens.
Does light bend down our atmosphere?
Yeah.
Yeah. There we go. That was pretty easy, wasn't it?
Well, that was kind of what Napalm was saying. You just wanted some kind of feeling like you got a slam dunk or something without actually having the conversation.
It is a slam dunk.
Not what he was. Napalm was asking for validation of the claim, not whether you think, not just an ad hoc deduction about things
Not
bending.
ad hoc. Jesus, it's simple deductive logic.
Hold on, let's start there. Okay, let's say that your theory that you just laid out is, let's say it is true. Okay, what you just said, the deduction, the whole thing. What would you provide as the validation that it's actually happening in reality, in the real world?
Right. Measurements of the density gradient showing that the density is lowest at the surface density is highest at the surface and lowest as you go up, which is what these graphs are.
Okay, let's even just take that on face value. Okay, you have the graphs, you have this thing, you have these other measurements from somewhere else, from a balloon that you didn't, but let's just say that's all fine. Let's say it was your balloon, whatever. You have all that data, it's absolutely solid. Now, how have you then validated how that is actually working in the world in terms of curvature and these long distance, etc., that you're actually trying to indicate with it? Like, where do you have that validation? I understand. I'm taking everything you said on face value. I'll play right into your whole thing. I'll say, yes, thumbs up. I mean, I'm not saying me personally I'm valid. I'm just saying I'll go with it. Where then do you have the validation that, hey, and this is how it's happening? Kind of like I said, if I took you down to the pool and we can see the guy's heads refracted and, oh my God, where do you have that part?
Yep. So again, look, if I go out into the reality and I'm at 1,000 meters and I'm looking at something in the distance that's also 1,000 meters, right? Because light is bending downwards and supposedly the Earth's flat, that will appear above eye level, correct?
So now you're using, now you're using the claim that it's always bending in this way to say, oh, and if it were flat, it would be doing this other thing.
Right.
That's a whole nother set of ad hoc. So, well, again, you haven't
It's
really.
not ad hoc.
No.
If light bends down, an object will appear higher.
That's not really responding to what was asked, though. The question was, if you're saying this thing is bending, how have you then shown in the real world, hey, here it's bending. This is bending differently than what the actual Earth is. Here I have these measurements of the physical Earth. It shows this curvature. But hey, I then look out there and it's not showing this curvature. It's showing as if it's a flat Earth. And then somehow you would have to validate why it's looking like a flat Earth, but you think it's explaining the globe.
Okay. The point of that little observation, right? If I go out and measure that from 1,000 meters to 1,000 meters over some distance, my measurement will be below eye level. But I know that that's actually too high because light bends down. The actual position of that object or the mountain is lower than that. Therefore, the Earth is a globe.
Okay, so this is the next part of your conclusion where you've taken your theodolite over very long distances, claiming that you're measuring a drop, and now it all matches your gradient. You think Earth's a globe.
Yeah.
Well, I'm only repeating it because I've heard it probably 100 times, 200 times. It's kind of the same thing that you bring.
Yeah, it's pretty simple. Light bends down, right? So the actual position of it is even lower.
Well,
and if we measure an angle,
that's the part. How have you validated that? That's, I think, perhaps
the deductive argument that we've had for the last half an hour. The density gradient is more dense at the surface, less dense higher up.
So you haven't done it in the world. You've just used all the deductions and all the things to claim that
is that a problem?
Yes, it is, because you're claiming it's like there's a term for it. It's like a priori conclusion type thing. Like
no, it's a deductive argument. This is blowing my mind.
Wait, Gio. So I'm confused. I guess you want like an example with air showing this refraction effect, because we did the sugar water, right? So I guess you want like an air example. Is that what it is?
This is unbelievable. It's just simple logic.
Yeah, you'd have to actually show. Like I use the example of, if I wanted to show you that things can refract through glass or water or some medium or a lens or whatever, I would have to demonstrate that and show how it's happening.
You don't have to.
And how that differs from reality. For example, this guy is in the pool, the glass-walled pool. He's in this position. We can measure. He's 10 feet to the left of this wall, whatever. And then we can look at it from a particular angle and be like, oh my gosh, it's displaced. The glass, the bending of the glass in the water displaces it. And then we can show, that can be shown. So
you know how you guys always asking for proof, right? This is one of the only times, right, where I will give you proof. It's a proof by logical deduction.
But that's not
if you accept the premises, then you accept the conclusion.
But
dude, you could say that about anything. I could say, there's little leprechauns that are controlling reality, and
I reject that premise. Do you accept my premises or not?
But my point was just going to say, like, if you accepted that premise, then I could say, oh, and they really like eating green apples, and therefore when they eat the green apples, they're happy. And then you're like, okay, well now you have to agree that they're happy when they eat the green
No,
apples.
I reject your premises. Do you accept or reject my premises? This is such fundamental logic. It's blowing my mind. Do you accept that light bends in a density gradient, refracts in a density gradient? And then step 2, does our atmosphere have a density gradient? And then maybe step 3, like which direction does it bend? If you accept those, then you have to accept the conclusion. This is the only time I will say proof.
Can you show me light bending down and lifting objects up?
Again, we're talking about logical proof here, Whitsett.
No,
we're talking about logical proof.
Well, maybe that's what you're talking about. But what Napalm asked you for is what Whitsett just said. That validation.
Right.
Where do you? That's what you.
Yeah, and I measure it because I know the Earth is a globe, right? I know that the light refracts downwards and will lift it. So if I measure something below eye level, I know that it's curvature of the Earth.
It's literally a begging the question, right on.
No, it's not. No, it's not.
And by definition, text.
No, it's not.
Yeah, right on the.
If my measurements are consistent with the Earth being flat and inconsistent with it, consistent with it being curved and inconsistent, I disprove flat Earth.
So, can you show me an example of light bending down and lifting objects up?
It's a deductive thing, right? If you accept
deductive would be that if light bends down, it's going to make something look like it's lower.
No, you're retarded.
Well, how so?
Come on.
Whitsett,
Let's go back.
hold on, Whitsett. If I
just explain why you think differently. You don't
well,
have to-
it was on the screen for half an hour. Did you not see it on the screen?
I was 100% enjoying myself more than talking to you. I was talking to my wife.
On the screen. Can you see my screen? And I can't believe you've been in this arena for so long and don't know this.
Ask for proof. Evidence.
You asked if the light bends down, right? You said it would appear lower.
I said, can you show me that happening?
Again, on the screen, if light is bending downwards, do you understand that it will appear higher? If you don't understand that, go away and figure it out.
Oh, just because you say so?
Do you not understand what's on screen?
I mean,
you understand that it appear higher.
You're trying to make it's almost like a periscope where it's actually bending it around like a periscope does, but so it looks higher than it would be otherwise.
Does he understand why? That's a simple question for Whitsett. Do you understand if light bends downwards, things will appear higher? Do you understand?
Well, that wasn't really the discussion. Napalm and myself and Whitsett now have been asking you to show that light is bending in this way.
Right.
Not just
I keep telling you it's deductive.
Deducting. I know, but that's okay, dude. Remember before when I said if I wanted to show you the glass line pool with the person, it looks refracted, and it's like, or the thing with the arrow and the water where you put the arrow and you pour the water in and it shows the other way. It like mirrors it. If I was making an assertion like, hey, this happens with whatever, and you were to say, no way, I want to see it. And I would say, yeah, check it out. And we would go look at it and I would actually show you. So we're asking for the equivalent of that. Can you show that happening in the work? Not what you're doing is kind of a bunch of ad hoc things and paste them together. And please believe me on this, believe me on that, believe me on this. And I'm going to deduce through a
proof.
No, it's a begging the question and a reification combined into
this
one.
Is a deductive proof.
Well, can I just? I'm confused. So, I mean, why isn't the sugar water thing allowed or whatever? I'm confused on that.
What you're talking about, Armor, is like saying if
an object lifting up,
like visually.
Yeah. Like if light bends down, show me the object being lifted up.
Yeah,
again, it will come back to whether you accept that light bends towards a denser medium.
There you go.
We can show you that.
Okay, now I'm just
do you accept
debunk you? Is that cool?
Do you accept that light
Is it
bends
cool if I
towards
just
a denser
debunk
medium?
you?
Well, you can answer the
I'm tired
question.
of playing your game. You're not going to answer, so I'm going to debunk you. I'm going to show you that what you call me
Give
retarded
me an L. Give me an L in the ass. What's it?
No problem. I can actually demonstrate what I'm talking about. You're making up fairy tales.
Okay.
Here we go.
Debunk me. Go.
Okay. Let's see. Let's talk about this. So where's the more dense medium in this picture?
Debunk me, Whitsett. You're not answering my questions.
Where's the more dense medium in this picture?
Debunk me, Whitsett.
Where's the more dense medium?
I've asked you questions, Whitsett. You refuse to answer. Answer my questions.
Just go back and forth, dude. Just let the conversation flow. He asked you a question. Just go with it. He asked you a question about the refraction at the.
But didn't Ruiv ask him a question too, or at least from what
You're both afraid to answer, Gio, because the truth is they've all just said this.
Do you accept that light bends towards a denser medium, Whitsett?
Light optically.
This is his shtick again. This
Yeah,
is
here you
his
go.
shtick.
At the
That's all
very
he can
least,
do.
He refuses to. All of you refuse to answer the question.
all right. Well,
All
at
of
the
you.
very least, hold on. If we're having the live stream panel like this, though, we have to go one at a time and let each other speak. Even if you don't think he's answering your questions, you don't like it or whatever, just let him speak because we can hear what he says, hear what you say. We can all hear what each other are saying. Otherwise, it's just gonna be a shit show. So go ahead.
It will look like it moves towards the more dense medium. So if we have this glass of water right here, the water's more dense than the air. So we put the pencil in here. Where's the object look like it is? Lower
Just
or higher?
debunk with it. Just debunk
Does it
me.
look
Come on.
like it's in the direction of the more dense medium or the
No,
opposite?
I'm not answering any of your questions. Debunk me. Just keep going. If you answer my questions, I'll answer
There
yours.
you
All
go.
right?
So the water's more dense than the air. So if the light looks like it's bending towards the more dense medium, the object looks like it's lower where the more dense medium is. Thanks for playing.
Okay, thanks.
That must suck. That for 7 years you guys have just repeated something easily disproven. So can you
Okay,
show
so
me an
does,
opposite
does
example?
light bend towards the denser medium? Yes or no?
Yeah, it makes things lower.
Oh, Jesus Christ. Look at my screen. Please look at my screen.
I'm looking at an actual demonstration.
Please look at
Actual
my screen.
demonstration,
Right?
not
Do you
just
want-
begging the question, Ruhif.
Again,
Hey, Ruhif, I think you should put a different cartoon on there for your claim. I think that
Do you
makes
not,
it more
does
believable.
any flat earther understand why the apparent position is higher if light bends down?
Well,
Any
I'm
flat
looking at
earther
it be
here?
lower.
I think you should put the wording in crayons too. So keep the cartoons and put crayons on there. I think that'll make your proof much better.
It's
So let's ask
demonstrably
Dan. Dan, do
making
you
it
understand?
lower.
Do you understand why it appears higher?
I understand what you say about it. Yeah.
Yes. You understand if light curves down, then it will appear higher, right?
I'm sitting here looking at it look lower though.
Dan, will it look higher? Will it appear higher?
Okay,
No,
so
it'll move the
you're
image
saying
down.
that
Yeah,
you're
the
saying
one
that
the
a
image
typical
will move down.
sunset that I observe is of a sun that is already set.
Wait,
No,
hold on.
I'm asking a simple question. Is
Yeah,
there a
yeah.
flat earther that understands that the apparent position will be higher if light bends downwards?
We understand that's wrong.
Yeah, you keep saying
Anyone?
that, but wait, is the light in the pencil right here? Is it bending down towards the water
Oh,
that's more
we
dense?
can map out a curved glass and see where the light goes, and it will bend towards a denser medium. Do you want to do that?
It bent
Should
towards
we do
wait, so the object will look like it moves towards the denser medium?
the path of light when it hits that boundary of the glass, it will move towards the denser medium. Obviously, with the glass, and
So
then
the
the water.
pencil
will
It's
looks like
be-
bollocks. It's nothing to do with the denser medium. It's just to do with
Yes, it
the optical effect of the lens. All it's doing is shifting its image in its apparent position. There's no light bending. It's just shifting the image, and it's nothing to do with the denser medium at all.
All right, let's ask some globers if they understand that the apparent position will be higher if light bends downwards.
Dude, that's your NPC script. They're all just gonna say, yeah,
Well,
of course.
Of course,
Do you
because
have a
they
demonstration?
understand it, right? They
Demonstrate it.
understand it.
Can they
It's
demonstrate
on
it?
the screen. It's on the screen.
No, I showed
That's
a
the
real
demonstration.
demonstration of doing the opposite of what you're claiming.
That is the demonstration. The path
about
of
the-
light leading to the object is curved downwards, right? Your eye will see it at the angle it comes into your eye.
Hey,
There's
Armin,
no
does the
path of
pencil look
light.
lower or higher than it is in reality?
In that
So-
picture?
Yeah.
So
I mean, I guess it's kind of. I mean, lower. I guess I don't know.
The actual, right, the actual position of the sun is lower.
Well, I've been trying to
Right.
come in for the longest time now, so I'm trying to.
What do you mean you guess? You guess the pencil looks lower? Does it look
Well-
lower or higher?
All I know is that I've seen sugar water fucking video. All right, that's all I'm trying to say. All right, I've been trying to get that
no,
in.
we looked at it. Brian actually debunked that and showed that it showed something lower. So can you answer my question? Does the pencil look
He didn't
higher or
debunk
lower?
that first off, and also I'm pretty sure I looked at that and it did exactly what it was supposed to.
Does the pencil look lower or higher?
Well, I already said my answer, man.
Say it again.
No, I'm not gonna. You heard it already.
Okay, so wait. Why is it? Wait, is the water more dense than the air?
Yeah, the water is. I don't know the specifics for this cup though. I don't know what goes on in this whole little thing though. But I've seen the sugar water. I've seen a few examples actually. I even seen one with air actually.
So
It
wait,
was
you're
like
saying that
one I guess he did.
the more dense medium is the water, so the light's bending towards the water, and the pencil, the object, looks lower in the direction of the more dense medium.
I mean, it's also magnified too a little bit. So there's a lot at play here. So I don't think this is
Yeah.
equivalent. The pencil is a little bit larger.
Yep.
Yeah,
Magnification, it gets lower, it gets
Yeah.
magnified.
So hang on, is Witzer claiming that the light in this pencil, like the pencil image, is it not bending towards the more dense medium? Like what is which way do you think it's bending?
It just appears to be bending.
Yeah,
It's
light
not
doesn't even travel. Like, I mean, we're not even getting to that. Ruif, does the pencil look
That
lower or
might do.
higher than? Does the
That might
pencil
do
look?
me. I think if light doesn't travel.
Hey, Ruif, does the pencil look lower or higher than
Does
its
light
actual?
bend towards the more dense medium?
Dude, Ruif can't even answer, dude.
Oh Jesus! I literally asked you that question 10 times and you refuse to answer, and then you accuse me of not
It appears to move towards the more dense medium. Sure. So does
Yes.
it?
Okay. Does our atmosphere have generally more dense
Yeah,
towards the
absolutely.
surface than higher up?
Mhm.
Okay. So in our atmosphere, does light tend to bend downwards?
Sure.
Yes. Okay. When it bends downwards, what does that do to the apparent position of an object? It's on the
Makes it
screen
lower.
right now. Hint, hint.
Lowers
You're an
it.
idiot.
Lower.
You're an
Lowers
idiot.
it.
Well,
I'm
okay.
gonna
So
go.
now I'm
Hold
the
on,
idiot.
that's
No,
your rebuttal, Ruhif. Is just
Yes.
you're just saying
It's on
Ruif.
screen now.
Okay,
Hang on.
Ruif,
I'm
can you
out.
answer
hold
the
on,
question?
hold on.
I'm gonna go clip out the
Yeah.
concessions from Witsit.
Okay,
So anyway,
flip out. Go run away.
Yeah, hold on. I keep looking at your screen, Ruhif, and it's just like the same cartoon thing. Do you have actual like physical, tangible, real world evidence? Like, Witsit put a picture of something of within reality, at least, right?
see
Do you
if I
have
can
anything?
He literally ran
analogous
away.
to that?
He literally ran away.
Let me see from
Yeah, I
this.
think he went to feed the dogs, and I think the answer to that is he does not have that.
There's plenty of. I've seen plenty of examples where it does the opposite, though. I mean, I think the water pencil thing is just sort of like a, kind of like cherry picked almost, because the pencil's
Ooh.
also scaled up too. It's also larger too. But in the videos that
Ooh.
I've seen,
Is it a parlor trick?
Not
Would
a
you
parlor
call it
trick.
like a parlor trick?
No, it's not a parlor trick, but it is larger though. Like look at the pencil; it is larger, so there's a little more going on there. But in the
Things
video,
look like they're larger in the atmosphere.
I don't know.
Ooh.
But here,
Oh,
let
well,
me real fast pull
objectively
up.
and provably they do. So
Okay, but I haven't really seen stuff like from that though. But
that's
that's not the
not
point
very
though. So
cool.
real fast show
Why does the
you
moon look like it's
refraction,
bigger?
hot
Why does the
air.
moon look like it's bigger sometimes?
That might just be like optical illusion, like where you think it's bigger and it's not, because you would have to actually measure that to say it's bigger.
No, but why does it look like it's bigger?
Wait,
That might just be an optical illusion, and you have to
Based
measure
on
it before
what?
you just say, based off of just like I know there's one like explanation where it's like, oh, things around it, whatever. There's a few other things. Like you ever see that little optical illusion where you have like big objects next to like a small object, or and vice versa, where small objects are next
Oh
to like.
my god, dude! Armor, your own paradigm has something called astronomical refraction, and there's a magnification effect in astronomical refraction. That's the official globe answer for the moon looking bigger.
Oh, okay, but I mean, let's actually measure it though, because I mean, like this saying, oh, it looks bigger. Like let's actually measure it.
Hey,
Otherwise,
buddy, your own paradigm says there's something called magnification and
oh, that's
astronomical
cool.
refraction.
That's cool.
So then the atmosphere does make things look bigger. So can we get back to the point? Does the pencil look higher or lower? You admitted it looks lower. Is the denser medium higher or lower? It's lower, which means that the pencil is actually looking like it's moving and displacing lower towards the dense medium.
Well, I've seen, examples, especially like from Jesse, what's his name? Jesse.
You mean something that would cause
Gordon.
something to cut off from the bottom up? Huh. That's
Oh,
a thin script.
weird.
Yeah.
Same with like
It's
the
all-
atmosphere causing something to appear magnified, right? So can we use like a Ruhif argument and just say, hey, Arma, do things appear to be magnified in a more dense medium?
I don't know. I haven't really seen examples besides like literally that.
Wow, dude, there's 1,000 examples. What about when someone's in a pool?
So if
Yeah,
things
that's the same
appear,
one. That's the same
can
example.
you
It's just more
agree?
water.
Well, that's the point.
We could take you down the same road that like if we're trying to be disingenuous and try to prove a point through deduction and not actual like physical evidence, we could take you down the road that Ruhif tries to take everybody down as far as refraction is concerned, and we could say, hey, Arma, do things appear to be magnified in a more dense medium? And show you the pencil example right there, right? That Witsit put there. Does that appear slightly magnified in the more dense medium?
Yeah, I guess in that example, yeah, sure.
Yeah, and that's
I don't
not
know if
even a
that's
cartoon.
I don't know if
Like
that's always the
Ruhif's
case though.
drawing a cartoon, right, and putting in some words. So that's a real world thing right there. So now I could take you down the road of is the atmosphere more dense towards the surface?
Yeah, it's more dense. Yep.
So would you say as the sun gets closer to the horizon, it's entering the more dense portion of the atmosphere?
I guess it's visually in that area yeah.
So since we know things get magnified through a more dense medium, wouldn't it stand to reason that the sun wouldn't reduce as much in angular size as it's going further away and getting closer to the horizon because it's being magnified?
Perhaps, and I get the argument you're trying to like
Which
take
is
apart
exactly
roofs,
what
but
we'd expect on a flat Earth. Blah blah blah. Ergo, Earth is flat. Boom. There's my proof. You're a retard if you don't understand it.
Logical deduction.
I'm not calling you a retard. I'm just saying that's kind of the projection.
Hey, Arma,
I
is
wouldn't
this
call you
kid?
that name, by the way.
Arma, does this kid look like he's bigger than he really is in the water?
hold on, let me see. Give me a second. Yeah, he does look bigger.
Right.
Yes.
Yeah. Okay. So when you guys claim every single time that light bends to the more dense medium, it lifts objects up. That's a baseless and provably false claim, right?
I don't know about. Hold on, say that again.
When you say every time that when light bends to the more dense medium, it lifts objects up, that's a provably false claim, right?
You mean provably false?
Is there some other interpretation of those two words that I wouldn't understand?
I mean, when did you prove that? I mean, besides the pencil thing, whatever. Because like that pencil thing.
Besides the pencil thing.
Well, the kid's body doesn't look any lower. In fact, it actually looks higher than where it should be.
Oh wait, why that's based on
Am
the
I-
angle? It's based on the
Yeah,
angle.
exactly. So then what do you want about that? I mean, if you're
Wait,
saying, oh,
wait.
it's based
Does
off the angle for this
okay,
example,
you
because
guys
it's
claim that it always happens. You guys claim every single time that light bends to the more dense medium, it lifts objects up.
Yeah, I mean, I guess because with this is sort of like a hard cutoff thing, whatever. So I don't really know if it's like, I mean, I guess it would still do the thing though, but I'm sure there's a lot of things we're sort of like just glossing over, or whatever, that we're just sort of like forgetting, whatever. Because yeah, in this example, you'd be right. Yeah, it's like all right, or at least pencil example, you'd be right. Like yeah, that it looks to be lower or whatever. But like I said, from the stuff that I've seen, all right, in terms of like the sugar water or Jesse's like video that he has where he actually has like hot and cold air in a little fish tank, whatever. And also just like like putting like what do you call that? Like an iron thing, whatever, next to like a light, whatever. It always seems to bend towards like the denser medium, whatever.
Okay. So have we determined that maybe it has something to do with where you view it from?
The angle, I mean,
Yeah.
I mean, I know they say, I know there's the whole argument where, yeah, like if you look at it from different angles, then it's like less apparent or something. Like I said, I don't know too much on this. I just know enough to where it bends towards the denser medium. I don't know, like, like obviously with this example, we have the water and you have, the kid, that one's a little bit weird, whatever. Like I said, I don't know enough, but from what I've seen though, it usually, bends towards the denser medium, which means it'd be higher.
Let's read what I just asked ChatGPT. Let's read what Daddy Bot says here.
What?
Okay, I said if light bends down to the more dense medium, will it cause objects to appear higher or lower? I said, when light travels from a less dense medium to a more dense medium, it bends towards the normal, which is an imaginary line perpendicular to the surface where the two media meets. This phenomenon is called refraction. If an object is viewed through the interface between the two media, the apparent position of the object will be shifted due to the bending of light. The direction of the shift will depend on the angle of incidence of the light, the refractive indices of the two media, and the position of the object relative to the interface. In general, if the light bends down towards the more dense medium, the object will appear higher than its actual position if viewed from above the interface, and lower if viewed from below the interface. This is because the light from the object is bent away from the normal as it enters the more dense medium, causing it to appear to come from a higher point. The opposite is true if the light bends up towards the less dense medium. It is important to note that the amount of shift will depend on the specific conditions of the refraction and can be calculated using Snell's law, which relates the angles of incident and refraction to the refractive indices of the two media.
Okay, so it seems to be that like angles a big part of this.
Yeah, so why the Globers leave that part out of it for 7 straight years?
I think it's because, I mean, I'm just guessing at this point, but if I had to guess, it's probably because for the globe model, obviously, the Earth is bending downwards, so I imagine the angle that we would have would be where from above or whatever. So that I don't know. I feel like the angles might work there or whatever. But I guess I'm trying to think if you're on a flat Earth though. Yeah, like I said, I don't know enough on this though, but you might have somewhat of a point though. But like I said,
Yeah.
I don't know enough though.
Your ChatGPT is their kryptonite, bro. Like, you don't have to just believe it because I read it off ChatGPT. It's wrong about a lot of stuff.
Let's see, it does.
But all I'm saying is we showed you an actual demonstration, right? So it would be nice if you could at least show a demonstration. And when I said 7 years, I really shouldn't have said that because the globers constantly update their position. First, boats disappear over the physical curvature of the Earth. Every single time you see them disappear, it proves the Earth's a ball. That turned into, oh, never mind. You can bring it back from behind what looks like the alleged curve. But eventually, once it disappears again, that's really the curve. And then, of course, we ended up seeing way too far. So it's like, first it was a mirage. It was an inferior mirage or a superior mirage. And then that turned into, there's something called terrestrial refraction. And we now have standard refraction. That was literally created after the flat Earth conversation. Isn't that interesting? That standard terrestrial refraction was created after flat Earth.
I mean, I don't really know too much on that. I'm gonna have to look into
Why
that.
is that though? That's not weird. So you guys are constantly updating how you explain the globe, like literally.
For a
So
whole year, Rumpus never mentioned refraction once.
now every single one of them say it. Now the people that are new to the conversation, they all repeat it
Well, I mean,
immediately.
we're just getting better at our arguments. I mean, that's just how these debates have been. We've just been
Okay, how are you
getting
getting
better and
better at
better.
your arguments if we just now
Coping.
showed that what you say as a collective is provably and demonstrably false?
I said better. I didn't say best. All right. I mean, just because you could, something's taken down, just because you defeat something doesn't mean it wasn't better that time around. We're getting better. We're both sides are getting better. It's just, sometimes we
So if
still
we
make,
see that refraction can actually cause the object to be displaced optically towards the more dense medium, that drastically hurts the globe. And when we make long distance observations, if it's getting displaced lower, that's even worse for the globe.
Well, we have to say thanks to all the Globers because without them, our model wouldn't be getting so more accurate day by day, inch by inch.
That's true. Now, Arma, check this
Yeah,
out.
our swords are getting sharper and theirs are getting very dull.
Yeah. Like, did you see how Rumpus left, Arma? Like, I answered all his questions. I asked him a basic question. You were able to answer it, but you had to throw a I guess in there. But you saw he just left. How long do you think before the Globers collectively address that what they're saying is wrong? Do you think they'll ever do it?
On what? I mean, because once again, I don't know enough on this topic, so there could be more than I'm just missing. I'm not gonna say like, oh, you're 100% right. Maybe you are right, but I don't know enough on like refraction to really say for sure like this is how it is or whatever. I just know the basic. Bends towards the denser medium thing. That's it.
Okay.
Because it has to be a ball, right? There's no way you could be wrong. There's no way you're gonna stick to your guns at any cost.
I'm still trying to. I mean, I'm sort of kind of half talk right now. I'm like looking for a video right now, but
You'll be a flat earther one day. I promise you.
I highly doubt it, but let's see.
Well, you will when it's like all the way out.
So, am I demonstrating 27-mile lines here on my video or not? I mean, we got people on the other side. You can see the little green laser, a couple of flashes of it, so we can tell that what we're pointing at. I don't know what would make these lasers light up for 27 miles. So, I do know we're not diverging as much as they think. It's not that cone shaped, really.
How many miles?
That's 27 Salton Sea.
Did you know that you can buy a? Apparently, there's like a $4,000 laser that will shoot 5 miles and have just like a couple inches of divergence. Isn't that crazy? I don't know how much these are, but that's like crazy. Like it's I think it's 5 miles and less than 6 inches of beam divergence.
What's fucking me up right now is like Jaren had the problem with the middle point. We are trying to figure out buoys or balloons or what the fuck we're supposed to do to catch the middle point at these distances. And then all of a sudden I was looking at Pontchartrain and the power lines and thinking, damn, if you just put a laser on top of one of the cement pylons and shot it down those things, we get our center point reading pretty quick, and the difference between the surface and the light curving. And then when the temperatures change and the light sources change, we could prove that the light's always straight and so's the earth, or so's the water.
Well, that is interesting because there's multiple pylons. It depends on whether they're all the same height or not. But yeah, that would be interesting because if you shot a laser, like I was thinking of if there's like cement blocks and you could shoot it like above the cement blocks, you could potentially shoot it, let's say, 2 feet above the blocks or some marker that you could use.
Just right on top of the blocks, an inch. Just literally lay the thing down on top of the block.
Yeah, because if the Earth is curving and the laser's straight, then it's going to start to diverge. Like that extreme curvature that they show with your naked eye, you're just seeing this warping as if the Earth has a radius of about 50 miles. It's like warping like that. It's like you should be able to visually even see the laser either curving along with it or shooting straight in deviation. Anyways, yeah, that would be interesting to kind of break down how much of that's optical and and if you could go out there on a boat and make the markings. There could be something interesting to do there because it does seem like a unique place where there's some refraction happening there.
Plus the
That's my point a long time ago, bro. The pylons at Pontchartrain, bro. We could do a lot there. We could maybe draw a straight line. It'd be in increments, but that'd be our best chance of drawing out a straight line on them pylons.
And then when you redo it in different weather conditions, that shows you that it doesn't affect the light in the ways he's claiming. Everything would be so minuscule that it's just not even, the idea of a solid or of affecting something with such I'm not sure what parts per million Jesse was getting when he was playing with the fish tank, but when you're talking about changing something to the 100th and 1000th of times, we're just not increasing the air that much until you get real wet weather. And then of course we know that is clouds, and fog. You can't see through that. But damned if we don't just sometimes get clear days, and their denial of that and applying standard refraction to a clear day.
Which fish tank video are you talking about from Jesse?
All of them.
Okay, well,
all of them, and the
only you analyzed one of them, didn't you, Riggs?
Did I what?
You analyzed one of them, right?
Well, I mean, I've looked at the stuff he's sent. It's just garbage. Like there's like a 200 plus temperature range in one of them, like right next to each other, and he's like, "Oh, that's reality." I'm like, "No, you're fucking insane."
How do you plan on scaling it down though to a fish tank size? I mean, without doing that,
You don't. Everything about the globe is unfalsifiable by nature. It's literally designed that way. It says, "Hey, look, let's create a scale that's so massive that no one can call us out." That's literally what it is in every endeavor. I don't know why you can't see it. It's actually insane. No, look, there's nothing else in this world that covers all of its bases specifically at the limit of your ability to perceive it. Nothing works that way except the globe because it's designed that way.
I don't know about that.
And actually, the only reason that we figured it out is because the technology for optics has increased so much that it actually superseded their presumption about how far we could see. I'm sure if they could change the model after the fact, they would, because it's causing them a little bit of a problem. I mean, they can change the size of the stuff external to us, but they've kind of locked in with the stuff terrestrially.
All I know now is that for us to fucking have curvy, bendy light at the same rate as the Earth, we would have to have our laser off level. We'd have to be shooting upward. To make an arc reach the other side without burying itself into the water. Well, I guess they're going to say that on the curvature of the Earth, the water wouldn't be there. I don't see how we're obtaining line of sight on a globe.
Yeah, because the best you could do is like level your laser at your local plumb for what they would say is to the center of the Earth, and then now you're shooting the laser essentially off into space. But instead of it going off into space, because of Ruhif's ad hoc density gradient radius reification claim, it's just a deductive ad hoc thing that he just wanted everyone to accept without actually validating it. They then claim that whole bucket of can of worms is explaining that laser, instead of shooting off into space, is going to just perfectly curve around the radius of the Earth to hit a target as if it was just shooting right over a level planar surface.
Well, there was another fish tank video. That's what I was asking. Sorry to interrupt, but there was, I don't know if Jesse did it. That's what I was trying to find out. There's a bridge inside of a fish tank. Is that one that Jesse did?
He had an object in there. I guess you'd call it a bridge.
Well, he had some kind of arc inside of it. I don't know if that was his video or if he was just linking it. But it's very clearly in a fish tank that is flat with an arced bridge inside. So if he's trying to create this possibility of seeing around the bridge, what you're doing is you're looking through like flat layers of medium. I mean, it would be one thing if the fish tank were curved and the mediums were curved, but they're not, just the bridge. So you're essentially proving that on a flat Earth, you can see around a bridge. Good job.
We thought at Bear Lake when it was really cold over the ice that when we were doing one test, we really couldn't get it to hit us, but we could see it going over our heads. And we could sort of see it hit a cloud because it had been stormy and like get caught up at that level. So I think that was a true refraction, basically, based on the density. When it hit something dense, it hit a cloud. But we literally couldn't bring it down because there was clouds between us.
Those ones you're showing there, what's the distance of those?
27.
Wow.
Yeah. And at the very, very last minute, when it goes to the single violet colored one, you could see the green laser on the other side. It also sort of flashes in the middle really quickly. So they're shooting back with a green one. There's some shoreline homes lit up there that are not quite that far away. But that shows you that in these images, we can see the shoreline all the way around. I don't know where you'd have 200 feet of curvature, At the same time, these lines can't be straight. They wouldn't be lit in the middle. So I don't know why it appears like they're going all the way across.
Yeah, they're just like a straight shot across. I mean, to think that that's behind the curve of a globe with a huge hump of water in between, that is such a far stretch. I mean, those look straight as an arrow.
These are both from the road, also about 18 feet up. And it sort of, to me, negates their, oh, you can't get so close to the water shit. But now he's saying I got to go a football field in the air. Fuck off. How am I going to measure parallel to the ground up there? Fuck. I don't even get it. Why? I mean, it's just, I don't remember anyone saying gradient anything until we started pulling this shit off. Then suddenly it's like, oh no, you got to measure up in the air too. It's like, why? You know, and it's like, okay, I'm 20 feet higher. Oh, that doesn't matter. Oh, okay, I did it hot and cold. I did it during the day and at night. Oh, that doesn't matter. It was 30 degrees this day and 60 degrees the other. Oh, that doesn't matter. Oh, we got different color lasers. That's the different frequencies. They should bend differently, right? Oh, that doesn't matter. It's negligible. It's like, fuck you. So angered by this. And that this footage isn't out. The good footage of this isn't out. Angered by that, too. Fucking bureaucratic horseshit in the way of everything. But this isn't going to wake people up. It's a psychological battle. Even if it's not good and evil, it's still psychological. They just got such an edge on us with programming. They got everyone programmed. That's why I'm fucking back to the lab coat, man. Just like the lab coat.
Just
People are
normie penetration.
Huh?
Normie penetration.
Yeah.
That's all you should be doing.
And it's like, just like the, I mean, I need to go back to the beginning. I was proud to put my face on the whole idea. And that's really all I could do is go, yep, we're really here. Fuck you. We're really here. You know, and at this point, I'm sticking with it right, wrong, or indifferent because it doesn't bother me to be able to bitch about everything else. So really, it's just an excuse for me to bitch about everything else that's wrong and how this government has been disappeared my whole lifetime. You know, my whole lifetime, this government's been dismantled.
Was it ever really your government?
They say that's one of the problems with the
Statism, yeah.
Yeah, is that what it's called? But also the people that where they think their individual rights outweigh the rights of the people, you know, of the greater body. I have the right to this and I have the right to that. And they say it's a super American thing.
Well, everyone loves the government until it applies to them, you know? Like, it's all about the benefits, the perceived benefits.
Oh my God, I learned that. I went to live at my mom's once. She was living in Boston. And during the Big Dig, her husband at the time was working on that Big Dig project. And I found out that there was like politics. There was like, not only was there a homeowners association, which I thought was normal, but it turns out there was an anti-association. And I guess my mom's was like the drop-off spot for little leaflets and shit for the anti-organization. So I learned that minute that politics happened at such a small level that I always thought politics meant government. But politics really happen at small levels. And I'm sure the government, quote unquote, you know, knows exactly what size groups things get to be a problem. And I think we're going to have to take advantage. I think we're going to have to take advantage of our flaws. You know, yeah, we're crazy and go ahead and laugh. And I think that's going to keep us from getting shot. The fact that they're going to laugh at us is going to, and that they're still interested in us as a spectacle, I think will get the truth powered down. You know, like, if Austin breaks on the internet big, you know, and someone that knows how to speak in 40-second fuck off, you're done in 40-second blurbs, we can communicate with the masses. But it's
Have
that
you
short
been
attention.
practicing your 40-second blurbs?
But I know we have them everywhere. And maybe this AI shit will help us to bring them so we don't have to put our faces out there. Like I just saw one of these things, somebody made Jesus talk, and it was like, oh no, I didn't even think about that, and messages will be delivered visually so much easier now.
Yeah, and I think there's way more open-minded people. Like I think the whole scamdemic thing, the lockdowns and everything. Certain people obviously went with that more. I'm not trying to go into that whole conversation. I'm just saying some people really were like, yeah, get the jabs and doing the whole thing. But a lot of people were either in the middle or not, whatever it may be. But I feel like that activated something in a lot of people to where I think in a lot of people's minds are like, okay, wow, like nothing's off the table of what could be going on at this point.
Yeah, that's a good summary of that, huh? Because it's so crazy. It's almost like impossible to summarize except for the way you did. So crazy. Because it's like, yeah, there is a worldwide conspiracy. Yeah, they do plan things in advance. Yeah, this does go back 40 years or more. Yeah. It must be easy when you have big plans knowing you just have to go through a couple generations to make it happen. And by then, people forget the way it was anyway.
Yeah, like will there be a day where they can throw the moon landing under the bus? Something, oh, that was just an old propaganda thing, because it's going to be outdated at some point. Like all the people that were live during it at some point are going to be passed on, and then everyone else kind of just, mildly, oh yeah, we went to the moon, but they probably didn't even look into it or haven't even seen the footage. Like a lot of kids that were born in like the 90s or 2000s, some of them probably haven't even seen much of the footage. Maybe a picture here and there, but. Anyways, I'm just saying, it's just that way that time can kind of.
I hear people online that don't really know about 9/11.
And they use world wars and these genocides to like change culture in ways that it's almost like a mass erasing.
It's like an antibiotic.
Yeah. Just blow out the whole old thing and cause a bunch of war and then create some baby boomer, some new world with NASA and United Nations like they did after World War II.
Think about what a small world media is, as a business and how easily they really did bottle it up. Because there's less correspondence for newspapers or, media outlets. There used to be 3 media outlets, for news, the API, UPI, and NPR or something. There used to be a third one. I can't remember the names of them, but they were in every city. There was reporters in every city for everything that went on worldwide. And now it's just a press release and it doesn't get investigated or challenged. Just like we hear that, the 16 screens of every reporter scripting the same thing. That's not exactly. It's not reporting. I mean, it is, I guess, news, but when it's scripted like that, that's pretty intense. It's hard to tell normies about, the Gates Foundation and what was that, Agenda 201 or what 201? What was the name of that one? Where they did everything.
Yeah, Event 201.
Yeah, they had it all in advance. Then played it out right away. Like as soon as they had it, like while they still had their actors in place,
I've always wondered why they do those. It seems so obvious, but I guess maybe they kind of need to. It's like if you're going to put on a play or something, or like put on some kind of show, you got to do a test run, at least once or twice. Like you got to kind of make sure people are in their positions and, some level of coordination.
Did you have oh yeah, you're here. Like when those white tents popped up overnight in the hospital parking lots? That was weird. Like, somebody had to purchase all that shit in advance. They were consistent from hospital to hospital. It was like decontamination tents or whatever they were.
Yeah.
In the empty parking lots we saw everywhere.
And they had like hazmat suits practically.
Empty. The hospitals were empty while the news was saying it was a war zone and they were overrun.
They had to show bodies from Italy and say it was in America.
Right, yeah, from a movie or something, right?
They faked the footage to show that it was a full hospital.
Oh.
So in terms of that, I don't know if we have to tread lightly on streaming or whatever, but it's probably fine. But I was just going to ask, with that whole thing, if we view that whole pandemic thing as an event, sort of like there's the 9/11 event, there's these different events. If we view it that way, in terms of that part of it, like, do you think there were any hospitals that were overrun? Do you think anyone was going in? Or do you think there were some that were? Or, I mean, the thing is, the people that, that they claim were going in, it was not like, oh, I have the sniffles. Oh, I have a sore throat. That's not what they were necessarily going in for. Like,
that's the mind-blowing thing about it, is everyone didn't get sick. And imagine if they just put out a cold more often. Like, imagine if they just had everyone the sniffles. We'd have been sold. If we were all sniffling and afraid of dying, we'd have all but gotten jabbed. But nobody was sick. So it's weird that they didn't attach random flus around, just to get people on board with being sick. Like, they didn't have to die. They just had to have the sniffles. We'd have been scared to death, you and I, right?
Well, I think people still got sick, seemingly kind of somewhat at a normal rate. Like, people obviously get colds or little flus here and there and whatnot. So, I mean, I think people still got some stuff like that during it. But, well, I was in a parking lot once after I got out of the grocery store, and I was sitting in my car, and I had my window down, and I forget what I was doing, but I was just kind of chilling there for a minute. And I just overheard this woman. This was kind of near the beginning of it all. And I heard this woman in the parking lot, and she was saying that she was a nurse at a hospital. And she was saying that there was something going on. She said people were coming in with like acute organ failure and acute breathing. Like, not that they were coming in like, oh, I have the sniffles, I have the flu. Like, they were coming in like, I'm dying. Like, I cannot breathe, like gasping for air. And then their organs were shutting down and stuff. And she was saying, like, she was like, oh, I've never seen anything like it. She's like, the people are coming in, and so she's like, we can't really do anything. We can't really do anything for them or whatever. So I'm just throwing out there, like, could there be a bioweapon that was involved at some point?
Yeah, it was a massive nocebo effect.
Well, I mean, I'm just saying, I overheard her, so it's obviously
organ shutting down is a direct result of stress and being in fear, and a regular sickness will turn to the next stage. Someone who's very sick next step is to die.
All right, I mean, that's a fair
possibility.
That's a fair
And
possibility.
guess what? The percentage that's affected, less than 1%, exactly the amount we expect to see with some kind of nocebo, psyop, mind fuck.
All right, so you're saying that there's a certain population in that just explanation. There's a certain percentage of the population who will have like hypochondria or whatever, and if it's that crazy on the news and all the fear,
exactly,
you're saying that there's some that even though they just have the sniffles or they have a sore throat or whatever, they're going to be like, oh no, and then have some kind of stress reaction or heart attack type thing.
Exactly the same thing where you have a small percentage of the population that's very hypnotizable. The same way you have a small percentage that is very affected by nocebos, by fear mongering, by stress, by threats, which is what they did threaten us. Shortage of body bags, you're gonna die. Don't touch anybody, don't 6 feet apart. This is all a mental. It's like a psychic attack. Increased stress, that could lead to organ failure. That could lead to a hypochondria situation. But then the stress is real, right? Why did more people get heart attacks on Monday? Because they're coming back the weekend. Stress hits them, right? Heart attack. A small percentage, heart attack. Then they show us those numbers like, oh, this is really happening. they could have, increased in. I don't want to say fudge the numbers, but they could have increased the numbers. Because how many people died of regular flu? Right, none. Right? Yeah, it all had to be from that.
Well, I think what you're describing would definitely be the case no matter what. That because of all the fear mongering and that there definitely were people that were hyperactively freaking out and probably going to the hospital when they didn't even have to, or even on some little thing that, they feel a little tired or something, and they all of a sudden think, that they're going to need. Remember how much fear they did? Like, you're going to need a ventilator. You're going to need there's not going to be enough ventilators, and it's that whole thing too. Like, that's definitely going to trigger some people, and they're going to freak out. And
Yeah, you ever had a panic attack? It's in your mind, like if you just calm down. Like, I'll tell you a quick story if it's worth something. When I was about 9 years old or 8 years old, we had these candy drives, and we would sell chocolate bars. Chocolate bars were big bars, we'd sell them for $1 or whatever. So I devoured one, right? And my grandfather told me, Eric, you're gonna get sick. You can't eat that whole chocolate bar. I within an hour I threw up because of that what he told me, right? Since then, I can eat a bar or two whole chocolate bars, but since he told me I was gonna get sick, I listened to him and I threw up. He psyched me out. He got me to believe him, and it had the real effect. Make sense?
I think so. I think we're both reading chat.
That's not far off from what really happens.
I wasn't paying enough attention to comments. Sorry.
Did you guys know that Copernicus literally said the Pythagorean teaching of heliocentrism was founded upon hypothesis, and it was not necessarily improbable? The hypothesis of the movement of the Earth is only one which is useful to explain certain phenomena, but it should not be considered as an absolute truth. Yikes. We knew for a fact that it was a ball orbiting the sun way back in the day. Copernicus figured it out.
Is it true hypotheses was the Greek god of all bullshit?
Yeah. But it's just funny he's saying like heliocentrism is just a hypothesis that it's not necessarily true or even probable.
What is absolute truth? Because absolute truth has to be very clearly tested and confirmed and repeatable and observable.
Unless it's an eventual truth, and then it could just hit you in the face later on.
So what's true for you may not be true for me.
Yeah, it shows you how confident he was in it. Like, oh yeah, this idea is really just an idea. It doesn't yet even have any bearing to reality. It's just a conceptual. And they try to claim that that was him discovering it at the time, even though he was just like laying it out as a theoretical possible model.
Yeah. It's super funny. It's after Ruif ran away, some other Glober in here. He said you can prove right here. So Mandelbrot said, he said you can demonstrate how the atmosphere makes objects appear higher than their true position by following a celestial object as it sets with an equatorial mount. And then Ruif said, true that. In other news, I have clipped Witsit admitting that light bends down in our atmosphere. Dude, the Globers don't even understand how that works in their own model. Okay, so that's called like diurnal parallax. So they when say you have the equatorial mount following the object in the sky, they claim it's based on the motion of the Earth, right? So it's like they say that this happens due to the rotation of the Earth on its axis. So as it follows the object down through the sky, the position of the observer is changing, which causes it to look like it's being lifted up. Because the position of the Earth of the observer on the Earth is changing relative to the motion of the Earth. It doesn't have anything to do with the atmosphere bending light. So, of course, it's actually them just following a sidereal rotation and then our position changing relative to the position of the stars as they move in reality, right? And the globe says, well, you can treat it like that, but it's actually the Earth spinning. That doesn't in any way show that light bends towards the denser medium down, lifting objects up. That phenomena is nothing to do with light bending because of the atmosphere, even in the global paradigm. So, just to destroy that nonsense. True that, he said. Yikes. I just didn't know if you guys had ever heard that, but pretty easy refutation there. This is actually why I made the intro to Schooling the Globers. The intro to the Schooling the Globers says the first step. Here it is. The first step is knowing what you believe. Schooling Globers. Or understanding what you believe.
It always starts there. It always takes a whole day to gain their trust. And they just fucking deny. Seems like a small breakdown is when they just go, well, it's just too big, you couldn't see it. And then we have to employ math, and that's a real checkout point for most people. Most people. Done. As soon as you mention it. That's why the laser is impressive to me, because it's a demo. Water in a tube is a demo. Water in a shallow pan is a demo. Water off a ball, the demo. Spinning a tennis ball wet is not a demo. Too much revolution. Wish people'd stop doing that. Seems we should have enough natural demonstration. Hey Austin, what do you think these peepholes in the middle of the monuments where the things line up every once in a while? Is that supposedly because we're in sync with the rest of the Milky Way? Is that why they would say that would be true?
Yeah, they claim that we're moving with the galaxy. And
Which goes
so
against all their expansion, right? Goes against all of it.
well, they claim the galaxy is so immense that you're not really gonna be able to tell. And then they'll show you, like, say you're driving on a highway and you look at the median in between you. Say it's got like a concrete wall. You can see that passing by you super fast, but if you look out in the distance at like some fields, then it'll look like it's going slower, right? So the stars are so far away they don't look like they're moving. And then since we're moving with the galaxies, the stars that we see, we're moving in the galaxy with, so it's gonna look like they're moving even slower. So it's gonna take forever. They're just gonna stay stationary forever. That's basically a stillman of their position.
What's it? What do you think about Walter Bisland's salt flats, Bonneville salt flats curvature? I posted the link. Have you seen that? And then Dan posted a picture.
I don't know, man. We pointed lasers down 35 miles down those railroad tracks.
Where did you find out?
Well, I mean, we did a gradient here where we did 5 miles, 10 miles, 15 miles, 20 miles, 27, and we set up a laser at each point and did that as part of the Flatlanders series.
And you determine it was flat, and they're determining it's curving?
We had line of sight across 35 miles at each step of the way. That's
so no curvature.
Line of sight to me means no curvature. Line of sight to the glober means light must have bent to allow me to have vision. So the fact that the place is called the Flats doesn't mean anything to them, and I don't know what to say about it because it's too basic. It's too basic. You want me to show some of the footage?
Sure. Can you respond to Walter Bison's video?
I doubt it. Should I?
Well, I don't know how to do the measurements myself, but it looks like he's using satellites. Which obviously are corrupted because satellites show a sphere.
Yeah, I have no idea what he could possibly show. I mean, I've been there. Have you ever been there? Shit's pretty flat. It's called flat. I don't think the shape of it should be in question very much. Did you watch this? Are you just throwing it out there, or do you have an opinion on it?
I couldn't follow all the measurements. So I don't know how to do that, but it looks like there's a hump on that
it does look like
observation, which is to say that like the Earth is a toilet paper roll. It just kind of humps around,
Mm-hmm.
Though if you took that hump, if you will, and followed that diagram, it wouldn't get you around the globe. It would put you in some kind of spiraling effect.
Mm-hmm. Well, let me show you what it's like when we were busting out some lasers here. This is at the exact spot you're literally where your center screen on your arrow is if you click play, on the thumbnail. This is the same thing. If you were to look at my screen, it's the same location that we're starting from. And you could see marked out here on a map. Can you see a map on my screen?
It looks like a highway.
Right.
80.
All right. Yeah. So the 5 mile, you can see the beginning point here. It says West Start Point, which is roughly the center of the screen on your thumbnail. And then you can see that we're starting here to set up a laser by driving 5 miles and seeing if we could see each other still.
Can you play the video?
Yeah, here we go.
How long is it?
Just a minute or two.
It says 34 minutes.
Wow, you're smart.
Now, were you there with this green laser?
Was there the next day or that night. I was not there for this. I was there for this.
I'm just checking. It's all good.
We did the railroad tracks after this, the next day. So this was a dry run for the next day, so we could prove the readings and such. What you'll see here is really fun to watch. This is the laser not hitting you, and a lot of people think that we can't tell when it's hitting us. And you could hear it, you could see it scoping around as we guide it in by phone, and the difference when it hits you is remarkable compared to seeing it go next to you. And that's what people
so my understanding is that you see how it scopes in the sky like a Batman effect.
Yeah.
So it's pointed up. But when you see the light on the water, over the water, that means it's hitting your eye. Am I right?
Yeah, so that's what we call
that would be level.
And also, since we're seeing the source, we can really assume there isn't much bending. There is a divergence. It is a wide beam, and it may be encircling us here in its entirety, 20, 30, 50 feet. I'm not sure. Could be more. But that doesn't mean that when you're not in that cone, in that beam, that you're not seeing the source. You can question whether we're seeing the source when it's Batmaning. And we can, but that doesn't mean it's hitting us. I can see the source, but it's not hitting me.
Okay, for this first observation, I guess it's 18 minutes.
No.
What's the observer height in the distance?
They're both on a tripod on the ground, standing there, 5 feet, 6 feet. And now he's going to move out. Well, that was 5 miles. He's going to move out to 10 now.
Okay, so the first was 5 miles.
That was 10. We sort of briefed through it too quickly, but that was just. Let me back it up. So 5 and then 10. We saw it again. Talking.
Now, as a curiosity, what kind of laser is that? Do you know the power of it or the rating of it?
I could find out, but it's nothing special. I mean, nothing dramatic.
Because that laser has to cut through that atmosphere, so you need a powerful laser. Yeah. A little tiny laser is not going to do that effect. You need a nice one, to cut through all the atmosphere.
All right, so here it starts. This is again the 5 mile. 5 mile. Sorry.
Now, can you send this whole 34-minute video and I can save it to my files?
No, it's like pay-per-view on.
Oh, we gotta pay for it. How much is it?
$1 on Vimeo.
Vimeo? How you say it?
Vimeo.
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 Can you put the link?
It's also on Rockfin if you got it.
Put the link for me.
Okay.
Now, is this 10 miles with the green laser?
Right, 5 miles. This is still the 5 again. Now they're going to 10.
Mark, after hiatus there, this is showing 10 miles, and there is the altitude 4206, so it's very close to the shore, and the time, of course, coordinates around the.
So this is almost 3 years ago.
Yeah, I hate to say that. It's true.
It's all good. I mean, we probably should update it, probably do another one. 2023.
Very bright.
So anyway, I like this because this is a gradient and it shows 510. Now we're going to 17.5. There's a picture of your laser. If that means anything.
Now, is that laser enough to blind you at close up?
Kinda. Yeah. It's got more. Yeah. It's got radiation that comes out of it, so I don't know what that. It's not. They're not. You're not really supposed to handle them without wearing goggles and stuff.
So this is 17.5.
Yeah, that's 17.5.
Yeah. Oh yeah, definitely.
I think they shoot a return here.
To think that whole, like where that laser is coming from, and all those lights, all that's supposed to be around under the curve. To think that's all just displaying as if it's just straight over a planar surface.
Not to mention the city behind it, right?
Yeah. I mean, some of that, I don't know. I haven't, you'd have to calculate the height of some of those buildings or whatever, but. And that laser's like reflecting off the water. I mean, it's incredible. It shows how it's, just like when the sun does that. When it makes a line. It's so cool. It's cool. You have that footage of the laser doing.
Actually, there's no water here. There's no water. This is all dry land stuff.
So that's all reflecting off the land?
Yeah.
Wow.
Why did you not do the water shot?
We went here specifically to work over land.
Yeah.
Okay, so the lake was just one shot.
The lake was a different time. That was Salton Sea. This is Salt Flats.
Bonneville.
Yeah, but the other stuff was at Salton Sea. It was different. The 27-mile test. Now that wasn't a great, but that was just the dry run, really, because the good stuff was on the railroad track.
And that's coming next.
I think they're gonna do a 30 dry run still. This is still the dry run. The day before. This is on the road, not the tracks.
You're right close to the red lights.
So it's not really a hit, but it is what it is.
It's probably banking through the atmosphere at that point. You can see it, but it's kind of fluttery.
Right. All right. So then this is the railroad tracks 35, and it's less dramatic. It's less dramatic because the gradient was a better test, really. So this is us setting up on the railroad tracks on a 35-mile stretch, and the batteries were all frozen and wouldn't work, so they had to put hand warmers on to get the batteries to even function. So that was like drama, like, you know, in the Antarctic expedition.
So the batteries can't be cold, otherwise they won't turn the laser on.
Yeah, that's the kind of thing you learn over time. You know, you don't know.
Oh, cool! I see two lasers. I see a green one and a purple one.
And this is outgoing from this position, and I'm on the other side, so I'm under the arrow. The green is the side I was on.
What are these train tracks? What are these red tracks?
That is the red switching yard.
Wait, back up. How much curvature is in 35 miles? Go back. What number did it say? Right there. It's 720 feet.
Now remember, if it says that, you got to chop it in half, because 720 feet of drop would mean only 310 feet, or 350 feet of obstruction. In other words, half of that would be obstruction.
But is that right though? I've heard that argument. I'm not sure. It says here 5 feet over height. No, that's meters. Okay, let me get 5 feet over height here. Hang on 1 second. Dan.
So do you see this the red in the tracks is the lights up above. You see the lights, the like switching yard lights?
I don't get what you're saying. Yeah, it says here on the Earth curve calculator, the DIS bid says at 5 feet over height, 35.89 miles, there should be 730 feet of hidden curvature. So why would it be half that?
Because that's generally a calculation for the drop, and the curvature would be between you and the observer.
But do you know what that means? Because I'm going to send you a picture of my phone, which actually has a picture of the hidden height below, and I'm going to tell me if this is wrong. Okay.
Well, I could go to our notes and see what we're claiming. Hang on.
I'm gonna put in this in the live stream if I did it right.
Let's see.
Is this not correct? Now, I think I get it. You're saying that it's bending 350 feet on the left side, and then it hits to the point, then 350 feet on the right side if it was a sphere, which is 702 feet. But that's saying this is wrong. That tells me that this is wrong. They're saying 732 feet of curvature of hidden height.
Okay, according to what we're claiming here is that 600 metabunk refractive hidden in feet would be 630 feet, and the bulge in between 210 feet. So basically,
But how do you get that number though? That's only 1/3 of 600. 200 is only 1/3 of 600.
some bullshit they call quadratic something. I don't know.
Are you trying to put in refraction?
That was calculated into this. I put it in chat.
But how can you put refraction in there? Because you don't know what the refraction comes from the nature. You don't know what the refraction actually is over 35 miles.
Well,
How could you?
But it's a different calculation than the mathematics of the Earth. So the Sagitta, I think it's pronounced
Sagitta.
Right, that's 214 feet. So
can you explain how you get that? Because I just posted above what you posted. You're saying a second, you posted something here. I just posted the Glober calculator, which, unless you're telling me it's wrong, it shows 732 feet hidden height.
Okay, so just say it again. What's the number?
732 feet of hidden height.
And they said 720 on screen, right?
Yes.
And my data from the organization of this says 630. So I really don't know. What we know is it's well over 200 feet.
Well, hang on.
The size of the building should be in the way.
Slow down. It says 630 in the meta book, but then it says 214 in the Earth bulge Sagitta. So what is it?
Well,
that's 1/3.
You're not understanding the center point would be a high spot.
And
that's the Sagitta. The high spot. It's the overall drop creates the high spot. The overall
okay,
drop.
let me explain it how I'm thinking about it. You tell me what's wrong, okay? If I'm looking at a building.
What's wrong is you're not letting me finish this video. Yeah.
Well, we can finish the video. Go ahead.
You had a question about the tracks, which is frozen on here. Why it was red.
Why are they red? Yeah.
You see the red lights above? Do you see the tower?
Yes.
And what's also hard to see is there's a tiny red light at the end of the tracks, which is actually a halfway point that him and I were targeting the lasers at. Literally, we were at a halfway point to reach this. So this is almost over here. Let me just show you. So this is.
But why are the tracks red?
Because the light is hitting them and bouncing down the tracks.
Got it. Okay, good.
But it's not the laser. It's the natural light of the thing. Now, why aren't they straight is a pretty good question, huh? Optical illusion of some kind.
They look like they bend up, right?
They're wiggly, left and right.
Well, the train tracks could be wiggly, right? They may not be.
Probably not. That's probably light waves.
I got it on this camera.
All right. So anyway, that's the excitement of getting that shit done. But I'm convinced we had line of sight down a place called the Salt Flats because it's salt, because it's flat. You know what I mean? Like it's
okay.
Flat.
Okay. Are you done?
Yeah.
Okay. Cool video. Thank you. This video said 720 feet of curvature. Right.
Hey, listen to me. How much bread and how much meat was on my sandwich isn't really the question here, right? Is like there's enough meat on this sandwich to be constituted a sandwich. There would have to be over 200 feet obstructing the observer from the observation. Like the 2 points, right?
Right. So that debunks the globe, but I want to get more exact. Is it 600 feet? Is it 200 feet? Is it 720 feet? What is it?
It depends on what calculator you're using and what you're putting in leniency for conditions, like standard refraction. So in other words, the 720 that you came up with the straight calculation has been modified by Mick West Metabunk refractor down to 631.
Is he a flat earther?
No. Hell no.
Okay, so 631 only takes off 100 feet. Now, is that because of refraction?
That's because of predicted standard refraction.
Okay, so according to that, there's 600 feet of hidden height, no?
No, of overall drop. Not hidden.
600 feet overall. I'm trying to wrap them around. 600 feet overall drop. I get that. So you're saying the Sagittar is not bad.
I don't know. You'd have to look at the numbers I posted for you to get in, to understand it.
Well, do you understand? Can you explain it to me?
There's nothing to explain, man. If there's an overall drop, the observers are both over both sides. That's why they wouldn't see each other. So the peak between them is the Sagitta. The peak between them.
I don't get that because a drop means a difference.
They both experience drop. Both of them. Both points. So the height difference would be between them. Not the points they dropped at. It would be the apparent obstruction between them. If you distributed the drop between them both, you understand now? Put the middle.
No, because this is a Sagittarius 200 feet is 1/3 of the drop, of the total drop. That doesn't make sense to me. Now you can a little bit.
I'm going to have to look at your little tiny thing now. What in your diagram that says Earth calculator? There's a center point called the horizon. That's
let me go to that. Hang on one second. Let me go to that.
That's the Sagitta. That's the Sagitta.
Let me go to that. Hang on. Okay.
The horizon in that diagram.
That's the Sagitta. Correct. Continue.
Well, the overall number, your 720, is from point A to point B.
Okay, the 720 is from the blue to the red, but on the surface.
Yeah.
No, because that would be the actual Sagitta. Let me see if I can draw it. Hang on.
Don't bother.
Tell me I'm crazy. Let me see if I can draw it.
Try and phrase your question as a question so I can answer it. You're not.
Well, I'll show you.
Are you questioning all the Earth curve calculators?
No, I'm questioning what's the actual what's the hidden height? That's what I want to know. What is the actual hidden height? Yeah.
212 feet. 214.
Hey, watch this.
214 feet.
But I want to understand that. Right here, let's see if I can do this right. So from A to B. Shit, it's not gonna work.
But what are you questioning? Do you realize that we're seeing beyond any obstruction? That there is no obstruction? Whether it's 1 foot, 5 feet, 100 feet, 200 feet, it's not there. We're over 200 feet now. It's a pretty big object.
Let's see here.
So what are you calculating, man? I mean, I'm not going to listen to this for too much longer.
You don't have patience for me, Dan, and I understand that.
All right, so I mean, can you phrase your question in the form of a question so we can give you an answer in generalities and not numbers?
I just did a little diagram. It's the best way to know how to explain it to you.
Okay.
I'm going to post my little thing in the Discord, and you tell me what's wrong. Okay. So, I took the calculator that I was using that apparently you're saying is not right. Okay. I posted a picture. So, this basic above is 5 feet observer height, 36 miles. guesstimate. It says horizon is in 2.7 miles, which I'm not looking at that. Hidden height 732 feet. So that means to me is what's in the way between observer A and the distant object observer B, let's say a laser, should be 720 feet. You're saying it's not. You're saying the Sagittarius is less, but I don't know how that is. I did two pictures. One is just a quick drawing of a red line from left to right, which is obviously off. It's not straight. But
Are you trolling?
the one on the bottom.
Are you trolling?
No,
You're trolling me, right?
No, I'm not. The one on the bottom.
Why didn't we work on the picture we already had on the screen? What was wrong with that one? What did you do?
What picture did you have on the screen?
Well, you had this before.
You don't like my artwork. Okay, let's go back to yours.
It doesn't mean anything. It doesn't mean anything.
I want to find the hidden height. That's what. You're just saying 210. How you get that? If you can't explain it, cool. Just say you can't explain it.
Okay, I'm told it's some sort of quadratic equation. I don't know what that means.
Well, weren't you going to post something? What did you have?
214, man. 214. There would have to be 200 feet of something between us. Earth.
Okay, but Dan, see now let's just listen to me for a second. What if I want to question that, right? How do you get 214? You can't tell me. Is that what you're saying?
Yeah, I read it to you.
But you can't tell me how that works. Can you?
I can explain how it was explained to me.
Right.
Something called a quadratic equation.
This is why, because if we're going to be regulated to only 1/3 of the curvature that we would expect from the globe, that amount of curvature can be explained away by refraction. It's 3 times easier now for them to explain away the missing height, the missing curvature with refraction.
Yes, sir. Yes, and
because your own video said 720 feet,
and we still blow it out of the water.
Hang on a second. Your own video says 720 feet, and now you're telling me it's only 214 feet.
Oh my God, you are confusing the overall drop with the hidden height.
Right. That's where I don't get it. That's where I'm stuck.
Because if you look at point A to B, they both disappeared equally on both sides. So it gets distributed in half at least. Right? Can you see that the obstruction point being the middle isn't as far as the overall length from A to B? You can see that, right?
Well, it bends up and then it bends
down.
down.
It's called horizon in your picture. It's called horizon in your picture. You could see that that's only half of the number because that's the part blocking your vision. The horizon is what's blocking your vision. So the overall drop isn't what's blocking your vision.
Okay, well then, if it's half, then you're telling me it's a third. So which is it? Yes. So forgive me if I'm confused.
It doesn't matter because we exceeded it all. So you don't get it. It doesn't matter what number you decide, it still wasn't there.
Correct, Dan. For 200 feet, what the globe is going to say, which is what they told me, they're going to say, well, there's 1%, 1% divergence, and that's refraction. There you go. They just get to save their globe.
What is 1% divergence? What does that mean?
I don't know what it means, but what I think it means is if you take 35 miles and you bend it 1%, 1% of 35 miles, whatever it is, 10% would be 3 miles. They're saying refraction bends 1%. Actually, I think it bends 1% over 69 miles. Is that right? I'm not sure, actually. But the point is,
that's not That's not
what
refraction.
percent refraction
That's
gets you
not,
back to a globe? This is what the globe is telling me. I
not
don't know
a,
what the hell they mean by it.
it's not a refraction number. That's a number based on dividing 24,901 by 360 or something.
Yeah, probably.
That's not related to the bending.
Well, do you know? Okay, let me ask you this: do you know how much refraction bends?
We know what Metabunk said. It took it from 750 down to 631 using standard refraction Glober math.
But why are you even using a Metabug globe calculator?
We're not. We're using your reference, Glober reference, so you know what the fuck we're talking about, so we don't get accused of ignoring refraction. We're including refraction.
Well, that's fair. That's fair, actually. At least they should agree on the calculator.
I mean, we're trying to do everything we can to be
Yeah. So your video
of regular science, right?
Your video shows, even with the Sagitta, which I'm not exactly sure how that works, but I'm gonna give it to you because there's no point arguing.
Can you go back to the gradient, because that's more important? Wow, we see it at 5 miles. Wow, we see it at 10. Wow, we see it at 15. Wow, we see it at 20. Wow, we see it at 25. That's doesn't require numbers. It's just like, there it goes, there it is. There it goes, there it is. There it goes, there it is. You can throw all the numbers around you. We're only claiming line of sight. We're saying, hey, we see it. You can play with the numbers all you want.
What about the excuse that you're looking at for example, the purple or the green laser? You're looking at it in the sky. It's pointing above your head, and you're seeing it. What about that excuse? You heard that?
In order to follow even the curvature of the Earth numbers, we'd have to be pointed up to have it.
That's a good question. Do you point it up or do you point it flat?
It's generally leveled to begin with. But I've done it 10 miles handheld, so it certainly wasn't leveled.
Here's a question for you, because I've never been in this big experiment. Can you get the laser to bend over distance?
Only
Or is it just straight?
Only with weather. No, not only with weather. If you hit the water, it'll bounce up. You could bounce.
Okay, that's not what I mean. That's not what I mean. I mean bending, curving over and above the curve and curve on the other side. Have you got it to bend at a distance? Rufus will have it has big spiel about you point a laser upwards and it'll curve because of what the fuck? Whatever the dude that uses two mediums to bend light.
Snell,
because of Snell, it'll bend in a rainbow. That's what he says.
Yeah, we just haven't gotten him to demonstrate that.
But have you seen that happen?
No, we've demonstrated the opposite.
Yes, I have not seen that happen. I don't think that happens. I think they're taking it and they're saying that, but you can't get a light or laser to curve like that at a distance. And the only reason they say it happens is so they can hold on to their globe. Now,
actually, the only reason they're saying anything is because we're achieving line of sight. They're saying that's impossible. Therefore,
refraction.
Yeah, therefore anything.
No, you're gonna give me this link. I can pay the money. You're gonna give me this link, please.
I'm trying.
Either Venmo or I'd rather have Venmo because I don't like fucking another one. I don't like the other one.
Where am I gonna find it? Let's see. Vimeo. Rockfin is the other.
I don't like Rockfin, but if you have to, give it to me.
No, that's all right. Flatlanders on Vimeo. That's it. Give me a sec. I don't know where I have it.
Yeah, take your time. Yeah,
well, I mean, I have it in a graphic, You could copy.
The big deal I was having, Dan, is because I've been for years saying, going on this world calculator saying this building should be hidden. But if I'm using the Sagittarius, it's like a half or a third. That's completely different.
Yeah.
That's why I was thrown off by that. So I don't know what's right. I have to look at it a little more.
Hey y'all, have you ever thought about that with the stars? It's a little bit of a change, but it's been bugging me. I wanted to ask anybody if they thought about this. Like if you're at the equator and you're looking at Polaris, which is sitting on the horizon, and then somebody's antipodal to you on a globe, and they're also looking at Polaris on their horizon. So they're exactly on the other side of the ball, and they're looking 0 degrees or say 0.1 degrees, whatever, sitting on the horizon is Polaris. Now, as they go, pretty much, so everything in between doesn't even matter. I mean, it's like there's no star over the Earth, basically. So if they take and go one way, like east to the next star to the right, and the other person goes to the left, antipodal, then there's nothing in between. Like there's a whole Earth, the whole rest of the hemisphere.
It would have to be flat.
It doesn't make sense. There's no star in between. Like, in other words, everybody could be around the equator looking at their horizon and seeing Polaris.
First of all, is it Brian?
What's in between them is what I'm saying. If I'm on one side of the globe and you're on the other, and we're both looking at the horizon, it's Polaris, and all of our friends are holding hands at the equator all the way around their globe, and we're all looking at Polaris on our equator. What the fuck is in between us? Nothing. There's no other stars in between Polaris and itself. You know what I'm saying? So that leaves the whole rest of the globe with nothing in between, with
Brian,
no stars above.
Hang on,
Brian,
I don't think that that observation is even possible.
Yeah.
To see, let's say from Egypt on the equator, seeing Polaris, and then go on the other side, which is what South America. I don't know where it is.
We'll say South America, but we'll say we're all
I don't
on a
think you
floating barge.
can both see. I don't think you can both see Polaris.
So we're all looking at Polaris from the equator, like on a floating barge. It's at our horizon. So there's no stars in between any of us.
What are you talking about, Brian?
If we're all looking at Polaris on the horizon,
if you can see Polaris, you all will see Polaris. It'll be the
I don't think you can see it, Brian. I don't think that's a possible observation.
No,
it is absolutely possible. Brian, you just got to think about it a little bit more, man.
I've thought about it. I understand the explanation and all that, but it's a crazy thought, though, ain't it? Though, Coach, like if we're all at the equator looking 0 degrees, seeing Polaris just peeking its head up over the horizon, but there's no stars in between every one of us. We're all holding hands, cutting a circle around the equator, looking at the horizon, and we're all looking at Polaris. So what's in between us all? No stars.
Okay, if we're all laying down, or go ahead, Zach. Sorry, go ahead, buddy.
Not 0 degrees; it's 90 degrees.
No, 90's overhead. 90's overhead.
But he's talking about if they're on the astronomical horizon. If you're at the equator and you're looking at the astronomical horizon northward, then you basically see Polaris.
Everybody holding hands, Brian, around the globe will see her. There's nothing in between. What do you mean nothing in between them? You're all seeing the same star. What's wrong with you?
Imagine there's a giant Christmas tree in Yankee Stadium, posted up by a crane, and we all hold hands laying down around Yankee Stadium on our backs outside of it. That'd be like if we were on the equator and looking at the North Star, and there would be a Yankee Stadium in between us.
Brian, you understand that, Brian? Everyone in the Yankee Stadium looking up at a Christmas tree in the center of the stadium. We all see the same star.
Yeah, I didn't need that, bro. I understood it before the explanation.
No, you don't
but
understand.
My point,
you don't understand anything.
Yes, I fucking do, Zenny. Just because
Just
because I'm giving you a thought experiment. Why do you start talking right when I go to respond?
Yeah,
dude?
you gotta stop, dude.
He's fun though.
God, I try to
Just
respond.
Gaslighting, the endless gaslighting, dude. You gotta stop, dude. If you
Yeah,
have
my
like
only
something
point
to
is this.
offer, if you want to bring something, like bring a point, don't just come in and be like, you don't know anything, you're an idiot. It's just not. It's not productive.
Well, he made the it almost it was a little dense. He talked about
Dude,
holding
I
hands
understand the
underneath.
That's not the
explanation.
topic of the live stream. Is whether you think someone's dense. That's just not the topic.
Okay,
If you
I
think
got
that,
it.
keep it to yourself, or just write it in your diary or whatever you want. I know,
I'm gonna
whatever.
write it in my diary.
I understand, Zanuck, that it's infinitely far away, dude. I understand the explanation, and you didn't have to. I didn't need the Christmas tree explanation. Maybe some people here might have. I doubt it, but I didn't. It's just a thought experiment that if we are all at the equator and we're all looking 0 degrees, and we all started cutting through the globe, then there'd be no other stars in between all of us, because it's because of the infinite distance. But still, we're using these stars to map the globe. It's just a thought experiment, dude. It just seems kind of weird if you think about it like
Now
that.
you're cutting through the globe.
Huh?
Now you're cutting through the globe too.
Yeah, like if we started getting closer to each other,
Right.
there's nothing in between, and there's no stars in between us.
Why? Why do you say that?
We
I
just
could just see
every
Zanuck every day. Dear diary, today. You should do that every day, dude. You should do
I
it.
know, right?
Yeah.
Dear diary.
And then when you come in here, you'll be all relaxed. You'll be like, "Hey guys, what do you think?" Be ready to have some actually
The day I called
groundbreaking
Brian,
discussion.
that was a box of rocks. I was really
I've read
angry at my mom, and I took it out on Brian.
I've read
But-
Zanuck's diary. You can make a
But
movie.
here's the
with it,
thing: I
too.
could go anywhere in the solar system, and as long as I don't change orientation, Polaris will follow me everywhere. I'd have to go like about I think 30 billion miles or something to get a 1 degree change. I forgot.
Sure.
I forgot the exact math, but as long as I don't change orientation. But that messes up when you think about how y'all worked y'all's system. Like I said, if we're all looking at Polaris, there's nothing in between us. It's just to me, it's a cheat. Putting the stars a distance like that away, it's kind of a cheat, because then you want to use perspective with the stars deviating. For like if we're looking like the picture Travis posted, we're looking southwest from where he's at, like say in California, and Gio made a good point earlier. We're at one orientation, yet we see the stars like maybe following that orientation overhead, but then the further south we see them start to straighten out. Then further south than that, we see them start to curve the opposite way. So from one single orientation.
No, we don't.
That's only
Yeah, we do.
Brian.
Have you ever done a
No,
star
no.
trail? You most certainly
Yes,
fucking
I
did.
have. I have, and I've. When somebody make that claim, I used Stellarium and made a series of star trails.
Stellarium.
Yeah, that's right. So I can make a series of them, just to
Brian,
show
can you
that
see the chat?
it doesn't matter where you are if you're looking at the same spot in the sky.
Yeah,
Did
Brian,
you
can
see?
the chat?
Did you see Travis's his Sandra 1, Sandra 2?
Yeah,
You didn't see them? Okay. What do you think he faked? Do you think he faked them?
I forgot what that one was about.
Well, when he showed the star trails, he had a 4-hour. That's all my camera will do too.
Yeah,
is
it was
4
the
hours.
two cameras with two cameras, and he had one of them with a tree was there or something.
Yeah. Well,
Brian,
I'm just
can you see
saying. In one of them pictures, he was pointing.
Go,
Anyway,
ask
he
him if
made
you see
one.
the chat.
You know what? Forget the Sandra 1, Sandra 2. But he made a star trail video from California, looking southwest.
Brian,
And
that's all
you most certainly do see the stars straighten out.
I remember that. Listen,
Brian.
Zanuck, hold on a second, Zanuck. Brian, just respond to Zanuck for a second, and then I'm gonna remember, because I remember I made something for this. So just
Brian, the star trails.
Here's
Zanuck for a second.
Say something, Zanuck.
Star trails are perspective. I just put a video of what happens
Okay,
on
perspective.
equatorial
Very
mountain,
good.
how the stars do not move with respect to one another at all. You have to
Very
have
good.
circular paths and these divergent, convergent type of paths with photography, depending on the wide angle lens and how long you leave the exposure on for, and how these things happen due to perspective. They are not indicative of a deviation of any angular position with respect to you observing those objects in the sky.
What are you talking about? They're not of any angular. So you're saying that that the stars at latitude 30. I mean, your latitude ain't curving.
What do you mean my latitude ain't curving?
It's not curving around the North Pole.
What does that mean?
I don't have to correct north if I'm going along a latitude. Don't I got to correct north, or else I'll deviate off the latitude?
No, you just go straight north. You'll go north.
No, if I'm going east or west on a latitude, don't I have to correct north?
Not all of them.
No, the north of the equator. I described 30
north.
north.
Of the equator. Okay, I got you.
Don't I have to curve? Don't I have to?
That has nothing to do with what I'm talking about. Star trails have to do with perspective. If you guys still
Okay,
haven't
so
gotten
you
that
want
yet, have you?
perspective, and you want
Oh my
infinite
God.
distance. I don't think you're entitled to
No,
both.
that's not what we're talking about, Brian. We're talking about what they look like on a camera. It's like looking at a horizon, why it looks curved. Horizons actually are flat. It's a flat,
They don't look
straight
curved.
plane between you, your feet, and the horizon.
Yeah, you can take a
flat, but it looks
You can take
curved
any straight edge and hold it on the horizon, and it won't
because
be
of
curved, bro.
photography gives you perspective. There has to be some distortion. It gets the entire observation on that one particular frame, so it looks like it curves, but it doesn't, because think about it. The angle down from your eye to the horizon is the same no matter if you spin 360 degrees around. So why is it curved on the film? Because it's perspective.
Okay, so if I'm at 30 north and I'm looking east, am I going to keep my eye on you if you travel away from me, or am I going to have to tilt to the right?
If you're looking at me walking away from you and I'm going east,
Yeah. If you follow that latitude, ain't you going to have to keep correcting north?
yes, of course.
Okay, so it's not just perspective. The latitude lines do it also, and that is indicative with the star trails. Okay, and the point is, yes, if you look west, it doesn't say nothing about a camera.
You're not traveling across. You're not traveling across the sphere, Brian. You're looking at a star in the sky.
Oh, I know that. I know we're not traveling across the sphere, Zanuck.
Brian, you're not listening. You're just not listening. You have it in your head, and you're holding onto it like a pit bull on a bone. You gotta let go of the pit, let go of the bone. Look at the picture I put in the chat. It's time lapse of an equatorial mount. Those stars do not change at all. What you see is what you get. Those stars do not have angular position change with respect to one another at all.
You know what I just realized?
So if I go east, then I don't have to turn right to correct. Then Zanuck, because if the star is following a latitude and it doesn't turn, it's not gonna circle your globe, bro. Get it? That's why equatorial mounts back to back make smiley faces and frowns. It's not like a big giant smiley face, but it is a smiley face.
Have the sky fixed and the Earth rotate underneath it, so you can see what really happens.
Anyway,
there's no perspective.
well, let me make my point before you interrupted me. Travis pointed his camera. I was almost done with my point. It was a little bit long, but so Travis pointed his camera southwest, and it showed the stars start to straighten out. Okay, whether we'll talk about what's causing it after, but fact of the matter is, his star trail showed the stars doing what you'd expect overhead. But then as he got further south, like toward the equatorial stars, like toward Orion's belt, it straightened out. It quit turning, and then the stars beyond Orion's belt started deviating off the other way.
Of course.
Okay, so that's three different from one orientation. That is three different different directions. And if I'm the one moving, there's nothing that really would cause that, right?
I just gotta let each other. You know what I realized about you guys? It's not just true about Brian. Hold on. Oh, there's a sex scene playing in the background, so just ignore the sex scene. But yeah, you guys are both like dogs, you know that? Like trained like dogs, like hard to train dogs. I hope that sex in the background is not getting you guys going.
Well, I was hoping you respond to the time lapse.
No, yeah, I do. Yeah, I have a response. I'm sorry. Brian, I implore you to measure the angular separation of the stars throughout the entire night, because Zanuck's exactly right. The relationship, the angular relationship, like the angular distance between them, never changes. And in the star trails, you get that observation, but that's obviously not what you observe. So it has to be all those still shots. But if you were to take any three stars, like Orion has stars on the equator, above and below the equator. Take their angular, use a sextant, take their angular distance every hour throughout the night, and you'll see that it doesn't change.
SunCalc does the measurement for me. It shows the when you or you could go to any like you go to Stellarium, you could go to Time and Date. I chose SunCalc. It shows the turns, and Yeah, it's measurable. It's not much, but it's measurable, and it does exaggerate it a little bit on time and date, but still, it's measurable, and it's the same thing if you have back to back.
What angle does it give you?
What? I don't know. I haven't did the freaking measurement.
No, I'm saying what type? What was
it?
it? No, I'm saying what is the name of the angle? Like, was it? Because the angle I'm talking about is angular separation, like the angle you would get if you had a sextant.
You talking about the azimuth?
Well, if that's what I think that's what it's giving you is the azimuth, right?
Yeah, I mean it doesn't matter. You don't got to measure it to discuss it because you could see it.
But that does matter
in real life or on one of them programs.
Brian, if you use a sextant and you actually measure the separation between them, it doesn't change.
Okay, how about I can just see them separating in real life? It's not much, but stellarium shows it.
If that's the case, then try measuring it and see if your intuition about it is correct. Because that's the only way you can really get an answer.
You want to believe so badly, but you're not thinking about it.
Dude, y'all are denying dude, Jeremy's gonna have a fit, dude. Because we discussed this, y'all denied this shit forever. Now y'all are back to denying it again. So now we have to start all the way back over. You don't got to interrupt, bro. I'm almost done, bro. You ain't got to interrupt. So now we got to start all the way back up. Please, dude, let me just finish my sentence. Now we got to start all the way back over into giving you demonstrations and showing you, and getting quotes from the Royal Astronomy Society and all this other, showing that it is what we see and measure. We're all the way back at step one, but we'll do it, and watch y'all squirm for a day or two.
Brian, hold on, Brian. How is anyone denying it when I'm simply imploring you to make a simple measurement? Just take a measurement with a sextant, like a simple angular separation measurement, right? I mean, it's very easy to do that, right? With a sextant or some sort of use a protractor for all I care. Use a protractor and take a straw and put a straw on each object, each of the two objects, and do this for different sets of stars in Orion. It's not asking for much.
Yeah, I'm good with that, but just give me some clarity, because you said you're not denying it. So I just would need clarity. So do you acknowledge the gentle separation at the equator?
I observed the visual separation in the star trails, like the divergence and convergence that it appears to be doing. But it's when you measure it, you see it's not actually doing that. That's just an optical. That's an optical phenomenon you get, especially by doing star trails.
Zanuck, do you acknowledge the visible separation at the equator? Just want to make sure we're all on the same page, so you acknowledge the separation.
He does. He knows that it's a visual.
Well, he was saying it's the camera, bro. He was saying it's the camera. I'm talking about with our eyes, though.
I said that too, though. Your eyes will not see star trails.
No, but our eyes will see the separation, though. We'll see the deviation.
Your eyes will see what perspective will. It's same thing as if you saw a railroad. If a railroad was coming at you, it would appear like it was converging. I mean, it was diverging. It would be like it was diverging. Is what I meant.
So you can't say the camera's causing it because it's opposite of perspective. We see things converge in the distance while the stars diverge. So you don't call it perspective, bro.
That's because we're looking at it inside a celestial sphere.
So it's not the camera then, right?
No, it has opposite curvature.
It's not like railroad tracks either, right?
No, I mean it is like railroad tracks. It's just not the same thing, because railroad tracks, obviously they're gonna converge in the distance. But if you're inside of a curved, if your observation is inside of a curved, perspective like that, it's gonna obviously diverge as it moves away from you.
So if we put up two big old sticks. Let's say we put two sticks up in the ground, and we're kind of right up under it. Not quite, but we're just about. We got two 20-foot tall sticks that are perfectly straight rods. We'll call them, and let's just say they're apart. They're separated apart by about 45 degrees, something like that, maybe 30 degrees, whatever. We back away just a little bit to where they're separated 30 degrees or whatever, about 10 foot apart or something like that. We back up till they're 30 degrees apart, and we line up a star that's like overhead where the sticks are pointing right up to them, and we watch them go off in the distance and follow the stick kind of down. Okay,
It's not the same thing, Brian.
Huh?
That's not the same thing. I just told you why it's not the same thing.
Okay, but anyway, what we would see if it was perspective, I was going to say is we'd see them converge like railroad tracks or anything else. But it's funny, the stars do the exact opposite. It's kind of weird.
It's not. Yeah, it's not that weird. The thing you're talking about, perspective, that's flat. That's like a flat perspective, right? Now take the perspective of a celestial sphere from the inside, which is we get that observation because we're rotating, right? So if you imagine those lines, like we were in a clear sphere, you put those same what do you call them, railroads, whatever it is, poles above our head, but they're following the celestial sphere. And now imagine what that would do. As they move in the distance, they're going to diverge.
Okay, here's where I say it's not perspective, is because if I'm where Travis was at and I'm pointing southwest, then perspective would pretty much have them converge or whatever, but they would all perspectively do the same thing if they were infinite distance away, I would think. But they take three separate paths.
Yeah, you have to remember though, we're not seeing them. We're not seeing the light come from the stars to us as in a straight line. Like that's not what we're seeing when we see star trails. When we see star trails, we're seeing the light from the star over time as we do a rotation, which is basically like seeing a circle around a celestial sphere.
Did you hear the info that B-Ball Earth is Life posted? Where he played. I had all that stuff recorded, but I never made a video. I just pulled out a clip of him saying that in leveling, geodetic leveling, they only go 50 meters. They don't go 200-300 meters. Then he made the point. He pulled up the vertical datums and with the triangles on the ground and shit, and he played the part. Like if he'd understood, he'd have never played it. But he proved, the guy even in there said that we know triangles add up to 180. So we use a little bit different math, and because we're on a sphere, we use a little different math. And I was funny that he played that part, like he proved my other point. That
I mean, what was the guy saying? What was the guy saying that he's quoting? Or that was?
I pulled it and made a video out of it where B-Ball is full of shit.
But tell me the truth though. Did you pull it and like that was all that you pulled? Was that guy just saying that?
No, that part of the video, yeah. I mean, this is what B-Ball pulled. I'd pulled it previous, but I didn't play that part because this is before we were talking about spherical excess. But it just so happens B-Ball, in trying to prove that the geodetic surveyors, he's trying to call me wrong, saying that because him and Bob are trying to do the elevation shots over like 12, 14 miles, and I made a comment that we don't do the elevation and leveling over them distances is ridiculous. Well, he switched, he stopped and switched to a different part of the guy's sermon or whatever, the guy's testimony and stuff, or his whatever demonstration, and played where they shoot like 80, 100 miles. But that's with the horizontal triangles, that's with the when they're mapping, the triangles.
Spherical excess.
Yeah. The where they're trying to work out the the latitude. You know what I'm saying?
The arc. The arc. Yeah.
That was pretty dishonest right there. I thought. Why did he just play the guy? Why is he trying to act like I'm talking about leveling? He knew I was not talking about them type of shots because them shots is line of sight, and it's not enough refraction to make a big difference. But he did play the part where the guy said that we know that the triangles add up to 180, so we apply a different kind of math to it. The guy said it flat out.
I'd have to see the video because, like I said, I'm not calling you because you're an honest guy most of the time, Brian. Actually, you're a pretty good guy, to be honest. And but I can't take anybody's word.
I don't think B-Ball was being
about
dishonest
some
either.
else.
I think
No, yeah, I don't
he
think B-Ball's being
misunderstood.
dishonest either.
No,
Well,
but he was
that's what I'd
being
like to see. I'd like
dishonest
to see
in
the
some
video,
of it. In some of the video, he was, bro. Trust me, blatantly, but not that part. When he keeps acting like he keeps doubling and tripling down, acting like he did what I challenged him to do, when he already admitted on Jose's like yeah, that you did say for me to go after the sun went down, but then he has a conversation like and says that he completed my challenge and went later on in the day. I never why would I tell him to go later in the day, bro? I keep telling him over and over, go after the sun sets at night. I put it. And he keeps tripling. And then after a couple months goes by, he goes back to that claim that he did what I challenged him to do and went at night. He keeps saying it. I went later in the day like Brian challenged me to do. He keeps saying that. I never, you know.
You really got B-Ball around the mind, brain. You got B-Ball around the brain, dude. But
Well, I do like it when somebody makes a video about me, man. It shows me that, you know, at least somebody's paying attention to some shit,
I'll make a
whether they
video
agree
about
with
you.
it or not.
Hey, I was going to say just real quickly. You know that you live in an opportune location because I've seen your house on the maps, on the camera even. But you live in an opportune location where you, B-Baller, and I actually live close enough to be in a great circle. We live in a great circle route from each other. So like you and B-Baller.
Where are you at?
Don't worry about it.
Like, not exactly where you at. I'm not asking for your address, but like, what is your what's your latitude and longitude, or what's your fucking what?
I'm nearby, man.
Ain't you in Texas?
Yeah, I am. I am.
Yeah, okay.
Yeah.
So
No,
you're in
I'm
between
close.
me and B-Ball. You're in between us.
Yeah. If you do a great circle from you and B-Ball, then I believe so. This seems kind of weird. No, actually not. That would be correct. Yeah. Yeah. So if you do
I
a
think
great
I'd have to
circle
go a
from
little
you
bit
and
north of you,
B-Baller.
bro. I think I had to go a little bit north of you to get B-Ball because he's south on a globe.
Yeah, no.
It's
Yeah.
backwards.
You both are south of me. Yeah.
So that means we'd have to go north to get to each other. We'd have to pass north of you.
Yeah. All great
Don't that
circles.
sound counterintuitive, bro?
It does, but not when you realize that all great circles cross the equator twice.
Well, if you're right in between us, but then we obviously have to go up and around you.
No, not well up and around me. Well, let me see. Like I said, a great circle. Oh shit. Anyways, a great circle route from you to Hawaii. Let me think about that real quick.
Dude, did you
Actually,
ever
it's
see
hard to think about.
the directions to Kenya, bro? That was interesting as fuck because it's not right dead on the equator, right? But it's almost dead on the equator, but it's a little bit above it, dude. So when I was drawing my directions from the 80th meridian, like I had to go north from where I'm at 80th meridian, and then I went further north.
Absolutely.
And I had to even go steeper north to get down toward the equator. And then I went down south of the equator, and I still had to go north. And then it wasn't until I went way down south that I had to go, and then I had to go south to get north, dude. It was like, dude, it just blew my mind, bro. It was so counterintuitive, bro.
It's counterintuitive at first, but if you remember a few things, then you always remember it as a case. Because like I said, no matter what, any great circle route is always going to cross the equator twice, and the extreme end of your, so the extreme halfway point of your journey is always going to be at the exact same latitude, just on the opposite side of the equator. So if you live
it, dude, but it was kind of counterintuitive, like to me.
Yeah. No, it is at first.
To me, if I'm going to the equator and I'm north of the equator on a ball, so I have to head a little bit. I have to head a little bit north, right? But then that should mean that if I go south of the equator, then I should have to head slightly south. But it just so happened from that location that I had to still keep going north. It was weird.
Depends on which side. Like if it depends on where you're going.
Yeah, it does. It depends on where you're going to.
You are. Yeah. If it's closer, if it's or like which direction you have to go to get there, and whether it's further north
and
or
how
south
far away you are and everything else, bro. It's all. But I was pointing out, and it was to me, it's still funny. I could look at it a million times and laugh because then when I went west of Kenya, it was like almost opposite, dude. Like then I had to go south from the north to get to Kenya because of the distance. It was like the distances didn't quite line up, so it just changed everything, dude. It was just fucking funny, dude. Real funny. I could look at it 100 times, I'd get a chuckle. Not saying that's not the way the ball's designed, but it's fucking so counterintuitive, bro.
What did you use to to take the Great Circle route.
Google Earth. There's a couple factors. Like I said, Kenya is just slightly, just a little bit above the equator, man. I think that was enough to throw one of them off, like the one from the south. If it had been a little bit below, just if it would have been like 100 miles south, it would have changed my direction. Like I would have had to head south then to get, not completely south the whole way, but I'm saying I would have had to start off in a southerly direction, southwestern or southeasterly direction instead of a northeasterly direction. The fact that it was just a little bit above the equator changed it. It was just crazy to me that just that little bit of fucking. So if I'm heading to Kenya, or just a little bit above Kenya or a little bit below Kenya, it just changes everything, bro. From where you're at, it's like in your straight line distance, it changes everything. And then some spots it doesn't do shit hardly. It still would be the easiest way to make a model, I don't argue that. Like, as far as even being a flat earther, I would still agree that modeling it, the practical way to do it would have been with the longitude, latitude, and just taking the celestial sphere and setting it on Earth. Even if that meant not being able to make a flat map with the right distances, it's still going to translate a lot easier, just keeping the distance feasible. Yeah, keeping the distance feasible, because there's no way to put whether it's a dome, whether it's a perspective. If the Earth is flat and we're looking at a celestial sphere for whatever reason, whether it appears that way, whether it's actually curving, we're not going to be able to map it tried and true, distance-wise, on a flat surface if it's appearing to us as spherical or measured.
What do you think about the fact that we can do that? That's why we use that.
Then we just curve the ground. Yeah. You just curve the ground.
No. I'm saying we use the celestial sphere as a one-for-one representation for the ground.
Yeah. Like that's what I'm saying. I'm agreeing. That would have been the easiest way to model it. I agree.
I know, but why would that be the case?
Like I said, it'd be impossible to model it'd be impossible to model a hemisphere onto a flat surface. The distances would be wrong, right?
Yeah, but I know, but why? I know that's my point, though. Is in that case, you wouldn't be able to do that. Then you wouldn't use the stars to navigate, because it wouldn't be.
How else would you do it? You're missing. I mean, you're kind of agreeing with my point, like.
I'm agreeing with your point, except for the fact that I don't think you realize your point is kind of contrary to what your position is.
Well, do you agree that if, let's say the star, let's just say hypothetically that it's a literal hemisphere of stars over top of us, literally.
Yeah, okay, right. That's
literally, and perspective is reinforcing it, and so no matter what I do, I'm going to see the sky as a sphere, and it's going to measure as a sphere, and I'm not going to be able to use the stars to make an accurate map as far as distances on a flat plane, right? If they're all arced.
I agree with you 100%. But the problem with that is that we already do use the sky as a celestial map. I mean, as a map of the ground, and so that's why it throws a question. But go ahead, no.
I'm just saying that's how you made the
Let's
model.
say the problem with that is, like, for a sphere, don't you need like the radius value for the sphere? Like a sphere, and that radius value would be the distance to the stars for that, I guess, hemispherical thing above you. That's the only measurement a sphere has is how big its radius is.
No, but in this case, you don't need that. You don't need that though. Like in the case of celestial navigation, you wouldn't need a radius value.
Right, because you just need the GP, but you wouldn't actually know the actual dimensions of the sphere though, because that literally the only measurement a sphere has is its radius.
Okay, yeah. Okay, so you're right though, because if you're talking about the radius of the Earth, then yeah, to do celestial navigation, you do need the radius of the sphere that you're on, because that's going to represent the amount of miles per degree or whatever.
But Noah's right. It would be the zenith. Our zenith to every star measured would be the same as the radius.
No. Oh, what are you talking about?
It would deviate over distance because, like I said, it's a flat plane, so it would have to deviate, and it
Yeah, I
does.
know, right. So then that's what this is my point, though. You're right what you're saying, and you're also right that you couldn't do it. We couldn't model it on the flat plane. You're right that it would not be it would not be the same distance, overhead, and it would not be the same angle per distance. Like you said, it would get wild that further out. But these are all contrary to your position, to your ultimate position. That's why I agree with what you're saying, but I don't understand why you don't go a step further and realize there's a reason it doesn't work.
It couldn't work. The best we could do would be an AE map.
Sure. Why do you think that's the case? And why do you think even though that fact's true, it's still a useful
Because it's
tool
flat, and we have a
map?
celestial sphere. That's why.
Yeah, I know, but if that's the case, then we either A, wouldn't be able to use it for navigation, or B,
We can.
would be able
I got a whole
to
series
map
coming
it.
out, bro. It's so much easier, bro, using AE map than a globe. It's fucking ridiculous. And I figured out the
That's
hands
stinking.
and what they're for, bro. We've been bamboozled.
The equation that I had to use to make those or the ellipses of equal altitude is extremely difficult, man.
Yeah, but that's the last step, bro. That's unnecessary.
Yeah.
Like there's
It's
so
not
much
unnecessary?
information. There's so much information that's there before you try and calculate the distances over long shots, bro. I'm talking about all the practical navigation and the fucking bro. I don't want to give it
I
away
know.
yet.
No, I know one. Let me see. Tell me how close I am. Okay, I'm gonna guess, and you tell me how close I am. You're not concerned with doing trilateration with 3 stars. You're gonna do a cheat mode where you find your latitude first. You find your latitude, and that's much easier to do. And from your latitude, you really only need 1 star. Is that right?
Or the sun. Yeah.
All right, so yeah. I know.
Yeah, I mean that's a given. That it doesn't matter what we're on. Whatever map you're. As far as latitude goes, yeah, that's easy. But I just anyways, I gotta keep you a little bit in suspense. But yeah, you're on the right track as far as there's no. That's the last step as far as the math that pretty much are getting a little help with and stuff. It is fucked up, but that's the last step. There's so much practical information in the almanacs and stuff that translate that are so reasonable. And the distances, in the most part, for the most part, you're going to know your distance just by how high the star is above you. You know what I'm saying? Like you're going to have a good idea before trying to exact it in. To me, the directions are wholly fucking more important than distance. Because like I said, I'm not going to crash into rocks if I miscalculate the distance and it's a little bit further or closer. As long as I'm on the right path, I'm not going to run into them rocks that killed me. It's the directions that killed people, bro. I'm not making this series to prove flat Earth or nothing like that. You could call it evidence, yeah, whatever. I mean, anything you could use as evidence for or against. But I'm just trying to show some practical values, practical uses, and the ease of usage for on the flat plane, and maybe possibly some of the origins. It may have conclusions that are. You're good.
Practical Navigators, his YouTube channel.
Yeah, I've seen all that. I've seen
Yeah,
all. I've watched everything they have to offer.
I'm saying, yeah, it sounds like you have because you're saying practical a lot. But yeah, you notice that he had a full set of hair, like a beautiful, mane, and then like at the end of the videos, end of the series, he's like bald as fuck.
And dude, he's like got the most stress-free life in the world, bro. He's like drawing circles on fucking islands. You hear the waves and shit with shells as his azimuths and shit, or
He
for
seems like
his
a cool.
GPs.
Seems like a cool dude, man. I watch all those videos too. Yeah.
He does look cool as fuck, dude. I'd love to go fucking anywhere with that guy, man. But also the one with the popular one with the ABC method, dude. I'm sitting here going over it. I had a discussion with Bacon earlier, and finally at the end he's like, "Yeah, it's wrong." He used like the tables from the Nautical Almanac, but the shit he posted is dead ass wrong, dude. I'm sitting here, and I grabbed my calculator, bro, and my fucking
ABC. What's that?
yeah, dude. Look at the fucking I'm like, what am I missing, Bacon, bro? The tangent of the fucking LHA. Over the tangent of the fucking GHA ain't fucking what he's got right there, dude. I've grabbed my calculator in case I'm doing something wrong, bro. And it's like, but then he found where it lined up and shit. Where I guess he might even state at the beginning of the video that the numbers are ain't lining up completely.
You're talking about the method to find the point on the three circles, right?
What that to get to azimuth? The ABC method to get your azimuth. Your local azimuth.
What is that?
It's the ABC method, bro. You just said it.
I got that part, dude. I can say ABC. I understand it's ABC method, but
I don't got it memorized, bro. I got to look it up. It's
okay. But you said it's a method to get your azimuth.
The tangent of the Hold on, I'll get it for you real quick. I got it right here.
Yeah. The only one I know how to do is the trilateration.
What, the Haversine?
Yeah, I can do Haversine.
Yeah, but what people are failing to realize is most of this fucking math is with a laid down circle. Not all of it. I'm not trying to say all of it, bro. Okay, so don't put words in my mouth. But are with flat triangles. You know what I'm saying? A lot of the math is flat triangles. And
I don't think there's any triangles at all, actually. But yeah.
Oh,
I mean, just yeah.
How can you have sine and cosine without a triangle, Kosher?
It's fairly easy. I mean, if you have a circle and you
gotta have a 90-degree triangle, right?
It's based off of 90-degree triangles. That's
right, bro.
Yeah, but
it has to be 90-degree triangles, bro. Or there is no sine or cosine and tangent, right?
I know, but all the measurements in celestial navigation are only the measurements of one single angle. You're not using two angles. You're not using two angles. I guess there's an implied 90, right?
Yeah,
but you're only looking for the other angle.
To know the dimensions of a triangle, you need 3 pieces of information. But if you're using cosine, sine, or tangent, you automatically, one of the angles is going to be a 90-degree angle because it's a 90-degree triangle. So all you need is 2 additional pieces of information.
Yeah, right. But in the case of celestial navigation, as I said, you're not concerned with any other angle. So the 90 is already implied; it's not necessary, and then you're only concerned with one of the angles. So I understand. I understand. You're right. There is an implied triangle, but it's not necessary. There's no triangles involved. That's what I'm saying. There's no triangles involved in the measurement. But you're right. It is there.
Okay, it's basically A over B. Hold on. The A part that I was talking to him about was the tangent of the latitude or the declination, whatever, over the tangent of the local the LHA, right? The local hour angle. Okay, but then B is the tangent of the declination over the sine of the LHA. Right. And like I seen the guy put in the video like the numbers. I didn't realize it at first because I'm double checking these numbers, dude. And I must have wasted 20 minutes. Like I pulled out the calculator like to make sure, like because these science calculators a lot like they're fucking tricky, dude. And they're hard to use if you don't know. And I'm really kind of learning. But and I pulled out the fucking the calculator like the complicated calculator. Texas Instruments shit, and it ain't even lining up. And I didn't see in the guy's shit where he said the numbers don't line up. Like he was going off the tables, I guess. But until Bacon pointed it out, like right at the time I was realizing that he said, don't go off the numbers. But hey, it pissed me off because it's like this is a fucking tutorial, and then you should make it clear, crystal clear, You know, he just stated it one time or something. But I guess he's off the hook. But still, if it's a tutorial, man, use the right fucking numbers. Don't use the incorrect math if you're trying to teach me something, dude. It fucking bothered me.
Well, I don't think he was using incorrect numbers. I think he was he was, because there's videos where he adds in the corrections and all that kind of stuff. See, when I do social navigation, I don't fuck around with the corrections. I just measure my angles. I measure my angles
Oh,
in
this
a
ain't got nothing
more
to do with the
correct way.
correction. Okay, tell me this then. Okay, I'm gonna give you a quick problem. Okay, what is the tangent? The tangent of 43 degrees, 35.9 minutes. You might want to write this down. So it's it's the tangent of the latitude. So the tangent of 43 degrees, 35.9 seconds over the tangent of the LHA, which is
Wait,
230.
hold on. You said 43 degrees, 35.9 seconds?
0.9, yeah, seconds, yeah.
That doesn't make sense.
I
43
mean minutes.
degrees.
I'm sorry, dude. I'm sorry.
Okay.
Minutes.
No,
Minutes.
cool. 35.9 minutes. Okay.
Yeah, very sorry, dude.
No, that's cool. It makes sense now.
Okay, and over the tangent of the LHA, so over the tangent of 235 degrees and 39.8 arc minutes. Almost said seconds again, dude.
Yeah. So good. But okay. And so that you said that's a fraction. So it's tangent of both of those.
Yeah, just so form? Divide it, whatever. Divide the.
Okay. Give me a minute.
Anytime it's over, that's what I'll teach anybody who's like trying to learn anyway. Most people don't give a fuck because they'll never use it, and I don't blame them. But like anything over means divided by. So anything of is times, and anything over. So if they say blank over blank, that means blank divided by blank. That's all it means. So if you see a slash or like even a fraction means top over bottom. I mean top divided by bottom, basically. If you want to put it in decimal form, you just divide the top by the bottom, right?
Yeah, there's like certain words that you like difference is another word. People often think it means division for some reason, but anytime you hear difference, it's a subtraction problem.
Yeah.
I mean, let me do this for a second. It's gonna take me a second.
Yeah, all right. Just use a fucking calculator, dude. You ain't even got to do it by hand.
I'm not gonna do the tangent by hand. But
what do you want to do? You want to know the tangent of 43.59? Is that what you want?
No. We know that. I mean, no. Yeah. Well, you too. So it's the tangent of 43 degrees, 35.9 arc minutes over the tangent of 235 degrees, 39.8 arc minutes.
Divided 43.59 tangent 0.95.
That'd be for 43. Yeah. So, but over the other.
Divided by. He said, "What do you want? What's the LHA? Sine 235? No.
Yeah, hold on.
What do you want to do with 235? Brian, what do you want to do with 235?
Hold on, I'm gonna tell you. It's give me 2 seconds, bro. 2 seconds.
Coach, what is a 235 degree number? What does that mean?
You put that at the bottom of the fraction.
The bearing, right?
So the first number was at the top of the fraction. Second number is at the bottom of the fraction. Take the tangent of both of them.
What is the second number you're trying to get? It's just a bearing.
Oh, 230. He said it was the. I think he said something with the LHA. Actually, I don't even know what the point of this measurement, what this calculation is for.
235 sounds like it's a value on a compass.
Well, yeah, it sounded like he said that this is to determine your azimuth.
Yeah, well, it's step
What do
one.
you do
It's
with
step one. Sorry about that. I was gone for a second. I had to do
What do
something.
you want to do with 35 azimuth?
Remind us, Brian, what's the purpose of this whole measurement again?
Yeah. Okay. Well, I just wanted to double check and make sure I'm doing that. I'm not doing this wrong. Or I'm like missing something here. I'm double checking, and that's why I figured. So it's the ABC method. So it's the tangent of the latitude. It's step A. It's the tangent of the latitude over the tangent of the local hour angle. So what I gave you first.
How do you
was
get a tangent of 235 degrees, Brian?
What do you mean? What are you talking about?
How do you get a tangent of 235 degrees?
I mean, I just know off the top of my head what some tangents are. Like, I always just keep in mind that the tangent of 45 is 1. So, like, I can estimate shit in my head without having to do all the math and shit.
Yeah,
And I could keep it in my head that 45 is like 1, and then so 89 is like I think 50 or like 59 or something, and it drops pretty quick. But I just keep it in my head like about what it is, so I got an idea of what I'm talking about. Without doing the math, I at least have an approximation of
Well, no,
what
you
the
had
fuck
it right for
what I'm
tangent
doing.
of 45 degrees. You had it right for that. What is tangent of 235? What do you even mean by trying to find tangent of an azimuth?
It's the tangent, bro. It's the fucking. That's the definition. What are you asking me for the definition of a tangent?
No. I asked you, what are you trying to get by getting a tangent of 235 degrees?
That's what I'm working on. That's what I'm working on.
No,
Okay.
it's just a simple question.
Bro, why do you always come in and complicate everything, dude? Like, I'm literally double checking my work against Kosho's work. You know, I figured we'd include you, dude. I didn't think you'd poison it, dude. And you're already confused me, bro. Poison and fucking like asking for definitions of words where the word kind of is the definition.
Why are you trying to find a tangent of an azimuth?
Because it's part of the equation, dude.
They're
It's
talking about
AB.
celestial navigation, and he was talking about the ABC method in celestial navigation with Kosho, and he was describing how you do it, right?
I'm still curious too what the ABC method is meant to be
So
finding.
you got your
it's for to get the azimuth
9.95 divided by your 1.4. What is that value going to get you?
That's what I'm asking you. That's exactly the numbers I got. Okay. And here's what the guys got down. No, I want to hear your answer first. I'll post what the guys got down. Okay. I don't want you to just agree with this motherfucker. It's not what you just said, because that's what I came up with. Just think about that. What you just said right off the bat.
What numbers did you guys get?
0.95 divided by 1.42.
No, what number did you get though? I didn't get it like that.
I got it written down over in another room. It's like 0.6 something.
We have 0.65.
Yeah, 0.65. Okay, now this guy's got. You on board with that, Zanuck?
But how does that give you an azimuth?
No, it doesn't. That's step 1. And I'm telling you what this guy has for his answer on step 1 for this tutorial. He's got. And I tried radians too, and it doesn't work. Okay, he's got 0.35. He's got 0.350. It looks like, and then a couple other decimals, but 0.35. That's wrong. And it's not inverse. It's not nothing. Fucking ain't radians. Like, dude, it's just plain as day, written right here.
Let me ask you a question. Did he do something with his local hour angle before he took
No, he gives
the
it to us.
zenith? Huh?
No, he specifies it, and he's got it written down. He filled in it. Yeah.
Let's say for instance
I'll post it real quick so you can see what I'm talking about, and it might.
Let's say for instance he changed it to a latitude instead, like he converted it to a latitude, and then did that. I wonder what he'd get.
Well, he's being pretty specific on the math. He fills in
the equation, Brian.
He literally puts the 43 degrees over the 235 degrees, or the 238 degrees. You know, with the decimals. I'd say that he literally fills in the blanks and puts them down. And so,
why don't you show me what you were trying to do there?
Yeah, I'll show you real quick. Okay. All right, I'll show you.
Let me play around with some conversions and see if maybe you get that value from doing some conversions.
Ah, do you see it, Zanik? Because I posted it. I'm not sure if it's showing. It's not showing up for me.
Not seeing anything.
Let me try something else. Okay, hopefully this will show up. Come on, show up, show up, show up. Oh my God, dude! It goes through to 100% and then it cuts off. It's gonna take a minute and then it'll come through.
Dude, I got my own AI model, dude.
Oh, this fucking work, dude. Does this sometimes? It's like stubborn. It shows that I posted something, but it won't show the post.
So
I'll
we
DM you,
already
man.
broke one.
Wait, it won't do it either. It still won't come through. It takes a minute. It'll
Still
pop
hard.
up. But what? Ridiculous. Try one other thing. Won't post, man. Nothing I do will post. Fucking weird. I give up. Anyway, I'm just glad y'all got the same answer as I did, So I think, but like I said, I think the guy was going off a chart or something, but and then B is so B is, let's see. So it's the ABC method, and that was A. A is the tangent of the declination over the hold on, over the tangent of the LHA, and then B is the what does it say? Okay, B is the tangent of the declination over the sine of the LHA. And then, C pretty much is if they're labeled the same, then C is hold on, is just adding them together. If they're different, then you subtract the smaller one from the bigger one. Like if the north and south are different. If they're both north or they're both south, you add them together. And then you convert that to your azimuth. Coach, are you still there?
I am still here. I converted. You know what's weird?
How do I write down inverse? Do I write down inverse tangent tangent minus 1? Or tangent slash 1? How do you write down?
Oh, yeah, you can do that. You can do that. You can do that.
Or tangent slash 1?
No, the like to the power -1. I mean, there's just a couple ways you can do it. Get out of there, logo.
Okay.
Ways you can do that.
I wish I'd have paid more attention in high school, dude. Like, I'd have been interested a lot more in shit if I'd have knew I'd be in these arguments later on. Like, I wouldn't have had to do so much catching up, dude. Like, I'm still trying to catch up. Like, dude, I made good grades in all these classes, but dude, it was so fucking long ago, dude. And I've literally only used the basic geometry since, Luckily, I even used that in what I'm doing. Or I wouldn't have remembered any of the shit. And so it's been, trying to re-explore the learning days, dude. Because it's just shit you never need, bro. If I didn't have a lot of pride and want to understand things, I wouldn't even have worried about half this shit. But it does come in handy, once you learn it in this debate.
Yeah,
but
that was in general, dude. A lot of stuff we learned about in here in the interest of answering questions or debating or whatever. I learned a lot of stuff.
It pushes you, don't it?
Well, yeah, dude. Like all of us who, like me, you. I mean, including you, but like Ruhif and Bacon and Eggshells. Like we all actually took the time to learn. We could all do celestial navigation.
I did too, man.
We navigate. That's what I'm saying. Yeah, so I said you too.
You don't learn it in a fucking hour. I'll tell you that right now. That's why
I had to watch all.
Okay.
No, I had to watch all Practical Navigator. I mean, that was at least one of the things I watched and I saw.
Yeah.
I had to watch so many different things just to
I
get
recommended to my flat Earth buddies, dude. I was like, look, if unless you really are gonna try and dive into this, and I don't recommend that you even, or if you never plan on using it, it's almost worthless information. A lot of worthless information to try and remember, unless you find it practical or you're ever going to use it, dude. It's a lot.
Dude.
It's a lot, dude. There's a lot of different factors.
It's like being a grown-up Boy Scout. It's like you learn this shit and you never know when it's going to come in handy, dude. All this kind of stuff,
dude. So I imagine on either side, this debate does push you to learn shit, dude. We'll give it that.
Everybody, cool. Scott Beach has been in college for 17 years. I did the math. He'd been in college for 17 years, and he said the same thing I said. Is that in this community, he's learned more in the couple of years in this community than the entirety of college.
Yeah, I bet, because it pushes you toward the practical. You know, I mean, we throw so much practical shit at you, and then so you got to learn it technically. You're gonna try and give answers or debunk something. You want to know it inside and out, and
The problem.
so you're
The
gonna
problem is
take
not
a deep dive into
practicality.
every topic, right?
But the problem is not practicality. That's why people like Dave, allegedly Dave, debated an actual astrophysicist, and he still made astrophysicists look, wrong or whatever. Because it's not even just practical. It's not even that kind of practical examples. It's like answering. It's like being asked like the fringe of the fringe questions, like questions that would never come up in practice, or maybe would come up like once in a career. You know what I mean?
Well, their information is pretty fucking. I mean, they've learned so much, but they haven't learned any of it. They haven't came up with any of their own thoughts, dude. I don't agree. You know, if you really think about it, bro, you do. You know, as far as trades and all that go, and certain things, that's great. You know, you learn the trades, but you're not coming up with any ideas and shit like that. Like you're just learning what somebody's already discovered, dude. Like in this topic, we're right on the fringe of everything. We're exploring different shit, especially on the flat earth side, like trying to come up with ideas and models. It's thought provoking, man. This whole topic on either side, it's very thought provoking, man. And I know you get y'all thinking about shit like what if this or how that. Whether you agree with it or not, it's got to get you thinking, bro.
Sure. Even Jeremy's retarded fucking train questions. Plus, dude, the reason why some of us are in this. I mean, honestly, I told him, I said that's a pretty good question, man. But that's the reason why, that's where a lot of the appeal for me comes, because like I really like riddles, and I really like puzzles, and so it's just boring when you get like through every puzzle. It's like you've been through every puzzle. There's no new puzzles.
Right.
So it's like in this community, you get like the new puzzles like every day.
I get it. And dude, look at even Blue Marble Science. Like he'd have never done something like that at this, at this stage in his life. And it motivated him to build a fucking Cavendish, bro. You know what I'm saying?
Really?
Yeah, man. Like motivated you to construct a fucking and redo the Cavendish and shit, bro. You think you'd ever did that without this debate topic? You know?
Oh yeah, absolutely. I would have, Brian.
Well, sorry.
What? Flat Earth had absolutely nothing to do with Cavendish. Because honestly, when it comes to topics like that, I don't really give a shit what you guys think. You can think anything you want to. Go ahead. Up to you.
Sorry, I tried to include you, Blue. Sorry, man.
I wasn't out to try to prove anything to anybody. I just wanted to know how Cavendish was able to get that kind of result.
Because of what? Because of because of all the contentions thrown at you and all this other shit. You want to see it for yourself.
I'm awful fucking happy that you've told me what I was thinking, Brian. Thank you very much.
God, dude, what crawled up your ass, man? I wasn't even trying to be a dick, dude. Just trying to say that this topic.
Then stop being a dick and telling me what I thought and what motivated me to do what I did.
I'm trying to say that I'm trying to justify all your wasted time in here with us in a friendly way, bro, just to provoke conversation and shit and find common ground. And you're lashing out at me, dude.
I like to think it's not a waste of time, but that's because I like to delude myself. I know. I mean, you're always going to think. I mean, for some people, it might not be a waste of time, but for me, I know certainly there's been times where I was supposed to go out. I was actually supposed to go out with people. I was dressed up and everything, I stayed on, and I was just talking about this all night in gyms. I remember my friend was waiting on me. It was like hours. I was like, oh shit, I was supposed to meet up with him like 3 hours ago. The stuff we talk about here is it's too addictive to me. You have to force myself not to get on here just to get stuff done, and that doesn't work. So I'm gonna have to start forcing myself.
Did your girlfriend ever say shit like that? Like, why is that? Or your debating with flat earthers is more important than me.
Yeah, she says that. She says that a lot.
I'm so glad my
Or,
woman ain't like that, dude. I've been with most of
she's
them
like,
are.
she's like, talk to your boyfriends.
Yeah, comments like that.
She's been in this room and talked to you guys.
That's cool. That's cool.
She was undercover.
Bro, they always get, that when they do come in, bro, we're going to, most of us anyway, like Zanuck probably ain't, but most of us are going to give them the floor for the most part, hear what they have to say and give them priority, especially visitors and female visitors, We value what they have to say and want to hear their opinions and shit.
Who
So
was that one girl?
hopefully she was treated good.
Yeah, she was. She was. She's in the same mindset as you guys, so it was pretty easy for her to get along with you guys. Like she's in the same mindset. She's not flat earther because she doesn't think about the earth or anything, but she's in the same mindset.
It's weird how most women could care fucking less. It's so weird, bro. I'm not trying to say that for every woman. I ain't trying to speak for every woman, but the majority of them, like, they're, to me, dude, it's like, what is more important? What's there to even talk about if we're just gonna have a conversation? Who gives a fuck about anything else? Like, that's more important than debating our reality. To me, it takes precedence over everything else.
They'd say the same thing about something weird like kids or I don't know, dogs or something.
Yeah, it ties into
Cats.
it ties into religion. It ties into just your overall philosophy of reality itself. And cosmology.
Yeah.
It's all a big topic.
This conversation could take us anywhere. Well, at least not anywhere, but into the topics that I like to talk about, at least, like science, politics, the greater, meaning of reality, just that kind of weird stuff. Yeah. I hope it persists. I know some people don't. A lot of people don't. But I'd be sad if it ever went away.
I don't think it will, man. I mean, even if it doesn't fucking grow, the way, even if it slows down, compared to how it's growing now, it's still, I'm good with talking to the same old people pretty much. It's
Let me ask you.
exciting to have new points of view and shit, but still, I enjoy the conversations that have been going on.
Well, that's why I like them. That's why I like it as a medium to nurture that. But let me ask you a question: if it came out in some kind of way, like it was, I don't know, some way, something came out, and for
I'd
some
switch to
reason
the
this
ball.
evidence,
If it came out as mainstream, I'd be back
let's not
on the
say
ball.
you, let's say 95% of the flat earthers switch back. What do you think? Like, obviously, if that happened all at once, the community would probably want to persist. So, like, what do you think it would transform into? I guess. Like, what do you think it would focus around?
I don't know. I like
Like, or do you think it
questioning
would just
things, man.
dissipate?
Me personally, I like questioning things. If everybody thought it was flat, then I'd be probably arguing for the ball. But now, just opening up my mind to how complicated reality is. It's if I was a glober, like I would be thinking in terms of like idiocracy. Like that's where we're heading. Like if I was a glober and didn't understand, or if I wasn't one of you and understand, some of the good points we bring up and shit like that, I would think, damn, dude, it's idiocracy, like for real. Like people are getting to me it's beyond that. It's a great debate. There is no better fucking debate. I'm not sure I answered your question. Can you rephrase it?
Give me 1 second. I gotta grab something real quick.
Morning.
when I'm in here chatting and stuff or debating, I'm 9 out of 10, not always, but I'm usually doing something. I know I can speak for a lot of other people too. And sometimes I'll just sit down and shoot shit, but usually I'm doing something and listening and joining in, dude. I've done so much while on Discord, like just keeps my mind busy while, dude, I've planted a big ass garden, cloning some fruit trees, bro. I mean, I've built batteries.
It always sounds like you're fucking doing something when you're in here, dude.
Yeah, I made a spot welder, made a fucking, made 2 spot welders actually. I was seeing which one worked better. I found 2 of them DIY, and I've went over countless patents and shit. I've built a milling, like a ball mill, and I do so much. I get a lot of fucking good info too. Like, there's usually somebody in everything, even chemistry, bro. Like with Jay, like what you call it, gave me some good information, bro. Like on a problem I couldn't figure out with even chemistry, bro. Like he gave me some good advice and stuff. Jay Ace, I think that's his name. He's like, everybody's knowledgeable at certain things, and you could get some good advice in here about my diet, about chemistry, about making things. It's like there's so many different. There's such a broad variety of people in here, bro. There's a lot of information, a lot
in
of
this
practical
community
information.
in this community in general, yeah, there's a lot of people. I've met so many people. Yeah, I mean, ever since I've been in this community, so many people I've been blessed to, you know, have conversations with.
Like if somebody's going to do a patio and they're going to do it themselves or a front porch or something, and like they needed to know, like, how many yards am I going to need, bro? Like they could ask
I
me,
did
dude.
that.
Like, oh, actually, dude, a lot of the information's online and shit, but you know.
No, dude. You're exactly right, though, dude. I've done that so many times, especially, no offense, just in gyms. There's a lot of people with different specialties and stuff. And anytime because I had to build this wall, anytime I had to do anything that I know somebody in there has a specialty for, I can ask people, and you get questions. It's much better than it's better than asking ChatGPT, better than Google.
Oh yeah,
It's
so
talking to a
much
real
better, dude.
person. Yeah, talking to a real person who's actually gotten their hands dirty on it or knows what they're talking about. It's better than it's worth money, you know.
It's so much better, dude. Especially the fact that it seems like every area or every trade, every profession has its own lingo and shit, dude. And it's not always broken down. You'll get the answer, but you might not even understand some of it, some of it might be important, bro. Some of it might even be important, dude. And if you got a
Yeah,
person instead of the internet or a machine, yeah, it's way better. Like J Ace might have literally saved my health, dude. Like inadvertently, when I had a question about the how do I break down this certain this thing that I'm using for the batteries for the binder. Like it doesn't just break down with freaking acetone or something like that, dude. So I'm asking him. I was telling him what I was gonna do and all that, and he's like, "No, whoa, if you're gonna do that, bro, you better take this precaution and stuff, because it's like it might have been dangerous. Like I do shit in well ventilated areas. Probably wouldn't have killed me or nothing like that, but it might have. I don't know. It damn sure wouldn't have helped me. It's just good information to have. I usually treat everything I'm not familiar with extra caution, but still, it's good to know things that are blatantly dangerous.
I'm finding myself a bit confused by Bev's new series of memes. The real globe is reality. It's time to wake up. I don't know why. Is he saying he believes in the globe now?
You still a Glober?
I am, yeah, of course I am, Brian. I'd never
You
believe
seem like
in.
a contrarian, bro. I can't believe you're a Glober, bro. Like
I would never
most
believe
con-
in such stupid ideas such as flat Earth. So always remember, I'm going to be a glober.
most contrarians, dude, have an open ear for anything other outside of mainstream.
What does contrarian mean to you?
Skeptics, true skeptics. Not many left in the world.
No, it doesn't. Contrarian is not a true skeptic. A true skeptic is discernibly skeptical. What do you call it? What do you say? But not what do you call him?
You'd say a true scientist is
What'd
trying
you
to
call it? What'd you call Don?
prove everybody wrong,
Can't
right?
remember what he called me now.
Yeah, wait. What was the name again? What was it?
Contrarian.
A contrarian. All right. A contrarian is just arbitrarily plays devil's advocate arbitrarily. In most cases, just to be annoying.
Which I do, Brian. Often, if someone states something that I think is stupid, I will disagree, not because I care to disagree, just because I'm bored and it's fun. Yeah, so that's when I act as a contrarian, but I don't live as a contrarian. I'm not pretending Earth's a globe just to be against you. I actually think it is a globe.
Right, you're all up mainstream's booty hole. I get it, bro.
No, the globe is not mainstream booty. It's a cosmology that's been there for hundreds of years.
Mainstream. Can you say boogina? Can you say boogina?
You're just wrong. If you say the globe is mainstream bumhole, you're just wrong about what.
Like I mean,
just
Brian.
God, I'm
Brian,
just fucking joking,
aren't
bro.
they like? Okay, yeah, but aren't
Sorry,
they
go ahead, Nate.
mainstream
Sorry,
ideas?
Nate. Go ahead, bro.
I just want to ask, aren't they mainstream ideas you believe in?
Maybe a couple, man. I'm trying to cut down though.
Maybe a lot.
I'm trying to cut down.
Okay.
What about sun's hot? You believe that, right?
Maybe. I don't know, man.
You're not
Like
sure about it.
is a magnifying glass hot? Not really. It's but you could burn an ant with that bitch, can't you?
Hey, can you freeze your hand with the cold beam from the moon with the magnifying glass?
I was trying to get volts. That's a good question. I was trying to get some volts. Like I should be able to, if it's reflecting sunlight, I should be able, like I got all these Fresnel lenses and shit, and a couple little magnifying glasses. But I'm trying to magnify the moon because I should be able to get a reading on my solar panels, right? If it's reflecting sunlight, no matter how small of a reading it is, even if it's reflecting like 0.001%, like if I magnify it with the Fresnel lens. Why ain't it reading anything? Like, are y'all sure this is reflected sunlight? I'm just saying, it's not fucking behaving like it should be.
Have you tried that before?
Yes, that's what I'm saying.
The Globers can't.
Nothing.
Is it cold moonlight?
I haven't been patient enough to follow the moon on the water. I did actually initially get the Fresnel lenses to do that experiment. I bought 2 thermometers that like water thermometers, and I had the 2 stainless steel dishes. But the moon fucking moves, bro. So you can't just set it up and go away and come back. Like it's slow, but to keep it in point, you literally have to sit there and tilt it, and then you got to try and tilt it on 2. I just got aggravated. I was like, fuck it, dude. I never finished it.
Can you chill a bottle of wine, Brian?
Man, I don't really like
So
wine, dude.
You never finished the experiment.
No, I didn't. At the same time, bro, I watched Mr. Drive and Survive, and he went out into an open field with a couple good thermometers, and he just went right in the middle of a field, and he controlled for everything, and he pretty much proved to me, bro, live that it's there's obviously a little difference, bro. It wasn't as much as like heard, but it's a couple degrees consistent.
I think Bev's saying he knows Earth's a globe now. I know he doesn't mean it, and it's like a triple troll, but that's what he's actually saying in words.
Who?
Bev is saying it's a globe.
Yeah, his globe's different from your globe, though, man.
I know what. Well, how is it different? I'm asking him. Do you know how?
Dude, just like my globe's different. My globe don't curve like yours, bro. My globe don't have the curvature.
For?
I don't know. Everybody else is calling their world a globe. I'm just saying my globe's different from yours.
That means globular. It's from the word globular, like a big rock, a big bolt.
My globe ain't globular, bro. My globe's different.
Yeah, so you shouldn't call it a globe, bro. You'll end up sounding absurd like Bevis right now.
Maybe, but I can relate with him, bro.
What, pretending to get like? Why don't you just call it a planet, even though you don't think it's a planet at this point? Why don't you pretend it's in space and call it a planet in space, even though it's not.
Yeah, I think that's taking it a little too far, man.
Exactly.
That's that's a stretch.
Calling it a globe when you don't think it's a globe, that's a stretch.
Yeah, I was just relating with Bev. Like I understood where he was coming from. He's just
He's a
joking
liar,
around.
semantic nonsense liar.
He's insanely honest, bro. Ridiculously honest. Like he won't veer one bit from advanced simplicity, bro. He's like advanced honest, bro. Like
Oh yeah.
he's like me, dude. He can't stand lies, bro. He can detect bullshit from a mile away, bro. He's a bullshit
Great
detector.
way. That's a great way
While
of putting it, man.
bullshitting himself. Sorry.
Advanced simplicity.
There's an oxymoron for you.
Doesn't matter if you spot other people's lies if you're lying all the way through, does it? There's no point.
It's a definite
Hello?
maybe. It's a definite maybe, dude. That my brother used to laugh at that. Another oxymoron. But are you gonna go? It's a definite maybe, dude. It's like a definite maybe. That's where I learned what the word oxymoron even was.
Yeah, why is, because Blue said it, why is this phrase advanced simplicity an oxymoron?
They contradict the two words meaning. contradict
Advanced
each other.
simplicity. How does that mean?
It's like simply brilliant.
You're retardedly
Simply
smart. That
It's
doesn't
like
make
saying,
sense.
like saying dry water. I mean,
No,
make it
it's
matter.
not.
Is it
No,
like
it
saying
isn't.
it's a fast, slow? Fast, slow.
That's
Yep.
advanced and simple mean the same things, or they're antonyms. No,
They're opposites.
they're no.
They're pretty
Complex
much
and simple. How about that? We try that. Complex is the fucking
It's
most close.
an advanced, simple technology.
Fuck off.
Well, Blue said it, so maybe he could answer.
I did. I already answered.
I missed it, I guess.
I said it. The words conflict with each other. You're talking about an advanced idea that's simple.
I don't think they do.
Okay, well.
Can you explain how?
That's up to you. That's what I think. So
clearly, that ain't much.
Yeah, but thank you for at least your input.
You try and make a coherent sentence with using both of those words to describe the same thing. Give it a try.
So is it like a fast, slow? Is that what it is? Like when you're in bed? Like when want to please your woman, it's a fast, slow motion.
Well, I don't know. I will say I understand what it means. I'm not making a claim like someone else and then not building on his claims. So.
And you can replace anything like if it takes like 3 AA or 3 AAA, you could use like an 18650 battery. And basically if you have a charger like a bent power supply, then you could make it rechargeable like flashlights, little things like that. But like this headlight, like I got these and these take 3 AA batteries, and I was thinking about like just soldering on a freaking 18650, but do I really want like an 18650 like pressed up against my head all the time, dude? I'm not too sure about this one. Like I could make a, put a piece of plastic or something. But even with the Duracells or whatever, do I even want them by my head? I don't know.
You can have like an advanced, simple, like a chess move could be advanced but simple and elegant all at the same time.
Yeah, I've been thinking that through. It is
Yeah,
possible. It just
because Blue doesn't know about words. Like
doesn't usually
something like
work.
advanced would be is opposite is primitive or backwards. Not simple. Simple isn't necessarily primitive. Simple is just simple, and it's a word that he doesn't maybe understand.
But hold
So
on.
he
You can
thinks it's
have an advanced backward move. You can have an advanced backward technology that's advanced, but it's like crazy. That could happen. Like a psycho evil
things regressive simplicity, right? It's not advanced. It's a regressive. It's so simple. It sucks, right? Some things are so simple. They're great. You know what I'm saying? Oh, no? Okay. Anyway. Blue Marble thinks that's an oxymoron, but he is so.
it could be too efficient for its own good.
He's
Like a nuclear bomb works too well.
Yeah, those are opposite words. Nuclear bomb. What the fuck here? Somebody get an English degree. Jesus Christ.
School is out.
This is what Bev's new website says. Welcome, visitor. Everybody knows it's globe.
Yeah. Okay. Flat globe, that's an oxymoron. Flat earth is not an oxymoron. You think that the globe is the earth. The globe is a sphere because it's a ball that's on a tabletop.
What do you think globe means?
The globe is on a tabletop. Of course it's a sphere, but that's not the earth because you live on that motherfucker and the ball is on the table on the fucking thing that you live on. Anyway, you get that. Don't confuse a model for a thing that's real.
Yeah.
I think that's what that meme is about. Like people accept reality as the globe, so he's trying to work with children somehow.
He's pretending he thinks it's a globe, even though he thinks it's flat, or
no, he's not.
Or pretending it's flat still while saying it's a globe. Either way, he's totally confused.
Turn down, little man.
You what?
I turned your voice down so I don't have to hear really like the full.
Can you be so good
I'll
that
turn
you're
you down as well, Snacks. That would be fine for me, thanks.
That's
Can
fine.
you
You ain't
be-
value anyway.
Can you be so good that you're bad, like a porn star?
Look up Michael Jackson.
You've got flat earthers saying Earth's a globe.
So when you asked about red wine, it means you cleared a bottle of red wine, Godric?
Did I ask about wine? Oh, about the moon.
You were asking
I
about
was
putting a
just
bottle
thinking if the moon has cold light, like just like a practical use for it would be to chill a bottle of wine. That's what I would think. Just throw it out there. Am I right? Yeah, I like wine. I like Cabernet, Merlot, Chardonnay. I won't say no if you offer. Now and then I might have like a Shiraz from Australia. Do we have anybody here from down under?
Oh, hang on. I'm reading the site. Now he's telling Bev's saying he doesn't want people to think anymore. It's a fake glob website he's made. So I think it's like some meta troll he's trying to do.
If you think that could lead to dangerous consequences, if you think about it.
What could?
If you think it can lead to dangerous consequence.
I'm not offended by Bev. I'm totally confused about what he is as a phenomenon, what he's trying to get across to people. There's so much ego and so little sense.
How much
Sounds
ego do you
personal between you two.
Is Bev a Glober?
It's boring. Bev is a flat earther who knows it's a globe, who trolls himself for 4 years in a small cult online.
Are you a Glober against evil?
Yeah, I'm a glober.
That's Dawn.
Oh, okay.
Just means I believe that's a globe. It doesn't mean I wear a t-shirt or anything.
Not one of your brighter Globers, bro, but Glober nonetheless. I'm just fucking with you, Dan.
Well, but hang on, but it's the whole paradigm. Like, do you believe we went to Uranus with probes? Because NASA will tell you this is a scientific fact, but I'm like questioning that, right?
Probing Uranus. Some people are curious about that, though.
Because Uranus is so big, wouldn't it just like stick to Jupiter like a grape, like a bunch of grapes, and also Neptune?
Well, the methane really stinks on Uranus.
That methane on Uranus, man, that's the shit methane.
Oh. Toilet humor. What's your favorite
What are y'all
planet,
doing
Don?
for like the summer?
Of the round ball planets that you like?
I'm gonna go out flying night.
What's your fave?
You going flying? Where?
I'm going to the Lake District this month, and I'm going to the coast in August.
No. Which coast though? Like y'all are nothing but coast.
Yeah, just our local East Coast.
The Great Space Coast.
Space Coast.
Yeah, you can
Coast
drop
to
on your
coast.
Get on board with the Great Space Coaster.
Oh man, good song.
Remember that shit they had us? Off we go on the Great Space Coaster. Get on board. Step inside. Y'all remember that song, The Great Space Coaster?
You get your global programming.
Like a Sesame Street. Yeah. Had me thinking
Yeah,
about
it
planets when I was a little
familiar.
kid.
I watch that
Sounds
every
familiar.
morning, Saturday mornings. It's on before the cartoons. Obviously, I'm an early riser since I understand that cartoons are the most important thing in the world to me. Great Space Coaster. It's just like, maybe I'll have some cereal to this.
Dude, you got to remember, there's no GNUs with like good GNUs with Gary GNU.
Very good news.
So somebody at least remembers Gary GNU.
I think it could have been just as good as Sesame Street. I'm not sure. They didn't have a Snuffleupagus, but fuck it. It was good. The space coaster, like they get on the space coaster, they're on like a little roller coaster, and then they're just like cruising through space. Then they get to, do they get to Earth and then they have the show?
Yeah, I think so, man. Like they circle around planets and shit.
Right. It's like Sesame Street if we're like an asteroid with a bunch of kids there.
I think Sesame Street is like kind of flat Earth, and Great Space Coaster was the globe answer to that. Near,
So,
far.
what conspiracies were you guys looking into before Flat Earth?
Moon landing.
Okay.
Bigfoot.
Bigfoot. All right. How deep does the Bigfoot rabbit hole go though? Like, what do you have to work on? You know, it's just a few pictures. Some of them are obviously fake. Like what? Like how far can you go researching Bigfoot?
Look, there's 3,000 eyewitness Bigfoot. Okay,
There's supposedly a
3,000
skunk ape.
eyewitness accounts.
195 years.
The original
There's a-
video.
And is this like global eyewitnesses or just in North America, like in a specific part of
like
the
It's
country?
just random reported. They're reported. They're documented. They're told to authorities. They're
But
stories.
where, bro? Where?
Figures.
Like, did someone see Bigfoot in India?
Around Florida, bro. Listen, around Florida, there's like the Indians, the local Indians and shit, over closer like to the Everglades and shit. Recognize a skunk ape. Like I don't think it's in mainstream zoology, but
Skunk ape?
yeah, like it's not a conspiracy to them. Like a skunk ape that lives in the glades. It's rarely spotted, like kind of like the Black Panther. But it's something they recognize. They don't question it. It's in their culture. A skunk ape, they call it. It's just a stinky ass ape.
Okay, so this is Bigfoot as well. So Bigfoot isn't just seen in like
They call them
like
yowies someplace.
like the icy woods. You could find Bigfoot in Florida as well.
You can find Bigfoot right
I don't know
outside.
if I call it Bigfoot, bro, but I'm just like kind of tying that in, like you could maybe mistake it for a Bigfoot if somebody's seen one around here.
But like I don't know, that original Bigfoot video, even though it looks pretty like what? It's like if you just look at it again and imagine how it would be possible to fake all the things that are in there. The costume would have to be so well designed at that time period to actually.
Chirality. On a serious note, I think of that, but it's like a spiritual experience when people will see like something like they see an angel or a demon, something like that. It's like a supernatural experience people have. They think it's real because they're experiencing it, but it's some kind of shaman spiritual entity.
So it's not material?
No, I don't think you'll ever catch a Bigfoot or find a Bigfoot egg or a Bigfoot piece of shit. I think it's all like a spiritual experience, not different than a demon or an angel. People will have all kinds of stories of those also.
You heard of panda bears?
I don't really believe in Bigfoot, bro, but I mean, who knows? Anything that just doesn't want to be around man, any animal that doesn't want to be around man, can avoid people. Not if they're real abundant, but I still don't really believe it until I see the evidence for it. But I'm open to see any evidence. Let's say that.
I don't think it's a physical creature. No, I don't think so. I think it's a spiritual entity.
Okay.
So you can't take videos of it, huh? Okay.
I don't think so. I don't believe so. Now,
Maybe
you can see a spiritual entity, and you can smell them, and maybe he'll throw rock at you or some shit. But I don't think anybody's gonna get killed by Bigfoot or snatched.
But you can get haunted by one since they're spirits.
Haunted, yes. It's like a psychic attack, right?
Yeah, definitely. That's easy enough. We can test for ghosts. We know how to do that.